to deal with other things other than relational databases. Sometimes we develop customized producers for Kafka. Sometimes we developed customized Python processes. Also, those Python processes run on top of Kubernetes, essentially in pods. Okay, so this is how we ingest data to our data lake structure. So on the top, we have the storage part, and this is the only part that we did not migrate to Kubernetes. Why is that? Because S3, GCS, blob storage, all of those object storage services on cloud, they have already a lot of features that optimize usability and high availability of data that you put there. So for us, it did not make sense to migrate storage for Kubernetes. We know that we have today lots of great tools to store data on Kubernetes, but this did not make sense for us then. So this is the almost part. This is the only part that is not running on Kubernetes. This is service-based. Okay, so we have object storage, service-based, and this is where we build our data lake storage. Okay, so for processing, we mainly use Spark. Probably today, Spark is the most used big data framework today worldwide. You know, it's a great tool. It has the capacity to process terabytes of data really fast. And because it's a cluster engine, you can scale horizontally. So you can scale very easily with Spark and process huge amounts of data. So we adopted this as our standard, and we now run Spark on Kubernetes. I'm going to explain you how in a bit. Uh, Next, you have our serving layer. So we don't use data warehouse anymore. We work now with uh,
One of the recent projects that we have been dealing with is called CAD-CAM data, a project that's between Karau and Bistronic. This service is cloud-based and is multi-tenant. We wanted to containerize this software and have it hosted in the cloud. Apart from the software itself, the backend is a MongoDB, and also we needed a Mongo Express to be able to have a UI for the teams to be able to do any changes inside the MongoDB itself. This is a resume of what we wanted to do. Pretty much, this is the project itself. Our first approach was actually to use virtual machine Azure as every project starts. We wanted to use a virtual machine to do our testing and evaluate the infra, how well it will be in production with relation to being in virtual machine, how it will scale up, etc. So we went for a basic setup in Azure with a normal with a public IP, a VM. We went for managed disks to be able, if something happened to the virtual machine, to be able not to lose the data. Our logging solution also was linked to that, so logs can be transported from the machine outside for a development team to be able to view the logs. We containerized here our application itself, and we wanted also to make MongoDB and Mongo Express into containers as well, because we didn't want to deal with the actual operating system itself and its dependencies. We wanted our applications to be easy to deploy within containers. We had some challenges with this. The first challenge was related to scaling or scaling fast enough. As you can see, we had a couple of virtual machines in high availability, but as this service will be multi-tenant, our first challenge was to see how we can scale this up depending on usage. Not as easy in virtual machines as in Kubernetes. Apart from this, as we have the databases inside the virtual machine, each running in a container, we wanted a solution to be able to replicate the DB between the different virtual machines that are running, and with every new virtual machine that comes up to support a new load, we wanted this to have the exact same replication of the DB that's running on the previous machines. Another problem that we had was maintenance, that all the maintenance that had to do with the virtual machines, whether operating system updates, whether with deployments, whether with, like I said, with high availability. All these things had a negative impact in our test, on our performance testing and our CI environment. So we decided to go for, or at least to give it a shot to see how we can replicate all of this into Kubernetes. We already have several Kubernetes clusters running, and our development and production environments are running several of our applications. So wanted to give this a go. We have not used MongoDB or actually stored databases on Kubernetes before this. We have our own applications that are running, but the backend has always been as a SaaS in Azure, for example. So this was a bit of a challenge for us, and I'm going to tell you a bit how we went about the move from the virtual machine to Kubernetes itself. So our first challenge was actually we already had the virtual the image of the application in a container ready. So moving that to Kubernetes was an easy task. Having the images already being produced in our own pipelines with our own Docker files and pushed to our ACR. So having those images deployed to the Kubernetes cluster, which we already have in our ACR, was not a big deal for us. That left behind obviously database and MongoDB on the virtual machine. The most scaling that we wanted was actually for our front end, for our main application, let's say, because that's what's going to scale up, and the database is gonna have more or less the same size, while the other pods keep on scaling depending on the load about them. So we didn't want to leave our MongoDB and Mongo Express inside virtual machine. We wanted to move everything to Kubernetes apart from solving the scaling problem that we had in virtual machine for the application. Here we went for the Mongo Express, we use the Helm template to be able to deploy Mongo Express, and we also use the Helm template to be able to deploy MongoDB. The traffic, as you can see, goes through from the browser to the Mongo Express. So our development team is able to configure the database and create tables and do any changes that they need from it to inside MongoDB. MongoDB itself obviously is not exposed. The Mongo Express has its own ingress controller, and inside the Mongo Express deployment, we have the secrets and the config map to be able to connect to the MongoDB itself that's running as an internal service. We use Helm chart, like I said, we use the Bitnami Helm chart for MongoDB, and we installed it fairly easily. And then for Mongo Express itself, we used this repo to be able to install the same release of Mongo Express into the Kubernetes cluster itself. So our own workflow went pretty much from stage one was to do our tests in our CI environments with virtual machines, etc. Then when we wanted to think about scaling, we moved to Kubernetes, and then we automated the entire process of deployment of our application, deployment of MongoDB, deployment of Mongo Express, all through our Azure DevOps pipelines that we will see in a bit how we do this part. Let's switch on a bit to the technical part. I split this up into 4 parts for this demo. I want to talk in the first 2 parts briefly about our application, and then the MongoDB and the Mongo Express. Our application, which is part of this obviously this entire project, it's split into 2 parts. The first part, we create the image itself and we push it into our ACR. And once the images reside there, we are able to deploy those images with our templates to the Kubernetes cluster. Yeah, as you can see, this is a basic Docker file that we use to be able to build our image, run our tests. And then once this image is created, this entire process is automated in our pipeline. So as soon as a pull request happens, the pipeline will run. This will run when this is successful. The image will be pushed to the ACR. The second part is actual deployment of the application. As you can see, we've created 4 files that we use for our deployment. The deployment one is what we use to deploy this is we pull on the image that we create with the Docker file, for example, from our ACR. And then, as you can see here, there are values that are not specified. These values, like the image tag, the replica number, sensitive values here, database URL, database name, etc. All of this is not hard-coded into our templates. These get replaced on the moment of deployment. So within our deployment pipeline, the first step is to always look for these variables defined between these 2 symbols here, and then do a proper replacement. And once those files have been replaced correctly, the deployment will happen directly from the pipeline. So this is the deployment. We're exposing the portal replication, our metrics port, to be able to grab metrics into Prometheus and Grafana. Our resources that we also limit, both limits and requests that we are able to easily change after with variables, and also the health probe that we have for this application. So any new deployment that happens and new pods that go up will have this dash health being checked before the deployment finishes correctly and the older pods are removed. Lastly, as we have 2 different node pools in CI, for example, and in production more than once, some of them are Windows and Linux. This application is on a Windows-based container, so we want to make sure that any deployment that happens goes directly to the Windows node pool. So we specify the node selector part in here for that. The ingress is pretty basic, as you can see in here. The URL, and then we specify our annotation for Cert Manager to be able to grab the proper certificate for this ingress, the namespace where we deploy this deployment to, and then the servers that will connect to the deployment and expose the correct port to be able to connect to this application. So we deploy, like I said, our application. This is how we build it, and we deploy it to Kubernetes with these templates. Then for the more interesting part, the MongoDB, we use, like I had mentioned, the Helm chart. There are some things that we do change from the default value. I'm gonna go through them a bit with you guys. So the first part that we do actually change is the architecture. We use standalone architecture for our CI environment. Then the authentication part, whatever root user and root password for the MongoDB that you need to, on the moment of creation, we specify and also gets replaced on the moment of deployment in here, these two value. Also the username, password, and default databases that get created on the moment because we don't want to use the root user and password for operations from our application. So we generate another username and password and a database for the application. Another interesting part in here will be, if we scroll down a bit more, is the service part. Obviously, this gets deployed to a Linux node pool. So here we specify with the node selector that we want to use the Linux node pool to deploy this from. This only needed in case you have several node pools of Windows and Linux, and you want to make sure this always goes to the right one. If you only have Linux, you don't have to worry about setting up the node selector part. And if we scroll down a bit more, we specify the resources, the limits, and the requests for this deployment. Usually we adjust this after based on what we see in Grafana from the metrics that we get. And the persistent part is by default set to true within this template. And then the interesting part is the servers that we configure to be able to connect to this MongoDB. We use a cluster IP, so we want to access this MongoDB only internally from inside the cluster. We don't want to have it exposed externally, especially since our application runs within the same cluster. So our application that needs to access this MongoDB will access it internally from within the cluster. It will store data internally within it. Same thing for the Mongo Express, that it will connect internally to the MongoDB and then have its own ingress to be able for developers to be able to do changes to the database itself. So here you specify the type, which is cluster IP, and the port that will be open. And then this is how we connect to the database. The external access is disabled, so we're not deploying any load balancer IP or public IP for this database. And then, like I had said, the actual persistent is set to true within this template. There we go, persistent enable true. If we move on to the Mongo Express part in here, we can see also some interesting stuff that uses the Mongo Express official image in here. And we scroll down a bit more. We're also, the service is cluster IP, and this is the port of the service for the Mongo Express. We specify the ingress enabled as true because we want to have our own ingress to be able, our own UI to be able to access this this Mongo Express. We limit the CPU and memory with our limits and requests. The same thing with node selector as earlier. This is the Linux container, so we want to make sure it's running on the Linux one. And here is the interesting part that it needs to connect to the Mongo server, which is running internally on this cluster. Here, instead of specifying the IP of the service for the MongoDB, obviously when a service gets deployed, it gets assigned its own private IP. But imagine there's a case that we have to remove the service or remove the application or redeploy. This is bound to sometimes maybe change this service IP, this internal IP. So we wanted to use instead the internal DNS resolution of this service, which will not change even if the IP does change. So we're going for MongoDB .sv.cluster.local, and this is how the Mongo Express is able to find the MongoDB internally on this service and on this port, obviously. It also will need the MongoDB username and password to be able to connect to it. So we find it with this local DNS entry, and then to be able to authenticate and write data or access it, We need obviously the credentials, which are also specified in here, that gets replaced on the moment of deployment. If we have a look at the service that we're talking about. So this is the service itself. It's using a cluster IP, and this is the IP that I was referring to. The Mongo Express will try to connect to this exact service on the name itself for the internal DNS resolution to be able to find it. The same thing with our application. It will connect to the MongoDB with the MongoDB service with the actual name internally instead of the actual IP here. And then, as you can see here, this has been running for around 47 days. So it's been running for quite a while in our CI environment without any issues. We went through several changes in the cluster, several Kubernetes upgrades, several deployments, several recreations, and the data has remained intact every single time with the persistent storage without any issues that we have. So, speaking of it. This is the persistent storage that gets bound to this. It will come up. In the meantime, this is the Mongo Express itself. This is the UI, and here this provides our developers a portal to be able, if they want to check in and create a database, do any change to be able to access. Of course, this is protected with the login details. So for that part. And as you can see here, the persistent storage is bound to this very deployment we're using only 8 GB. This is a value that can be specified in the template itself. For CI, it's more than enough size for us. That will also depends on your need, but this value is also specified within the Helm template itself. Okay. For the final part, so our takeaways from this experience that we've had, that having Helm makes everything very easy, especially for stuff like MongoDB or Mongo Express, not to have to write our own templates. And with a few changes that you have seen, we can deploy a MongoDB with persistent storage, with all that very easily with just a few changes to the values depending on our needs. Obviously, this entire endeavor, you need the entire Kubernetes ecosystem to make everything easier, because you're gonna make use to host this application and to host this database. You're gonna need your stuff, your other stuff in Kubernetes. You're gonna need your cluster. You're gonna need your ingress controllers. You're gonna need your cert manager. You're gonna need your Prometheus, your Grafana to get data. So obviously, starting from scratch, it's a big project to create Kubernetes and then deploy an application, but having that already existing, which we did, that of course made our life easier. And within a day, we were able to create these resources and add them to our already existing cluster. And like I said, we need more tools for this application to be able to monitor it correctly, for everything to work correctly, not just these, but that's how things go. The last takeaway that we have is that it's more cost effective. We compared to having virtual machines running, in our case, to host this application, having this in pods and Kubernetes, it's far more cost effective for us. We don't have to worry about having several machines for high availability. We don't have to worry. We have to worry about far less things. And also it's much more scalable, easily changing our value for our replica set, or having a horizontal pod autoscaler. We can control, since we get metrics to that, we can control scaling up and down our application. This doesn't really apply that much for our database, let's say, or the Mongo Express, but for our own application, this definitely applies. And for last bit, I want to thank everyone, to the community, and have a great day.
Thank you, Ellie, and we hope you have a good day as well. Thank you. So while we're getting the lights back on, you see the magic of live TV. It's really nice to see so many people in person. This is awesome. And to all the folks online, we appreciate your presence and patience. So, we like to do things on the go. While we're getting our next speaker ready, Arul, if you could come up and they'll get you mic'd up, but you don't want to come on the stage yet because it's going to get kind of scary. So what city are we in? Good job. So we got good job. All right. That's not a quiz question, by the way. You don't win a T-shirt for getting that right. Who's one of the most famous rappers from Detroit? Good. All right. So this one goes out actually to a live stream that we did quite a long time ago with a wonderful guy from South Africa. He kind of inspired me to do something similar because he wrote a rap based on, Lose Yourself, which is really, really hard. A lot of people go to hip hop karaoke and they're like, I want to do the Eminem song. It's like, it's actually really tricky. But Patrick, where are you? Patrick tweeted, he was like, Bart's probably going to do a rap. And I was like, okay, challenge accepted. So I just wrote these lyrics. I'm not kidding, fresh off. So for the folks who are online, I hope you enjoy it. I'm not going to make you clap along or anything because then you wouldn't hear, the wonderful things I'm about to say. So the pods are heavy. The logs are steady. We roll live on YouTube. I don't do stuff with Bevy. Impala, that Chevy. Chase Tax, that's Levy. Guitar goes hard. Picking strings, that's shredding. The Ruger's heavy. Lex Luger's betting. Your next workload is stateful on Kubernetes. Freddy Krueger sweating like Cuban betting. Cultural cocktails like boozing weddings. Play blues and ready. Make news and heading. Shake fools and ghouls when I'm Bill and Tedding. Thank you very much. So that's the first rap of the day. The second rap is going to be from my main man, Arul from Ops First. No, I'm not going to make him do that. But if we can get his slides up, there, it's the third presentation. So if you could go back, can we go back to the first slide? Because I think we're probably, keep going back. Want to make sure we're on the right, keep going back. Good. So that being said, Arul, the stage is yours, my friend. Go for it.
Good morning, everyone. I'm Arul Jegadish from OpsFirst. I'm one of the co-founders of OpsFirst. We are a startup that offers an end-to-end DevOps tools platform. So today I'm going to talk about a recent project that we took up where we migrated some of our data workloads to ClickHouse. Next slide, please. So the purpose of the discussion here, so one of the components in our tools platform is a full stack observability stack. And as part of the observability stack, one of the modules is distributed tracing. And for distributed tracing, we use the tool Jaeger. And Jaeger has different storage options. To begin with, we use Cassandra as the storage option, and then later migrated to ClickHouse. So this talk here is about about why we did that and how we did that. Next slide, please. So first of all, a little bit about Jaeger. If you heard about Jaeger, it's a OSS tool for managing distributed traces. It came out of Uber, and it's actually part of CNCF now. It's one of the CNCF incubated projects. It's very, very stable and widely adopted. With Jaeger, if you have a distributed system with several microservices, you can get a full unified view of your system when a request goes through your system. So that's about Jaeger. Next slide, please. Yeah, and a little bit more about the architecture of Jaeger. You actually begin by instrumenting your applications to emit these traces. That's usually done with, nowadays it's done with OpenTelemetry libraries. And then you collect those traces, send it to the backend, and Jaeger processes it and finally stores it in the DB, the Jaeger DB. The common storage options are Elasticsearch and Cassandra. In our case, we started off with Cassandra as the storage engine. We didn't want to run a bunch of Elasticsearch clusters. Cassandra served us really well till we wanted to do more with the data. We wanted to do a lot of analytics on the trace data that came into our backend. So then we started looking at other options. Next slide, please. A little bit about, again, Cassandra's some advantages, disadvantages. With Cassandra, the ingestion was really fast. We were using a Kafka. The lag on the Kafka was like really almost zero. So the ingestion was really good. But on the disadvantages side, we couldn't do much analytics on the data. So that was a main requirement for us. The other disadvantage is the resource usage with Cassandra with respect to storage, memory, CPU was pretty much on the higher side. And we were running this at scale, so we were looking for a more optimized solution. So next slide, please. So that's when we actually looked at ClickHouse. With ClickHouse, the analytics capabilities were really good. We were able to really do a lot of analytics on the data that we collected with Jaeger. Plus some of the storage optimization with ClickHouse was also really important for us. We were able to do a lot of analytics on the data. And some of the weaknesses around ClickHouse didn't really affect us for this use case because the tracing data is pretty much immutable. Once you collect it, you're going to delete it only when you are like over the retention period. So that was pretty much okay for us. Next slide, please. Now the other aspect of ClickHouse is other aspect of using ClickHouse with Jaeger is Jaeger has a plugin built using the gRPC support to support different type of storage. So we basically use that. There is a plugin published by the community called Jaeger ClickHouse that actually supported the ClickHouse backend for Jaeger. So we were able to make use of that and make Jaeger write data to ClickHouse. Next slide, please. At a high level, some of the steps that we used. The first thing is to run ClickHouse on Kubernetes. So we use the Alternity ClickHouse operator. So the operator has a lot of community support. It pretty much worked out of the box for us. The Alternity guys have done a really good job in bringing out that operator. So if you're going to run ClickHouse on Kubernetes, that's a great choice to have. We run a lot of production-grade workloads using that operator. So in this case, the other aspect is we use Argo CD to run our entire platform. So in this case, the steps are really about making changes to the Argo CD configs to swap Cassandra out and bring ClickHouse in. And bringing ClickHouse in is basically through the ClickHouse operator custom resources. And then it's just about changing the Jaeger configuration to use ClickHouse as the backend. We also had production data in Cassandra, so we had to migrate that data to ClickHouse. So for that, we basically used our own custom script. This is something I can talk about in detail, maybe offline, on how we actually accomplished that data migration. Next slide, please. So some best practices and some things we noticed when we did this migration. First of all, the ClickHouse operator that actually ends up creating a load balancer by default, which is something you might not want. Your ClickHouse is something you'll access only from within your cluster most of the time. So that's a setting you may want to change before you go to production with that. The other thing is you may want to create a read-only user, because if you are going to visualize your ClickHouse data on some visualization tool like Superset or Grafana, having a read-only user helps. So you may want to change the configuration to create a read-only user. And similar to that, some basic changes like change the retention period, disk space, and requests and limits for resources. These are things that you may want to change. The other important thing here is we were using Argo CD. So Argo CD is also a controller. Now you have a ClickHouse operator that is also controlling some resources. Often these two controllers get into a conflicting situation where both the controllers will try to manage a resource, especially like PVCs and PV. So you may want to take care of that. Otherwise there could be some unpleasant surprises where Argo might try to delete your PVC. So before you go to production, this is something you really need to take care of. Next slide, please. The next stuff is really about making sure you're backing up your data and monitoring your instances. So for backup, again, there is a great open source tool, ClickHouse-backup. Currently, we run it as a Kubernetes cron job. Interestingly, this is also becoming a custom resource as part of the ClickHouse operator. It makes it even more easier to create backups of your ClickHouse instances. And secondly, you can have ClickHouse expose Prometheus metrics, and then you can scrape it. And once you scrape the metrics, you can create dashboards and create alerts. So we have this done, and you can also get it done fairly easily with these open source tools. Next slide, please. Once you have all this set up, this is really showtime. You can query your data and create really good dashboards. All you have to do is connect your ClickHouse to one of the visualization tools, Apache Superset, RedHashDB, Grafana. These are all great choices. And all these tools have out-of-the-box connectors and data sources available to connect to ClickHouse. So you just have to connect that and then start writing queries and create really good dashboards. In our case, with respect to Jaeger, the Jaeger's data model was pretty flat. It wasn't really optimized for querying, so we used ClickHouse materialized columns to create a few more materialized columns, which made it easy for us to query the data, as well as it improved our query performance. Next slide, please. I'm going to skip the demo here. If you have if you want to look at some demo, I'll be happy to show that offline. Basically, what this allowed us to do is it actually allowed us to give our customers a really good APM solution on top of open source Jaeger. So open source Jaeger is really good. It collects traces, and you can view your traces, but then there's no analytical capabilities. So we took the data to ClickHouse, and then we created an APM on top of that data. So that's what we were able to do at OpsWest. Next slide, please. That's what we have to share here today. So if you have any questions, connect with us, connect with me on Twitter, find me on LinkedIn, or find me here. I'll be happy to chat more about this topic. I would like to thank the organizers for giving us an opportunity to present here. Thank you.
Thank you, Arul. Good job. Awesome. We do have time for a question. Do we have any questions in the audience? Anybody got a question? Questions? Let's see. Well, with that, then, we do have a question. Awesome. Give me an excuse to run. Exercise is good. Thank you.
Thank you, Arul. So you kind of mentioned about contention between the Argo CD operator and the ClickHouse operator. Can you talk a little bit about what exactly was going on?
Could you please repeat the question?
You mentioned a little bit about the Argo CD operator contending with the ClickHouse operator, and can you talk a little bit about what you saw? Sure.
So what happens is with the ClickHouse operator, the Kubernetes resource that you will create is a custom resource called as ClickHouse installation. That's the kind that you will create. So Argo CD will manage that, meaning Argo CD will take the configuration from Git, apply that to Kubernetes, and will actually manage that. And once that resource is applied to your Kubernetes cluster, then the ClickHouse operator running on that cluster will look at that resource, and it'll do a few things, right? It'll actually launch pods, it'll create PVC and all that. Now, what happens is, if you don't set the right annotations and labels to be propagated down, Argo will start thinking that these are extraneous resources. Argo thinks that there is a PVC now here, this is not defined in Git, so I should go delete it, right? If you have auto pruning setup, auto heal setup, then Argo will actually try to really delete your PVC. So if you don't take careful action, that can happen. So before you go to production, ensure you test it and ensure Argo and this operator is good. This actually happens with even other operator type setup with Argo. You have to ensure the right annotations and labels are propagated. Yeah. Okay.
So with the pros and cons slate that you had, so you identified some cons with the Cassandra, right? And you went with ClickHouse. So did you explore any other option, any other solutions that you had other than ClickHouse?
Yeah, so a couple of other, initially there was even a time when we explored, we were thought about even using S3 as our backend. That was not a very good option, but we were thinking about saving cost and all that, looking at S3. Jaeger supports even S3 storage, but we didn't go down that path. Analytics, it's not the right solution for analytics. There is Druid DB is also another option. We didn't do a detailed POC there. ClickHouse worked really well for us. The team also had prior experience running ClickHouse, so we actually went with ClickHouse. Druid is another option that you can actually explore for analytics workload.
Okay, perfect. That being said, we do need to keep you on stage, Arul, because for the folks who got here maybe a little bit later, you may not have seen that, it's difficult to get a horn through customs, but so that's why we got a North American horn. So say hello to the North American DoK horn. Arul, if you could come over here kindly, we would love to take a picture with you.
Okay.
All right, so yeah, hold it as high as you want. Yeah.
Okay.
Awesome, thank you very much.
Right.
Excellent job.
Yeah.
A round of applause for Arul. Thank you. All right, so next up we've got Dax. So Dax, if you can come to the stage. As usual, folks, keep on tweeting, take pictures, put the hashtag DoK Day. Oh, we need to plug in your computer. Okay, okay, you just want to have it there as a reference point, fine. So yeah, if we can get the next slides up, perfect. And then do you want?
Yeah, this is good. Everyone can hear me? Sweet. Cool. All right. So, hello everyone. Today I'm going to be giving a talk about how SourceGraph scaled our software as a service to thousands of clusters. And it's going to be kind of a fun talk because it's going to be, I think, a different path than I would have taken a few years ago, and kind of shows some of the trade-offs of going to Kubernetes right away and waiting a while. So next slide. So yeah, a little bit about me. I work at SourceGraph. SourceGraph is trying to bring code search to every developer. I originally helped launch our multi-tenant cloud offering, so that's sourcegraph.com, which you can use today to search the entire world of open source. So this is basically a story of how we came and saw that we started to switch and see a lot more demand for a highly isolated environment instead. So next slide. So yeah, next slide. Yeah, so the story so far. So basically, SourceGraph is a code intelligence platform that allows people to read and understand your code. We have sourcegraph.com, which is our multi-tenant offering that basically try to index as much of the world as possible. In the past, SourceGraph was deployed on-prem, so customers would deploy it, and they would manage it themselves. And then over time, as it typically happens, we saw more and more demand from customers for us to manage it. And begin in a highly isolated, compliant way. Because again, they're trusting us with their code, because we need their code in order to search it. So another thing we also noticed was that in our pursuit of some extreme scale, we had some scaling problems that weren't worth it to solve at this time. Where, for example, we have a feature called Code Insights, which allows you to understand metrics based on your code. This works for 99% of our customers, but it wouldn't work for our largest scale. So it's okay, I think it's time that we invest it in running multiple SourceGraph instances instead. So next slide. So we actually did have a single tenant offering that we kind of on the sly built for a few specific customers when they had they're unable to deploy SourceGraph on-prem because either they didn't have a DevOps team, that was one thing, or they had infrastructural differences. We had customers that exclusively run serverless. So SourceGraph as a product just really meet with the skills they had on-prem, and it's fairly challenging to run. So this is kind of our Docker Compose setup, which basically ran in a single GCP VM, and it did have some issues. So next slide. And So we had a blue-green deployment model with lots of manual steps. Again, this was kind of built in essentially a week, and it was something that we inherited this, and we had a blue-green deployment model that required us to basically, even though it was using Docker Compose, is basically like a machine image. We'd literally take down the entire VM, start it back up. All these steps are in our handbook for what we had to do in order to upgrade, which we did monthly. So as we scaled to like 20 and 30 instances, it became a massive issue and a massive time sink just to do this. So, of course, we're an infrastructure team. Next slide. So yeah, Kubernetes, right? That's what we're going to do. We're going to immediately move away from this old, outdated Docker Compose idea. We're going to leverage Kubernetes because a lot of the paradigms in Kubernetes are just something that makes a lot more sense, and we're all kind of eager to kill this old thing. That I think was, kind of thought about this a little more, and found that sometimes we have to balance the business needs with what might be desired as I think on the infrastructure team and how to move quickly. So next slide. Yeah, so we had so we wanted to, the reasons not to go full Kubernetes out of the gate were pretty numerous. So first of all, we wanted to be very incremental because we already have customers using this. We also had SOC 2 compliance at this time on these instances. So again, we're definitely not only building the plane while it's moving, but we're building the plane in a state where any kind of serious issue or failure to meet compliance regulations, and we can jeopardize the entire product, right? So this just really increases the risk to the customer and a risk to the company. But we did there's some paradigms in Kubernetes we wanted to use. One, we shouldn't need to take down the entire VM to upgrade the application, right? So let's just not do that anymore. Very simple kind of thing that we pulled out there. Another thing we saw was the leverage managed services. We're lucky that we're a cloud native company, and that many of the things we used to run inside of GCP, inside the VM, inside our Docker Compose deployment, like Postgres, we ran an object store. Many of those services are probably easily available in cloud, and it made a lot of sense just to externalize them and pull them out. Yeah, I think. Oh, and we also had some other business requirements of quicker instance creation. So we wanted, again, manual time to spin up an instance. Let's just leverage some automation. You don't necessarily need Kubernetes for that yet. Next slide. So we kind of intended on this incremental 1.1 model of just focusing on increasing automation. Again, keeping Docker Compose, not bringing Kubernetes into the picture yet, but decreasing the risk of unknown unknowns with the full Kubernetes migration. And we also, again, things were changed underneath us. So for example, during this time, we had another requirement come in from our code intelligence team to run Firecracker VMs so that we could run untrusted code. Again, maintaining compliance during this entire time. So this taking these small calculated risks to start externalizing services while we still have customers running on top of them let us kind of slowly make the move instead of doing a full-blown approach to changing it. Next slide. Yeah, another kind of just hit on how the challenges of architectural changes are still occurring because we're a startup, and the challenges of building a managed service when you're still building the service itself. Next slide. So yeah, so the basic automation we added was basically a Go CLI. This is step one of automate everything. This was basically allowed us to have a consistent API to other teams as we were moving from V0 to V1.1. Customers are able to, or other teams are able to basically just not care about the infrastructure underneath us. Basically provide a stable API in the form of a CLI. And common tasks that were previously manual steps, we scripted out into CLI. So again, just kind of your simple, conservative steps in adding automation, scaling the team, and reducing the risk to the company. Next slide. So another thing we found that were GitHub Actions during this time is really, if you're a DevOps team, definitely spend some time looking deeply into those. They provided a really straightforward way to kind of throw a quick poor man's UI, so we could provide self-service access to other teams before they would have to talk to us and engage with us in order to do basic things like upgrade an instance or like create an instance for them. Pulling that all out into GitHub Actions allowed us to simplify the process massively, so we weren't constantly getting pinged. So this would be something I suggest other DevOps teams to look into. Is like when you have a workflow that you have scripted out to like the ultimate end of it. Next step is to put it in just somewhere in some solution that end users can consume fairly easily. Yeah, and we didn't actually have to build a UI, which was always nice. Next slide. So we had quite a few learnings in this v1.1 phase before v2, which was the power of like incremental, incremental learnings led to some pretty serious surprises. One of the ones was the fact that like the complexity of the application, Kubernetes or Docker Compose for us really didn't change. Like SourceGraph, you can look at our deployments models online. It wasn't necessarily more difficult to run it in Kubernetes than it was in Docker Compose, but the infrastructure challenges we had were pretty large. We're spending a lot of time doing these very large Terraform applies with very large modules. There's a pretty big risk, blast radius-wise, to these large Terraform applies. If any, there's several times when we had outages that were basically linked to Terraform apply that wasn't fully either understood by the team or automation that went awry, and a small change to one module kind of bled into the overall apply and resulted in a lot of resources being recreated when they shouldn't have been. I think another thing that we found was that, so that was like one of the issues we found. We also like really wanted to get towards a declarative over imperative upgrade style. And this is again pulling out that, instead of invoking a workflow to do something, just declare that's what you want. I want this to be version 3. And let's leverage Kubernetes paradigms like controllers and the control loop, just continually work that through. It's also, I think, a similar paradigm to what we see in GitOps today. And another thing was, a few issues was also, depending on an external service for like GitHub Actions, if there's a GitHub Actions outage, that basically would, cause a lot of our self-service workflow to stop working, and kind of made us even push harder for, okay, I think we're ready to like fully engage with a Kubernetes controller model with drift detection and automated infrastructure creation. So, okay, I think next slide. So one of our, I think, bigger bets recently was, I think, really heavily leaning to CDKTF. So CDKTF is a tool that we use to leverage the Terraform we've already written, which we have quite a large amount of Terraform. All of our basically all of our infrastructure is defined as infrastructure as code. CDKF provided a way for us to start to add basically additional automation into a controller without needing to essentially run manual Terraform applies, which we found to be problematic and concerning. They were pretty challenging to run Terraform like in a fully automated way. And CDKF seemed to be, and still appears to be, I think the easiest way of like, when you hit the limits of Terraform automation, what should be your next step? Seriously consider CDKTF, for example. And that's something I would say, should you use CDKF? Because it is, I think, still kind of a newer product and has some complexity costs. If you're really like pushing Terraform with like dynamic blocks, and you're really like, I think like pushing like of what you can stuff into HCL, CDKTF kind of represents the next layer of abstraction. Although it's still new and it's still not without some challenges. So next slide. So yeah, this is like a high-level kind of like description of some Terraform code on the left with some like count operations to make it slightly more dynamic. Basically just turning on and off IP allow lists. And then we have the same kind of code in TypeScript with CDKTF. Just get kind of an idea of how like this code can be similar. Again, you do need to know the language, the higher level language you're writing it in. You need to be familiar with it, but it was still a pretty easy, direct, and quick translation for our team. We were able to rewrite almost all the Terraform like HCL we had pretty quickly in CDKTF. So it wasn't nearly the migration cost that we originally thought it was going to be. Next slide. And then, yeah, just the more high-level CDK TF versus Terraform. And that was the, like, you want the higher level access to the Terraform primitives. Like, basically, if you like Terraform, you're using it a lot, and you like what Terraform can give you, seriously think about like CDK TF as you start to increasingly rely on Terraform in your stack. Also, what we noticed is that a good paradigm was to split out your large modules into lots of sub-modules. So pretty easy flow with CDK TF due to its the concept of stacks. So CDK TF stacks allowed you to quickly auto-generate basically Terraform applies for multiple different steps. Yeah, and I think some of the cons that we noticed that have recently been improved were that the Go compile times were like, in a team that uses Golang quite a bit, like 15 minutes sometimes to pull in all the different types we needed to like run the Google Cloud providers. This has recently been massively improved in that's supposed to be the 0.13 release of CDKTF, so this is no longer such an issue, but before we were spending multiple minutes to like add all the types to our code base and to generate the stacks. Also, it's kind of relies on some technically unsafe some type safety issues because of its how like it basically goes from the Terraform providers to Go. A lot of times you end up with just interfaces. So those who are Go developers in here you just lose a lot of that type safety. But I think that's an open area where they're looking to improve it. And then also the last little joke was many times we would create so many CDKF type files that we would literally crash the GitHub UI as we added all those types to our code base. Yeah, next slide. So yeah, and then this is something like we started, again, our goal here with version 2 is to make everything as declarative as possible, really leverage what's great about Kubernetes. That's kind of what led us to this controller model. So this is kind of what we scripted out. Before we even built the controller, we actually wrote the type. And this is our basically our source graph CRD, custom resource definition, which provides our, am I good on time, I think? Okay, cool. Yep, I was making sure yep. And then, so this CRD provides a quick way for us to scaffold out all the, basically we added, as you can see here, we added some sections on like machine type, DNS name, all this, we put all this into the CRD. By doing that, we could kind of like scaffold out what we wanted to build. And we found that like Kubernetes CRDs are useful even outside of Kubernetes just for defining your types, defining basically your serializable format for your infrastructure. So here we've created our own type, which contains most of our information that we need. And then also this type lives inside of a Git repo, which was like several override files that allows us to kind of like, again, reduce the variation between different deployments because we can just kind of say, oh, this deployment is a medium-sized deployment, leverage this override file. Yeah. And I think, yeah, and also to start, like again, just to mention when you're starting building this controller, you don't actually have to run it in the cluster. You can happily run it outside the cluster, like in a very manual CLI-based control loop. And it basically provided us a lower risk way to iterate as we were kind of scaling out and getting familiar for the first time as a company with writing Kubernetes controllers. Next slide. And then, yeah, this is kind of like the long-term and like the model of the controller today, is we have basically our customer declaration in GitHub and Git, and then we have multiple. The controller basically continually runs with our CRD definition, goes out, syncs, runs basically a continuous Terraform apply, a Terraform plan. We still haven't fully got to the point where at this point it just fires off an alert when we notice that the Terraform, like there's a diff detect at the infrastructure layer. Still working out some minor trouble with like completely automated applies, but CDKTF has kind of given us like the foundation where I feel pretty comfortable to keep doing that. Yeah, and then all these clusters are individually controlled by that single CRD, and again isolated and yeah, in separate customer projects. Yep, next slide. So some of our future steps is just continuous work on the controller. Keep adding additional steps. Fully have completely automated Terraform applies without needing to fire off alerts when drift detected. When drift is detected, we think we can do that with CDKTF. I think the primitives there are strong enough to fully automate it. Multi-region is the next step for us too. Is just as we're scaling out, we're looking toward again by writing everything in Terraform. It's a very easy additional step because again a lot of the Terraform providers we already have just going to make minor modifications to add additional regions, and then actually building a true UI that will eventually create those CRDs behind you, automatically commit those to the Git repo, and then by adding those CRDs to the repo, then having the controller automatically pick that up. So that would hopefully be, basically re-enable the self-service flow without needing to depend on GitHub Actions. And that's it. Next slide. Yeah, so any questions?
The question I have is, why did you decide to use Google Cloud SQL outside the Kubernetes cluster and not use a database inside Kubernetes? Did you do a pros and cons analysis, or you just decided to go with it because it was a managed service?
Yeah, so for us, it was mainly just reducing the operational burden at every step. So that we have thousands of clusters. We actually ran into some issues early on in our experience running Postgres in Kubernetes. That was basically our #1 database service. So we ran into a few issues with it, and eventually just found that running as a managed service took out a massive operational burden as we were scaling. We're still exploring the country role Postgres operator, but at the time that was a decision that we made on sourcegraph.com early on, just use Cloud SQL. So we really hadn't investigated again to if that's still the next move. But I think as we go into the next iterations of managed services, we're probably looking to bring things back into Kubernetes as we get more comfortable running things in Kubernetes.
The other follow-up question is, so you said you do disaster recovery workflows, all the time. So are you using Google Cloud SQL's, disaster inbuilt HA and all of that for it?
Yeah, so I think Google Cloud allowed us to. They have their they have HA failover, but they also have the I forget the name of the service now, but it's basically the ability to restore any point in time over the last 7 days. So we basically use that, and we've had to use that once or twice. We have situations where some service either wrote a ton of garbage data to the database, the manual effort to repair it was too much, and we're able to roll back the database to a specific point in time before that release. So things like that are things that I would expect to see in an equivalent if we wanted to use the Postgres operator, right? We would need to have those same tools just exist and not have to fully engage with them. That's what we'd be looking for, I think, as we moved it back into Kubernetes.
Thank you.
Awesome. If we have other questions, please direct them to Slack. Thank you very much, Dax. Amazing talk. Another round of applause. Let's get a picture of the horn. Raise it high. Perfect. Good.
Thank you.
Thank you. Let's keep things moving. So we're getting more requests for raps on Twitter, so now we really got to improvise. So if you want a keyword featured in a rap, just please tag us on Twitter, and we'll do so accordingly. But we want to keep things flowing and dynamic. So this one, it's hard to multitask with a horn in your hand. So next one, before we bring up our next speaker, Holden. So Patrick's close to Windsor, feeling right at home. We're rockin', dockin', talkin' shop, putting knowledge in your dome. Next speaker's Holden, OG like Tetris, yarn, spun and woven, analytics and metrics, cheat codes and modes, better know your nodes, DoK, like the way to Rome, inclusive to all roads. Can we bring our next speaker, Holden, up, please? And can we get their slides going as well? Let's get Holden. Cool. Perfect. Holden also has the longest title of anyone in our event today, so congrats on that. Here you go.
Awesome. That's maybe not a good thing to start off with in terms of the longest title, but I assure you that each one of the Ks, there might only be one, stands for quality. So let's go ahead to the next slide. Yeah, so I'm Holden. My pronouns are she or her. It's tattooed on my wrist in case I forget in the mornings. I got a little fucked up when I got hit by a car though, so 0 out of 5 stars. I don't recommend it. Oh, also, my team is hiring. So if you are interested in renting your soul to a giant megacorp, please come and find me in the hallway. I am not that hard to find. And if you find another person wearing a sparkly dress, I'm sure their team is also probably hiring. Yeah, let's go ahead to the next slide. Yeah, also not super related, but I think for those of us who are building data or ML tools, it's really important that we try and create inclusive communities so that we don't accidentally just recreate yesterday's biases with more software, yay! And so, this is sort of who I am outside of tech. I'm Canadian. I actually got my green card this year or last year. I'm a little fuzzy on that. Prior to that, I was on an H-1B visa. 0 out of 5 stars, once again. Do not recommend either. But yeah, I'm super stoked that I get to live here. Next slide. Cool. And so I have a bunch of probably relevant biases that we should keep in mind. I tend to work with really large-scale data sets. So when I talk about data processing, I tend to think about things that really don't fit on a few hundred computers. To me, that's the small-scale data, and that's just because the people who pay me money tend to have lots of data. I've also worked on some of the tools that I'm going to be talking about. Those are the tools that I know better. Some would say that makes me biased to think those tools are good. I think that makes me biased to think those tools are crap, because I know how they work. And so sort of just keep that in mind as I'm talking. Oh yeah, I also really like strongly typed systems, which does give me some bias against Python. I'm sorry for Python folks. But yeah, cool. Next slide. Oh yeah, and I really love my dog. So he's in as many of the slides as I could fit him on. Cool. So we've got a bunch of different characters for today. We've got Hadoop MapReduce. That's more the OG kicking it. We got Apache Spark. All kinds of fun. If you've ever said to yourself, damn, I don't have enough out-of-memory exceptions, Spark is here to help. Then we've got sort of two of the new kids, Dask and Ray. And if you've ever said to yourself, you know what, I really wish there was a pandas distributed data frame, that's Dask. Only people I know have actually sort of gotten anywhere close to that. And the Ray folks, if you ever were like, you know what, I really wish more of Python was written in C instead of Fortran. Yeah, cool. The Ray folks are pretty rad. And then Flink, also JVM, more streaming than Spark, not as familiar with it, but they did a lot of things better with their cube migration than Spark did, and we'll sort of talk about that. Part of that is they didn't cheat as heavily as we did when they were on top of Yarn. So next slide. Rockin', yeah. So there's a bunch of different challenges that we're going to face in our migration. The biggest one that sort of everyone here is used to dealing with is our good friend state. The next one is scaling up and down. The state one, though, is the one that's really painful. Thankfully, scaling up and down is something that everyone sort of has to deal with. Another one is sort of the debugging experience, which is something that I think we can forget about as platform builders because we're sort of focused on making the thing work. But it turns out that nothing ever really works, so we really need to make sure that people can figure out what the hell is going on. And yeah, we kind of screwed the pooch on that one in some ways. But looking at it another way, just all of these systems were sort of created before data on Kubernetes was really a thing, and so it's all sort of a port experience. And so if you've ever played video games from the first Xbox on a more recent Xbox or PS1 on PS2, you know that these ports are not perfect. They're pretty good, right? But we've definitely got some rough spots, and we're working on them. So yeah, and that's my dog again. He's cute. Next slide. Cool. So why do we have to care about state, right? This data processing stuff, surely I can just write all kinds of stateless transformations, that's what Spark does. Why is the state thing mattering to me? Why am I having to deal with that? Well, so it turns out that to power a bunch of stateless transformations, we actually end up using a bunch of state underneath the hood. It's kind of crappy, but it's what comes, yeah. That's what comes to it. Also, if we start dealing with streaming data, then we have to start keeping track of what data we've processed and what data we haven't processed. All kinds of fun. Aggregations, all of these things. the TLDR is I need to know if my dog has had a bath this month, right? And so it turns out that no, Timbit has not had a bath this month because when I put him in the sink, he gets very, very upset. So next slide. Cool. So what are some different ways that we can achieve fault tolerance, right? So a big part of all of these data processing tools is fault tolerance, and that's essentially computers are terrible, they were a mistake, but unfortunately we're stuck with them now, so we have to deal with the fact that they're going to fail. And there's sort of these broad different techniques. The top one is sort of the one that MapReduce picked. It's kind of a cop-out, which is just like, we're going to say that my storage is reliable, I'll just put it in this reliable storage, and then the fact that my computers are garbage doesn't matter. And that's great, except for the fact that someone has to make this reliable storage, and then it has to like work. And that part kind of has some opportunities for growth, as it would say in a performance review, and could perhaps achieve better performance, as it might say in a performance review. Recomputing on failure, this is the sort of Spark and Flink approach, and to a lesser degree Dask approach. And essentially that's like very much just, you know, failures aren't that common if things go wrong. We'll just sort of redo the work that we did before, it'll be great. This kind of sort of works, except for when we get correlated failures. And it turns out that the kinds of failures we get tend to be correlated because spot instance pricing can cause correlated failures, machine failures cause correlated failures, et cetera, et cetera. So really, really great, except for the like whole in practice thing where things kind of go sideways. The other option is we just throw some extra computers at it and some fancy math on top of it. That is the approach to a certain degree taken by Ray, although honestly, Ray mostly takes the approach of ignore it. Pretend my computers work and everything will be just fine. And if that works for you, that's really great. In practice, that's an exciting opportunity to rerun your pipeline repeatedly. So Ray, by default, just assumes the computers totally work. And yeah, that doesn't work. But that's okay, whatever, they'll fix it, I'm sure. Next slide. Right, and so here we just see all of the things that I talked about. So if you forget what I said before, you can go look at these slides later. Okay, so, oh, and once again, also the puppy. He's taking a nap. Yeah, there he is. Okay, next slide. Oh, yeah. Okay, cool. So let's talk about how Spark cheated on Yarn. So Spark on Yarn is sort of like the traditional de facto place that Spark has been historically deployed, and we just cheated the heck out of it. So essentially, we had terminate and stay resident, which is like not really a thing on Kubernetes, right? Like when our pod goes away, they don't just let us like leave a few extra processes hanging around, right? Like it's no, you're gone. Whereas on Yarn, we were just like, hey, so just like when my executor goes, it's okay. Just this is their good friend. You can totally trust them with the files. No security problems here. Just if anyone shows up and asks for a file, just give it to them. No problem, no problem. And that's what we called the shuffle service. Totally great, really lovely. Didn't work when the node itself actually failed, but worked really well when we sort of had executors coming and going, which it turns out that that's most of what we have. The underlying nodes themselves are relatively reliable, but the executors themselves, those out-of-memory exceptions that we were talking about, all kinds of fun, right? And so this let us cheat, and we sort of were able to pretend that our code was more reliable than it actually was. And then when we came to Kubernetes, and I started asking people like, hey, how do I like leave a program around after my pod is gone? Everyone was just like, no, you don't get to do that. And I was like, oh, crap. So yeah, we don't get to do that anymore. Okay, next slide. Yeah, okay, so we don't get to do this like fun hack that we did on Yarn. So what do we want to do instead? So ideally, right, we want this fast write where I'm like writing to a local disk, and I can terminate and still serve files from that local disk magically. We don't get that, not available. Fast read and write from one movable place, right? So maybe I've got some kind of magical volume, I can remap it to different pods, that would be pretty cool. Ooh, I misspelled fast. The Y is a T, and the K stands for quality. So fast read from many places. Read from many, write from one. Not really sort of a thing in Kubernetes so much. Read and write from many places. Okay, we've got that. There's some performance downsides. We'll talk about that soon. And fundamentally, this all comes down to that state problem we were talking about before. Next slide. And so yeah, on Yarn, we sort of got this. We got this by cheating and being bad people. That's okay. My dog is cute. Oh wait, no, that's a picture of some yarn. Never mind. Next slide. Okay, is this my dog? I can't see so well. Whatever, we'll assume this is a picture of my dog and he's cute. So do we get what we want when we're running in the cloud? Ooh. The answer is, so we don't get to terminate and stay resident in the cloud, right? Like Amazon does not let you leave a running process on someone else's, AWS instance. They're like, no, that's not how that works. But we do get the ability to sort of remap our volumes and move them around. Those EBS volumes, we can move them around. It's pretty cool. Things like OpenStack, we can do similar things, all kinds of fun. This whole read from many, write from one, not so much in the APIs. On the other hand, read from and write from many places, totally, yeah, we can do that. The downside is the performance / the read after write, one of those two, sort of starts to become kind of sad. And it turns out that we kind of want to read the data right after we've written it. Who would have thought you would want to read data after you wrote it? Crazy. Next slide. So what do we get on Kubernetes? And no, see next, and essentially expensive. And so the TLDR is when we come over to the Kubernetes world, our storage story becomes all kinds of fun, also known as an exciting opportunity for consultants to sell you things, or Dell, EMC, whatever. Insert vendor here will totally solve this problem for money. It turns out, though, that I'm lazy and cheap, so I don't really like that. So next slide. Okay, how do we work around not getting what we want? So just like Professor Timbit here, my dog, he does not particularly enjoy being on this floating raft in the middle of the Ottawa River, but for enough treats, he will be on the floating raft in the middle of the river. And just like in Spark, for enough resources, yeah, it doesn't particularly like running on Kubernetes, but we can just make it work. Same thing with Dask and Ray. So one option is we can duplicate our state. Dask doesn't really have this concept so well. Flink and Spark do a lot better. Ray really does not have this concept at all. It's unfortunate because I really like Ray, but that's okay. The other one is we can just try and move our state quickly. So if we hear like sort of from Kubernetes like, hey, you're gonna get moved to another computer or I'm gonna kill you, then we just go ahead and copy out the most important things that we think to another pod really quickly. And the last one is this lazy write through to persistent storage. So sort of give up on trying to write everything to persistent storage all the time, but try and write through lazily. This is somewhat useful. This is the approach taken in Spark for medium-sized files if you have it turned on. And it kind of works, sort of. Next slide. Okay, yeah. So if you're the kind of person who is like, that sounds cool, I want to go see the code, I encourage you to go take a look at this very exciting Jira ticket, Spark 20624, which will link you to a collection of exciting, wonderful pull requests. And you can see this code. It is garbage, but I wrote it, so I'm allowed to say that about it. So terrible code. Most of it lives inside of this thing called Block Manager Decommissioner, and that is where we just try and copy state around as quickly as we heckin' can before we get killed. Next slide. Yeah, that's what the Jolt Cola was for. Okay. So that's great. We've been talking about state, but it turns out that there's more than just state, although don't have a super amount of time. The other thing that we care about is figuring out how do we get these pods? How do we get the right number of executors? How do we get the right type of executors? And the first sort of attempt at doing this in all of these approaches was just like, that's fine. I'll just directly create a whole bunch of pods. So I'll just issue 1,000 API requests, and they'll just issue another 1,000 API requests, and so on and so on. And it turns out that that is what we call slow and not good. So next slide. Instead, we do some different things. So what happens in Ray today is it runs kubectl exec underneath the hood. Oh dear God. I don't know why. Dask uses the pods API. Thousands of API requests, whatever. At least it's not running kubectl exec. I can live with it. Spark, big shout out to the Apache Unicorn and Volcano folks who actually wrote this code because I am far too lazy. Yeah, big shout out. Wait, did you write that code or are you just joining the shout out? Okay, just throw. Okay, cool. Because I'd buy you a Bud Light Lime if you wrote that code. Okay. So good news is Unicorn and Volcano, they actually wrote really cool things, and Spark is able to plug into them. And not only that, they wrote the plugins. Flink, sort of longer story here. Once again, if you want to go and see that long story, Flink 26559 has a whole bunch of people being really sad. But you can sort of kind of make it work if you use a separate operator. Okay, next slide. Yeah, mixed priorities, dynamic priorities. Yeah, we totally get mixed priorities. That's great. This whole expressing my priorities changing over time for pods, not great. So we have this idea that like state can come and go, and some things might temporarily be more important to me, and I don't have a really easy way to express that. To be clear, I don't have a really easy way to express that on Yarn either. On Yarn it didn't matter though, because I got to cheat, and I could just leave my state there for later. Next slide. Oh, right, upgrades. Yeah. We've got 1 minute. It's cool. Next slide. Oh, yeah, UIs. Those are totally important. We don't get those. We get to do kubectl port forwards. Except Dask and Ray actually did a really nice thing here, where if you're deploying with their Jupyter Notebook plugins, they do a whole bunch of magic underneath the hood to do a whole bunch of port forwarding. And you actually get to see the UIs. It's really nice. It's really lovely. We should do that in Spark, but we haven't yet. Next slide. Okay, cool. And right on time. We're done. My team is hiring. You should follow me on the internet. And if you have any questions, once again, come find me. I'm going to go get coffee that doesn't taste terrible, but I will be back this afternoon with better coffee. But that coffee's mine. You got to get your own coffee.
Do we have, I'm sure we have questions. We can take one question. Who wants to ask it? Okay, we got someone all the way in the back. You keep that one.
In the meantime, I'm excited to tell you, oh, sorry, I've been trying to reach you about your car's extended warranty. It is about to expire. Do you have questions about your car's extended warranty?
I'm not sure. I'd have to check.
Or Spark on Kubernetes.
But question about the block decommissioner. Is the purpose of that just for terminating state when your pods are shut down, or do you do that more routinely?
So, we all know that data is the most vital asset that...
Whoa, that's not me. Okay, yeah. So, great question. Right now, we only use the block decommissioner when we are being informed that we are going to decommission, or if Spark is initiating a scale-down event. We don't proactively move state with it. It's only reactive. There is options to proactively duplicate state, but that's a different mechanism.
Cool. Thanks, Holden.
Yay! And once again, come find me for your car's extended warranty, timeshare needs, or to talk about data on Kubernetes.
Or Bud Light Lime.
Oh yeah, if anyone really loves Bud Light Lime, that is my jam. I drink shitty beer all the time.
That's it. Okay, round of applause for shitty beer. Good. No, wait. We're gonna get a picture. Salman, can you come up here? We've done 153 live streams. This is our 4th DoK Day. I think we can all agree that talk absolutely rocked. So we're gonna do another round of applause. I'd like you all to stand for it. Let's get a standing ovation. Yeah. All right. Can you stand here? Salman, can you get here so we're facing the crowd? And can you hold that? Face him. Awesome. Thank you so much.
No, thank you.
All right. Y'all take both. I got 2 microphones now. Look up. So next up, we've got a panel. So when international banks are migrating data, things can get a little bit tricky. So we talked to some folks that are working on Fybrik, so we can run the next video. And they're working with people that work at ING, very well-known international bank. So let's take a look.
So we all know that data is the most vital asset that any organization can have. But what if that organization is based in different countries, has customers that are facing different regulations when it comes to compliance? We're going to take a look at a technology called Fybrik that's been used by ING, very well-known international bank. To start out with that, we have someone from ING. Barry, can you just describe overall the multinational banking environment? What are some things that folks need to keep in mind?
Yeah, well, ING's history is pretty long. We have a background in mergers, acquisitions, adding new labels. Eventually, it ended up in ING as the overall label. That comes with also a huge technical history, where we have big monolithic systems like mainframes, classical banking systems, HP nonstop, those kind of things. So we've been really struggling the last couple of years to get rid of that legacy. And that's also why we started looking at cloud adoption, of course, as the first go. Well, bank on public cloud is still a bit itchy because of the risks and the security and those kind of things. So we started out with a private cloud, which is now being used by, I think, up to 20 countries, of which we have a footprint in already. And of course, Kubernetes is a next step in that to make our landscape even more agile and make use of the latest, newest technology to replace all of those old systems. The challenge in that, where we saw and where we started looking at Fybrik, was that in the past we had those big monolithic systems, so we knew where the data resided. It was always on that big machine. Now going to cloud, Kubernetes, you get a fully distributed landscape. So it's harder to know where the data actually resides. And that's also why we stepped into the Fybrik part and started working on it and joining in the open source thing to add the governance aspects that are for us as a bank really critical in that concept.
Good. And are there other business challenges that you at ING faced related to data and how it's being used in public-private cloud environments?
Yeah, there's 2 major problems. I'm an information architect, so I'll focus on the data and the IT part. There, I think, lie for us the biggest challenge that we need to tackle. And the governance, as mentioned before, being in control of your data, knowing sure where it is, that you have the latest for reporting to regulators, but of course, more important to our customers, and make sure that they have the latest information available on their transactions, their status, their financial bookkeeping. The other one is IT efficiency, making sure that you don't copy the data everywhere. That we keep the costs in mind. As a banker, we're paying attention to money, of course. So the costs need to be regulated and under control. So for us, those are the 2 major challenges that we're focusing on in refurbishing our whole landscape from the 30-year-old history to hopefully a state-of-the-art new install base.
Now, with that in mind, we want to turn it over to Flora, who's working with Fybrik, working on it. Now, Flora, what are the technical challenges that you had when assisting ING in terms of addressing these business challenges that they were facing?
Let me start by sharing my screen with a very simplified illustration that shows how Fybrik comes into this place and assists. So this is the situation before Fybrik. We have a data user that wants to access data. The data is located somewhere And the data user, Eva, in this case, she has a workload to analyze customer data. The customer data has some sensitive information in banking, of course. Let's take the social security number as an example. So Eva needs to ask the data governance officer of the organization for permission to access a customer data set. Serena, the data governance officer, needs to ask another department, the IT admin team, to get a redacted copy without any sensitive customer data, specifically for Eva. So the IT admin, she asked the team to get a redacted clean copy of the customer data set, and the IT admin needs to generate a clean copy. The social security number is masked by the IT admin, and only after this, he can provide Eva credentials to the customer data set. And Eva, after waiting for a while, it could be weeks, it could be days, it could be months, when you have many teams in different geographies and each one of them has their own to-dos, you need to wait in line until you get a response. So it might take even months until she gets access to the data, and only then she can analyze the data and start her actual work. So there are several pain points for each one of these personas. The data user, when she wants to run analytics, needs to wait a long time to get the data. Serena, the data governance officer, she has to take care of the privacy. She can make policy recommendations, but she cannot enforce them. She doesn't have an automatic way to enforce the policies. And she spends a lot of time reviewing requests from different users. The IT admin team needs to make several copies per request. There is cost in storing these copies. There is work in managing the copies. It might have orphan data. After Eva finished the work, she might need to go back to Tim and tell him that he can delete the copy. And it doesn't always happen. So, and users had the credentials. So these are several pain points for each one of these organization teams or organization personas. So with Fybrik, the case becomes much more automated and easier. Eva, the data user, asks from Fybrik access to the customer data set after she found the dataset ID in a data catalog. Fybrik orchestrator automatically deploys modules, read module and mask module that has the credentials to the customer data set, and on the fly it returns to Eva an endpoint URL to the model, which provides the customer data set already cleaned and masked. You can see the social security number was masked on the fly. Serena, the data governance officer, had a way using Fybrik to define the governance policies rules upfront. She doesn't need to do it per user, per request. She does it once per data set because she knows in the data set which fields are sensitive. Tim, the IT admin, also has to do something once upfront. He can define which Fybrik models are available for Fybrik control plane. He has a way to declare the available infrastructure. For example, if there are storage between the data itself and the workload, might be when we have several clouds in different locations, different geographies, we might have several storage accounts. So he has a way to define that. And he can also define rules for the enterprise, like if we want to minimize the latency, if the workload is something that needs very fast response, or maybe minimize the storage cost if we don't care for the latency and we do care for the cost of the storage. So Fybrik enables all this. The value in Fybrik that the data user has an automated data access without waiting time. The IT admin does not need to spend time making copies and no need in cost in unnecessary copies and many redundant copies. The data governance officer can be sure that her recommendations are enforced which is very important for customer data set for banks and insurance company or every company that has sensitive customer data. The credentials are kept inside Fybrik in the system code. It's not provided to the data user, so you cannot share it. And there is no need in copies.
Very good. That being said, you've given a wonderful overview of all the different stakeholders that are involved in this process. But Alexey, if we want to take a little bit of a deeper look in terms of implementation, how would that be? Could you fill us in on that?
Yeah, sure. So we have seen that the difference in how the actors works and how it happens behind the scene. So this is a very high level view of the Fybrik. And you can see all three on the left, all three actors that Flora mentioned before. And we have a fourth one. It's a data owner. The data owner is the one who made the secondary use of the data set available. He provided some information about the data set. Is it HR data? Is it financial data? Put it in the catalog. Whatever it may, other information, he may tag it. For example, is it confidential or part of the data is confidential, like we saw, for example, for this social security number, it's personal information. And Fybrik takes the information of all different actors provided, including the library of models. Models that we mentioned previously are the underlying capabilities, what are available to be used in the flow that Fybrik generates. So it might be models for reading different types of data, it might be models for masking, transformation, encryptions, etc., for making copies. These models, they can be home grow, or open source, or some kind of third-party developed. And in order to include this in the library, we provide CRT to register that these models are available. It's one of the tasks that the team, like IT admin, does. So this library of Fybrik takes in information about the models. The requirements came in front of actors from the left, and Fybrik makes the decisions. The first one, which the capabilities are required for the request. Do I need to cache it? Do I need to move that data close to the workload? Maybe something else? Where each of these capabilities need to be run? If we have several clusters, we can run in different places. And the last one, it's maybe a more technical level, which type of capabilities deploy. It may be a multi-tenant or single tenant, etc. And usually can be more than one answer of these questions. And Fybrik has a very unique optimization capability to determine which is the best balance between all different requirements of all different actors. It scores the decisions, which is the optimum one. The optimization is done based on all of the items listed here in red, provided by different actors. It can be data governance decisions, types and requirements of the workload, what is the capabilities of underlying infrastructures, what's the cost and performance. And ultimately decides what to deploy and where to deploy as optimal as possible. And Flora, if you can go to the next slide, maybe slightly deeper dive. Of course, we cannot go to all details. We have very short time. If somebody is interested, we can provide offline deep dive. But in general, Fybrik, which we call the control plane, is interface with three external systems. One is the data catalog, in order to get information about the data set, the intent of the data set, and no less important, the metadata about these data sets. And typically in catalogs, of course, they store the links to the connections, how to access the data. Credentials for accessing these data sets may be stored in the data catalog, or may be stored in external credential manager. And the last one, it's data governance engine, which Sabrina, as a government officer, uses to define and evaluate the rules. The agent itself provided to Fybrik decisions. So the Fybrik, through the data policy connector, says which is the context. This is the data is required. What we want to do with the data? Maybe reading, writing, copying, ingestion. And the data policy agent returns not the rules, but rather the decision about the context. And Fybrik then uses all this information plus library of models in other words, a library of capabilities, addressing the non-functional needs, and runs its optimizer and creates a plane of what capabilities is the flow data between these capabilities, where each of the capabilities has to be deployed, and ultimately generates what we call the plotter, which is an overall view, and Blueprint Controller actually does deployment on each of the relevant clusters. And it's a very high level descriptions, and again, we will be happy to provide more details.
Fantastic. You mentioned, we're looking at the side of implementation. Now going back to the ING side, Maryna, could you tell us about what was your experience like working with the open source? What was your role? And just give us a feel for what it was like to be on the other side of this.
Yeah, typically I think when one thinks about open source, either contributing or working with open source projects, one would not necessarily think of a bank as a top contender to do so. But it's interesting enough, we, at least from ING perspective, do work together and contribute also with a number of open source projects. And Fybrik is a very good example. And I will say also quite a positive experience that we had so far. So it's all about collaboration. And from our side, we are bringing more or less real life examples, use cases and requirements from the industry perspective. So we mentioned already about the governance a little bit, especially being from the financial industry, and also me and Barry being an information architect, so quite dear to our work. But also from IT perspective and infrastructure, how do you optimize for the requirements and tasks that you have? On the other side, you have a Fybrik team who also have expertise in design and development. So it's a really good way to collaborate from different perspectives and to make sure that we design together, we brainstorm, but also do the validation on what we have developed or designed actually addresses the pain points. On the other hand, also, it's an open source area, right? So for engineers, and we also have quite a lot of engineers in ING, it's quite interesting area to participate. And we also had an engineer from our side, and she contributed to design and development of the feature itself. So she also was quite happy that she got to work as a part of the bank on open source. I think another benefit worth mentioning is the ability to do POCs and POVs in this setting of collaboration. Again, coming back to having an opportunity to validate what has been, developed and designed actually addresses the use cases. And generally speaking, Fybrik being also open source not only helps with somewhat freedom and flexibility to collaborate, but also helps more with the speed and kind of depth of the innovation itself, because it's a bit of a different setting that you're working with as an open source community as well.
Good. With that in mind, thinking about the next steps, working with a bank is something that most open source projects, are dreaming of in terms of their roadmap. For the folks at Fybrik, Flora, Alexey, what's the status? What are the next steps? What can we expect to hear about in the future regarding Fybrik?
So in the last pilot we have done with ING, we added features of optimizing storage cost and optimizing latency depending on the declarative needs of the personas. So this is something that we would like to enhance more. There are many more options to optimize user optimization across different clouds and different cloud providers and different cloud locations. And let me share another slide, which I would like to give credit to, just a second, to Einat O, who prepared it. It's a slide that shows the landscape of different data-related technologies on cloud, of course. And we have here red rectangles, which is different technologies or open source. We already integrated, as Alexey mentioned, we have a library of modules with different capabilities. And connecting to other open source technologies or open source or technologies, we actually enlarge our capabilities to read different formats. For example, using Trino to read iceberg format. And so we also want to enhance and enlarge our library by connecting to different open source. And we have here in red those that we already connected to, and some with dashed red, which we explored, and yellow ones are the ones that we are planning to go forward and do. And in addition to connecting to different technologies and enhancing our libraries, we have also additional use cases in mind, like masking and transforming on unstructured data, like images, forms, signatures, license plates, etc. It could be even on audio files, or there are many options to enhance Fybrik, and it actually depends about the customers that will be interested, what will be interesting for customers. And we invite other open source folks to join us, collaborate with us, bring other needs. We know there is need to govern sensitive data in logs, for example, and messages and different applications. So the sky is the limit.
Sky is the limit. I think it's a very good way to finish. There's a very broad landscape, lots of different opportunities to get involved, and seeing the value that's being provided here, I think is very promising. Thanks to everyone for joining us on this panel. As Alexey mentioned, there are a lot of different things that weren't covered that we should definitely cover, hopefully in a second session at some point. So you can definitely expect to hear more about Fybrik in the future. Perfect. Thank you very much. Cheers.
Thank you very much, everyone.
Thank you.
Cool. Good. Awesome. Good job. Few things are more terrifying than seeing your face really big on a screen, at least for me. That being said, if you want to find more about the Fybrik project, you can definitely contact Flora or Alexey in the DoK Slack. Now we're going to take a quick 15-minute coffee break. So if you want to go outside and have a drink, enjoy, socialize, and we'll be back for some more talks. Let's keep it up, everybody.
Your immunity in the DoK community, so much skill, you know that we bet the horn. Yeah, that's right, DoK community. Get ready for DoK Day, October 24th. If anybody wants to battle me, you know where to find me, and we'll bet the horn on it. Who's that? Stateless Stew? You want to battle me for the horn?
Yeah, that's right, homie. My style. Joe, DJ, spend that.
Round one. Yo. I'm taking that horn like the firstborn. I make waves and storms, stateless raves and swarms. Take your state, you mourn. You say your source is open, what kind of scam is that? Get a haircut, fool, looking like an underfed cat. Database and storage, boring, I'm flooring and goring. Keep my data safe outside of Kate's, backed up and restoring. You call this a community? This is you all alone. Stateless, my greatness delivers like the mailman alone. Let's go.
everybody from the 313 putting the stateful hands up for the DoK CEO. Now everybody from the 313 putting the stateful hands up for the DoK CEO. Now while he stands tough, gonna rock him, sock him, drop him if he doesn't keep his hands up. Yo, this tunnel vision got you on the wrong mission. Don't be rating my state, that be running with precision. Just an urge like Urkel Steve, believing, heaves and leaving, freaking, leaking, freaking, speaking, tweaking, blinking, stinking, reeking. Double trouble on the daily double, you won't ready. Who burned a Yeti, boop, stir Betty through webbing. Luger is heavy, dream so rug, got Freddy Krueger sweating. Sharpen claws like Vegas, stew in a stew of Freddy. Saurus Stega, Mega Data, Raider, well, Joe, Beta, Betty. Uber's wedding, Jada, Pickett, speaking, click it with super trooper steady. Grateful, stateful, lapse with the data, belongs to Kubernetes.
Hi, I'm Tim Spann, developer advocate for Apache.
Spann out here. Let's Spann out here. Let's Spann out
I got the blues. Take me away. Autoscaler, take me down the way. Well, my state sail was stateful. I'm taking my mind away. I got these autoscaler blues. Can take my heart today. I've got these autumn blues. They're shaking me down all the time. Cause my load balance is holding, darling. You know I'm gonna break it down. Till the sunshine and break through the darkness, singing me down and breaking my soul. Make me on run down the start of scaling blues. These SREs, they're shaking me down in my shoes. Cause the hard times are coming, got those alerts bringing news. Which cloud you gonna take? Where you gonna make your place? Cloud native all day, singing my soul and you're picking my space. I got that auto scaling blues, you're taking my time. How many words can you put with Kubernetes to rhyme? Come on, Dave. Taking it, breaking it down. You think I was the only boy living in this town? I got the auto-scaling blues. Can't bring my low balances down, balances down, balances down. Oh, a hard time is coming. I think I wanna wear that crown. Dave, I think I got my blues out. Woo! Pues tío, hoy va a ser bastante sencillo. Vamos a grabar unos vídeos promo para el DoK Day en KubeCon. Lo de siempre, ¿vale? Voy a sacar el cuerno de la funda, voy a hacer mis movidas y tal. Lo más importante, muy importante tener en cuenta que no me grabes desde aquí para abajo, ¿vale? Porque si la gente ve que estoy casi en bragas, que van a pensar que soy gilipollas o algo raro, ¿vale? Que no lo soy. Ante todo, hay que ser un profesional. Gonna get started with our next talk in a second, but as always, gotta keep things fresh and funky. So. Wow, doing stuff hybrid is different. We should do this every week. How are we doing so far? I think it's pretty good, and we're really, really happy to see so many people. As previously stated, please keep the tweets going, all right? Take pictures, meet people, do cool stuff, do stuff that's exciting. If you want to take a picture with the DoK horn, we got it right over here. Our next speaker is Yaniv, who's going to be joining us all the way from Israel. We can bring him on screen now. And he's going to be talking about data streaming, all right? So, like we said in the beginning with our research report, if you haven't checked it out, please do so soon. We're looking at the different workloads that are making their way onto into the data on Kubernetes ecosystem. So Yaniv is going to be joining us to talk about that, and I'll let him take it from here. So Sylvan, if you can let him know that he can start his presentation. Unmute. Yep, unmute yourself. All right. It's all good. It's all good. Just tell him to hang on for a second. This is really interesting. Now you see how the Super Bowl works. Okay, cool. So yeah. Is anybody currently doing data streaming on Kubernetes? Just out of curiosity. We got one hand in the back. That's good. One very enthusiastic hand. Excited to see that. So we see it with different formats. Whether we're talking about Pulsar, whether we're talking about other technologies, seeing how folks are doing that. If you check out the live streams that we've done, we've touched on this a few times, and you can definitely expect us to be talking about it more as it builds its sort of home in the data on Kubernetes ecosystem. Next question: is anybody here from Detroit? Yeah, we got one very one very humble hand in the front. That's good. Anybody else? Anybody else from? Yeah, one hand in the back. Very, very good. I think some of the folks on our streaming team are also from Detroit. They just don't want to raise their hands. But yeah, very, very nice to be here. Also nice to, has anybody traveled to Canada who isn't Canadian? Cross the border, folks. It's super close. It's definitely worth it. Definitely check out Canada. All right. So that being said, we can bring Yaniv on soon. Let's see if his audio, did we ever get an audio yet? That's okay. Still working on it. If you're trying to push me into singing a song, I will do it. Actually did forget to read the rap that I wrote after Holden's talk, so we can always have plan B, plan C, plan D. And I think we can all agree that Holden's dog is very cute. But anyway, I was going to do this later, but we can do this. So this was literally based on the stuff that Holden was talking about. Obviously will not meet the quality of her talk, but here we go. So Holden gets 6 out of 5 stars. She's got full rights with a green card. Works with large data sets. Loves her dogs and Apache Spark. She's hiring. What you know about Dask? What about Flink JVM with your batch tasks? Don't screw the pooch. State shouldn't be a big ask. Timbit like Horton works for me with my PS1 ports, helping us achieve better performance. Your dog is cute, and thanks for the perks. Thank you very much, Holden. Holden rocks. Holden rocks. Good people. Sylvan, can you tell Yaniv to talk? Yaniv, show yourself and share your beautiful voice with us, please. He's talking. Talk louder. No, I guess it's not coming through. You know what we could do is while we're working on that, why don't we run the next talk, which is Timothy Spann? We can just run his video, which is also touching on the subject of data streaming, which is why these two are together. The next one is the next video. Yeah. Yeah, the next video, we'll run that while we're getting Yaniv set up with the audio. Yep, Tim Spann, exactly. So Tim is no stranger to the data on Kubernetes community, and we'll be hearing from him shortly.
Hi, I'm Tim Spann, developer advocate.
But we still don't
for
have visual.
Apache
We're still
Pulsar.
seeing the
I
zooms
work
from
with Stream
Yaniv.
Native.
So
My
can we
talk
get out of
today
that? Building suspense for Tim, no pressure. Okay, cool. Good. Cool. This is Tim? Yep. By the way, Holden, I do have to ask. Timbit is a reference to Tim
advocate
Horton.
For Apache Pulsar. I work at Stream Native. My talk today is entitled Architecting Your First Event-Driven Serverless Streaming Application on Kubernetes. And that's my title because I couldn't think of a longer one, even if someone paid me. So it's really long. I tried to get all what we're trying to talk about in there. So I work on what I call the flippin' stack, which is Apache Flink, Apache Pulsar, and Apache NiFi together. All those one really nicely on top of Kubernetes or on VMs or in Docker or in bare metal or whatever you might have, even smaller handheld systems, whatever makes sense. I've been doing streaming systems and different data architecture at a number of companies. So that's ranged from things like big data, cloud, IoT, streaming, those sort of things. Worked at Cloudera, Hortonworks, Pivotal, HP, PwC, and now Stream Native. Every week I put out a newsletter, try to cover all the things going on in data, streaming, containers, Kubernetes, anything interesting open source out there. So subscribe to my Flipstack weekly, no ads in there. What is Pulsar? Apache Pulsar is an open source cloud native messaging and event streaming platform. So it's two different things in one. I know some people think messaging, event streaming, maybe the same thing. Not exactly. There's a little bit of variation in there. Now, from the beginning, when Apache Pulsar was first developed at Yahoo, it was built to be in containers, was designed for the modern cloud, designed when it was created, the thought of this is going to be in a hybrid environment, maybe multiple clouds. It's going to run in containers. It's going to have to support microservices. And it's something we're seeing a lot of people using because it's very hard to run these days without Kubernetes, and trying to get away with just one cloud is also a difficult thing to do. So when we said messaging and streaming, yeah, they're a little different. So with messaging, we think of message queuing, and different message queue systems out there tend to be used for work queues, usually don't care about order. It's a good way to distribute your code in different environments, especially something like Kubernetes, in different languages, different servers, environments, things that separate your apps from each other. This is a great way to distribute that, get code, get data from one place to another, have it executed RPC style, and all of it asynchronous and all of it durable. You're not going to lose your data unless you've designed it to be lost. That's your decision there. Now, streaming, pretty similar. This is where people get confused here. The difference is order is really important in streaming. And also we tend not to want to lose the data. I mean, in messaging, sometimes you're like, I'm firing the identical same message 1,000 times in a row. It's a status that rarely changes. Lose some data, resend it, whatever. In streaming, each event, each message, each record is really important. I don't want to lose it. Make sure the stream is stored, it's durable. I get things in order. I get things, I don't lose data. I can roll back, get the data again. These are things around Kafka, Kinesis. Common use case here is something like CDC, where I have a change happen on a production table, and I want that message, that record, that event that, hey, this record changed. Here's the old data, new data, what changed. Send that somewhere so you can update some other systems or to trigger some bit of code to happen when that happens. Oh, someone got a new deposit. Let's send them an email. Let's update another system. Someone left an account. Lots of things can happen when something gets changed in a relational database or a production system. So how does Pulsar work? Under the covers, as you expect in any modern, large, scalable system, we've got a cluster. Now, what's different about Pulsar is that it was designed to be cloud native. So we've got compute and storage separate. Metadata is somewhere else, and that metadata can be kept in something like Apache Zookeeper, but also now to embrace the Kubernetes world, could be an etcd, and you could use that to control metadata, names of topics, all those things that are ancillary to running the code. The Pulsar broker is handling, who do I talk to, who gets that message, pass it through, stateless, maybe a little bit of cache if need be. Underneath, Apache Bookkeeper handles storage. It's a real ledger system. This is not just a couple of flat files lining somewhere. Get 3 or more nodes, stripe your data, so we're not going to lose it if something weird happens. We make sure we keep consensus, and we make sure we don't lose data. Now, that's a lot that you could do with Pulsar. I don't want to do a full talk here, talk of all the hundreds of benefits there, scalability into the petabytes, thousands of nodes, support for multi-tenancy, which is awesome for Kubernetes. So we'll set up a tenant, namespace, and topics underneath there, all of them secure. So if I need to have just one big cluster and 1,000 apps on it, no problem. Support for millions of topics, great. So there's a lot of cool features. Built-in support for tiered storage. You decide you only want to keep a little bit of storage in the current cluster, maybe just last half hour, last hour of data. That's what's critical. And then I can have Pulsar automatically tier that out into S3, Google Cloud Storage, HDFS, ADLS2, whatever you might have out there. Great. But we want to build some serverless apps. It is kind of in the title. If you need to know more on Pulsar, we'll send you some links. So Pulsar Functions is how we do our serverless, open source serverless, not tied to any particular cloud or vendor. You can run this anywhere you have Pulsar, which is awesome. So a function is a pretty simple design. You specify a number of topics, and this is dynamic. If you need to change this, you could use the REST endpoint or the command line interface to just adjust how many topics go in there. So say I create a new topic, I could add it to this function to handle it. Like I've got one for sentiment. I got one that maybe looks up, addresses, all that kind of small functionality, microservices, do something on data. So we connect these topics to this function. So anytime a new event or message or record, whatever you want to call it, comes into a topic, triggers the function, we run that function's logic. And from there, if we decided to automatically map that to an output topic, when I'm done with it, I do my return, that result goes there. If there's an error or something I want to log, we'll send that to a log topic that you specify. What makes this even more powerful is inside the function, I could dynamically send that to other topics. So say I'm watching the data. If it's normal data, just send it to the output topic that you wanted. But if it has certain value, the results of sentiment or this, results of some machine learning or something else, I can create a new topic on the fly and send the data there. So say it was CDC. Oh, you sent me a new table. I better create a new topic, send that to there, so someone on the other side can move that into, say, a NoSQL database, what have you. Lots of options there. Currently, we're supporting Java, Python, and Go. Extensible API here in the open source. So if there's another language you want supported, like, say, Rust or Kotlin or Scala or something else, you could add that yourself and put a request out there, and we'll see what happens. Java and Python are awesome ways to do this. Support for all those libraries that you might want to use. Great way to get things done and do this in a very robust, scalable way and very easy to write. If you look at a function, this is an example one in Java. I just extend the function, say what the input and output are, do some logic in there, and then just return the results. Pretty straightforward. If I want to do, say, NLP in Python, import, say, Vader, import something to process JSON. I make a class, put an init if I have anything to do in there. Process is called for each event. That is that input value there. Context gives me access to things like the log, the ability to create a new topic, all those sort of things, forwarding and routing the message somewhere. Here, pretty easy code inside of Python. I'm just setting up a little row, converting it into JSON, and returning it to the output topic. Got that full source code available if you're interested. Now, to make this even more powerful, just having those functions and have them running in Kubernetes, great. Stateless, boom, deployed, event-driven, awesome. Now, to make it even more powerful, there is an open source project called Function Mesh. This allows me to build application pipelines that are a combination of sources which someone wrote already that can pull data from different places like MongoDB, MySQL, Kafka, Scylla, whatever you might have there. Combine your functions and maybe other ones. There's a bunch in the open source I've written and others have, and some syncs, create a pipeline together and build this whole thing out, deploy this in your own Kubernetes environment. Pretty easy for both Pulsar and the Pulsar function mesh. We give you all those YAML configuration files you need. You use standard tools like kube control, uses the standard Kubernetes APIs. We've got the operators out there for you to handle it. And it's very easy. All the Helm charts are out there. We've got all the documentation. Push a couple buttons and everything's deployed. Scale up, scale down, add more functions. Very easy. Wrap it all up in a GitHub and deploy. Underneath the covers, we have a full set of features in here: geo-replication, load balancing, support for other protocols. So if you want to have a Kafka streaming platform and Pulsar, you don't need both. Turn on Kafka support within the Pulsar cluster, and now you've got one Kubernetes cluster that lets you do Pulsar and Kafka same time, mix and match, send them back and forth between each other, built-in tiered storage, all open source. If you want to use Stream Native, has some extra operators to do a couple other features if you need to. Grafana, Prometheus, all of that is out there for you. Pretty straightforward. If you're interested, we got some cool videos showing you how to deploy your microservices, going in depth on different things you could do with functions. Pretty easy out there. Here's the link to the charts. Here's some examples. If you don't want to have to set up your own Kubernetes, which maybe you don't, just use Stream Natives, very easy. If you want to learn more on Pulsar, we've got an academy that you can get trained at for free. All on-demand training, very easy. This has been a quick talk. Hopefully you've learned a little. Join me at the rest of KubeCon in Detroit. I'll be in the Stream Native booth. We can go through some deployments, some examples, run through some code, and we'll have some other experts there to talk to. And enjoy yourself, and hope you like the rest of the conference. Thank you. It's been awesome.
Thank you, Tim. Much respect to you, Tim. This horn's for you. If you want to contact Tim, please do so on Slack. Right? He's always open for questions and answers. As he said, very, very active in all things related to streaming. He also mentioned he's going to be at a booth. Is anybody here going to be at a booth? Okay, we got some booth people. Good, strong representation. The DoK community this time has a booth for the first time. And Sylvain and I, this wonderful French gentleman over here, he and I will be staffing it, and we're going to be doing lots of cool stuff. And one of the things we will be doing is rapping from the booth. If you send us keywords, we will create a rap for you, and you can share that. You'll be happy. In addition, we will also be wearing costumes. I'm not going to say what they're going to be, but is anybody else going to wear a costume in KubeCon at some point? We've got time. You can buy one. Come on. It's going to be fun. Anyway, that being said, highly anticipated, very built up now. Yaniv, we've got high expectations. So Sylvain, if you can let him know that he can start, so we can.
Okay, awesome. Thank you very much, Bart. Great solo. So thank you for that. I always say when I'll grow up, I want to be like Bart. So cool as ever. Thank you for that. My name is Yaniv. Not a long time to cover a large project, a large topic. So 29 years old, married, 1-year-old kid with a golden retriever, which can be an extra boy sometime. A developer, data engineer, architect for quite a while, working with a lot of big data projects, data warehouses, and building real-time pipelines. CEO and co-founder of Memphis Dev, alongside with my 4 best friends from college. And when I have some free time, nature, sea, football, or soccer, and hanging out with friends, I always like to start with a quick intro slide about me. So Memphis, just a quick slide. It's not this deck or this talk is not about Memphis, but just so people would be aware of. So what is Memphis? So we are a message broker with the same behavior as Kafka and Pulsar that we just gave their session about. We also implemented the same behavior as Produce, Consume, Infinite Scale, and a message broker in the very simple shape of it on top of Kubernetes. So we are cloud native by design, but modern. So multiple protocols and languages. So all the way from HTTP, WebSocket, WebAssembly, gRPC, all the way to client side libraries, Java, Rust, Go, Python, and soon to be Scala as well. Fast troubleshooting and DLQ, something that we really, as a former developers ourselves, something that we are really highly invested in. So provide the ability to find root cause analysis around event-driven application and architecture can be a nightmare. So we really try to help out with different features and mechanisms that we implemented inside Memphis to find root cause in both at the data layer and also in the infrastructure layer. Modular connectors. We took the idea. We love the idea of how Herbyte did it. So basically, everyone can just implement their own connectors without waiting for the vendor team. So that's the exact thing that we implemented. So frameworks of connectors that everyone can just implement their own connector as they need, and better data quality. So better data quality in general is something that is really in the media lately. We have so many data producers of so many protocols and so many types around partners and marketing and different infrastructure and events that shooting at us from different interfaces, both internally and externally. So we're really making sure by using schema management, or how we call it schema-verse, and data contracts embedded inside Memphis to help developers and our users to ensure data quality while they're doing data streaming with Memphis Broker and with Apple-like developer experience, which I think is the most important part. Working with Memphis is easy, and implementing Memphis and implementing use cases on top of Memphis is really, really easy. So basically a quote from our users: 3 minutes to do in Memphis what took me a week and a half in Kafka. So definitely doing a lot of work there, and sync SQL, not just data. So at the end of the day, or at the other side of the pipeline, we also provide ability to shoot SQL statements and not just raw data to be reside on the other side. Again, to help reduce the work or the amount of code that the developers require to do around building event-driven or real-time applications and pipeline. So that is Memphis. It's not our talk. Our talk is about data streaming. So I'd love. I've been in Big Data London recently, and I've seen this sentence, and I think it summarized the entire concept of data streaming. So, would you cross the street with data from 10 seconds ago? So, in general, it means that in the past years we've been patient enough to receive data or generate outputs in seconds, but nowadays we're talking about milliseconds. and let's figure it out a bit more about data streaming before reaching out how we can actually do it or implement a solution. So data streaming is all about frames and not bulk. So instead of analyzing or moving your data in batch, we need to start changing our mindset and working on frames or a single event or a single message, and do a pre-processing or inline processing and not post-process. And in the coming slides, we will understand why it's so important to make this transition towards data streaming, because working in batch is probably much more simpler than working with data streaming. But as we will understand in the coming minute, there are some use cases that you just can't do, or you won't be able to get enough performance when you're working as a whole and not frame by frame. Another crucial thing in data streaming is that the data tab is always open. So there is no windows, there is no breaks. Data is always ingested and always flowing to our systems, to our microservices, to our data lake, and data in motion between different services. So usually when we work with batch or when we process in batch, we have a single source of truth. So probably a data warehouse that ingested, that all the data ingested into it, and then we can, in our available time, do some processing on top or run some SQL statements and do it on basically large time windows that allows us to freely analyze and transform the data on top of the data warehouse. So data streaming is really about data in motion. So it flows between different services, different applications, and we need to control all those flows in some way. So that's the complexity of doing data streaming and not having a single source of truth for our data. So so streaming make things complicated. Why do we need it? So data is going too fast to process as a whole, and we need faster results, right? Because we mentioned that in the last years we've been we tolerate seconds of response time or latency, and nowadays we need milliseconds. And I used a use case or a quote from one of our users. It's a company that's creating a really revolutionizing collaboration security, and they build these amazing algorithms that can take large amount of data and process it in minutes and get a full picture of if there is some breach between the communication of the internal entity inside the organization. So it takes them 3 minutes to process like a huge amount of data inside a very large and branched organization, but it takes them an hour to bring the data. And when we speak about or talk about cybersecurity use cases, just imagine that you have some breach or some threat inside your organization that has been live for seconds, even not minutes, not hours, but seconds. Imagine the amount of damage that it can do, and if we implement such a use case or such an application that can protect us from different breaches and threats, we definitely need to process or reveal an outcome much sooner, in seconds or in milliseconds. So we've talked about data streaming, talked about why do we need it, and there is also minor thing that we should be aware of. So data streaming has different infrastructure characteristics than working with batch. So spikes. And I think if I need to summarize it, it means uncertainty. So unexpected workloads in data streaming is something that happens really often. So high memory consumption and unexpected workloads, that's something that we can expect to happen in quite often in the modern organization. So basically we can have we can have one data producer that can basically crash our entire cluster, or a message broker or a data lake. So we need to be aware that the workloads can spike, and it would be consuming high, and it would consume large amount of memory. So we need to be aware of it when we prepare our infrastructure for such use cases or such environments. Storage that should sustain thousands of IOPS and fast readings, and also security. So nowadays we have hundreds of or thousands of different consumers and producers. How do we control the entire thing? How do we audit of who consumed what and who did what to the data while in transit? So definitely security. And if I need to summarize the entire concept, is scale on demand, made by code, and triggered by events. So those are like the main consideration when you start to work with data streaming or creating an internal data streaming platform. So data streaming, infrastructure characteristics, why on Kubernetes? So again, scale on demand, made by code, and triggered by event. Those are the things that we can receive when we work with Kubernetes. So we get the hardware abstraction, right? Instead of be attached to our compute or storage, we get that abstraction that Kubernetes beautifully gives us. So we get the attachment or decoupling between the hardware and compute and to the application itself. Cost effectiveness. So if we talked about unexpected workloads, just imagine that we need to wake up a DevOps engineer in the middle of the night saying, listen, I need to get that output from our data streaming or from our streaming app, and I need more scale or more power to do so. Instead of just be able to speak with the Kube API and run actions that would scale our pods or scale our compute resources automatically based on events. So it can happen only on Kubernetes and less with EC2 or virtual machines. And last but not least, scalability. So as we already know as mature engineers with Kubernetes, that scalability in Kubernetes environment compared to EC2s, virtual machines, bare metal servers is definitely a different world, and it makes our lives a much more easier to scale when unexpected workloads are coming, and so data streaming on Kubernetes definitely make things much easier in times of need. And in data streaming or when working with streaming application, it often arisen much faster or much sooner than you think so. So definitely, if you already started to work through or to encapsulate such a solution or build your own data streaming platforms or solution inside your organization, definitely make sure that you put under your consideration to do it on top of Kubernetes. Just a quick overview of the landscape today. So we have Pulsar, Apache Pulsar, which is a great solution for running a message broker or streaming queues on top of Kubernetes. We definitely have Memphis, and we would love to be used by the community. And we also have the new product in town. So it's StreamZ, which basically does Kubernetes version of Kafka. Definitely should check out whoever use Kafka. And that is all from my side. I hope that I succeed to do so in 15 minutes.
Cool. Yes. Good. Awesome. Thunderous applause. Very well timed. This is a very well trained audience. If you have questions that you would like to follow up with Yaniv, feel free to do so on Slack. Next talk actually is one of the most important things that's going on right now in the Data on Kubernetes community. I would like to invite to the stage, well, actually just for a little bit of context, for over the last year, we've been working with a team of interns from various countries that are excited about learning all about the different technologies that we're using, that are ready to jump in and want to get hands-on experience with the stuff that we're doing. And so it's been a very long and interesting learning process, and I'm very, very grateful for all the patience and support that our interns have shown us. We're now in our third cohort, and one of the things that we're doing is a new initiative called the DoK Explorers. And so what we're doing, I mentioned in the intro, about the DoK landscape. All right, so making it easier for folks that are getting started out with this, about where do I go, what's going to be the best fit for me. So what we're doing with the explorers is going through the landscape and just checking out what are the first sort of actions that folks can take if they're going to be using those technologies, and that way get hands-on experience and be able to share it. So with that being said, I'd like to invite Bhavin to the stage. Bhavin is one of our interns who came all the way from Nigeria for KubeCon. So let's give him a round of applause. Yes. So I would just like Bhavin to introduce himself, and then actually we probably need 2 microphones. Yeah, amazing. You're the best sound people here. Thank you. So, Bhavin, who are you?
Hello, everyone. I'm excited to be here. My name is Odazzie. I'm a developer advocate and technical writer, and as Bart said, I came from Nigeria. And currently, I just recently joined the DoK community to contribute and help build out the DoK Explorers Challenge. And it's been exciting and challenging, as Bart shared, but we're looking to get a lot of people involved in data on Kubernetes from the hands-on approach, which can be quite complex. And yeah, thank you, Bart, for the opportunity to introduce myself. And we have...
Well, we'll get to that in a second, but we want to learn more about you. How did your Kubernetes journey start? How did you get involved in all this stuff in the first place?
Okay, so I've been a developer for the past 5 years. So I've been doing stuff with Docker and Docker Compose. So I've been writing technical articles for like 2 or 3 years. So like learning more, I'm always someone who loves to learn. So when I left my previous full-time role, I started going deep into the cloud world. And yeah, I've used Docker Compose for a lot of use cases. Then I encountered Kubernetes, and wow, I was so excited and started researching more and learning more and trying to get more involved in the community. I joined the DoK community over a year ago. And yeah, that was my Kubernetes journey.
No, it's great. And in terms of what we're doing in the Explorers Initiative, we have different people with different skill sets. So we have some that are going out and doing research to learn more about how the technologies work. What's your specific role in the team?
So like I said earlier, I'm a technical writer and developer advocate. So I'm currently leading content delivery, creating content. So the stuff I've experienced and when learning Kubernetes is not everything is kind of like beginner friendly. So as a beginner in Kubernetes as at that time, so bringing that beginner's perspective and my technical writing experience. So the DoK community, I'm going to be leading content delivery and making everything like easy to onboard beginners and also give experienced developers that like clear, concise, and straightforward content.
Absolutely. I think that's one of the challenges that we all face is to make things as technically inclusive as possible so that everybody, regardless of their background, can get involved. That being said, we're going to play a video of one of the other members of the DoK Explorers Initiative. His name is Tapan. It's the video -1. And so they're looking at the specific challenge, and Bhavin was involved in helping him create slides to get the content right for this, talking about the importance of backup and restore when working with Kubernetes. So that being said, if we can play the video -1, good, and we'll be good to go. All right, Bhavin, thank you.
Hello, everyone, and welcome to the DoK Day at KubeCon North America 2022. I'm Tapan Halani, the DoK Explorers intern and a freelance cloud solutions architect based in India. And it's my absolute pleasure to be presenting before you guys here at KubeCon. Well, today my pleasure is doubled because as we tech enthusiasts are celebrating open source here at KubeCon, we, the people of India, are celebrating Diwali, the festival of lights all around the world to celebrate peace, hope, and prosperity. So from all of us at DoK community, a very happy Diwali to all of you. May your KubeCon experiences be as phenomenal as the illuminated night of Diwali. Today, I'll be talking about a very interesting topic. Our first project as DoK Explorers intern, something that is considered to be a day-2 operations task, yet it's absolutely necessary for any production-ready Kubernetes native architecture. Today, I'll be talking about backups in Kubernetes. How has the deployment of stateful applications changed? Well, this slide will give a rough idea where on the left side, we see a traditional virtual machine-based not highly available data application. While on the right-hand side, we see a Kubernetes cluster with two stateful applications, one database and one cache, designed in a highly available way. The single biggest difference here is that in traditional way, the application process, the data application is running on one particular server, which is why the disk volume also needs to be attached to only that server. Basically, there is a static mapping between application, the virtual machine, and the data disk. Whereas with containers, Kubernetes cluster topology becomes very dynamic. The pod can be scheduled on any worker node in the cluster, which means the data disk of the application pod also needs to travel with the pod. With this difference in the mind, let's start jotting down the differences in the next slide and also take the right-hand side diagram with us. So the first difference, dynamic topology, which basically calls for a backup solution that can discover where the stateful application pods are running and back up their data volumes. Different type of components. Well, to run an application in Kubernetes, we submit a set of deployment manifests to the Kubernetes control plane, based on which it creates Kubernetes resources for the application, like stateful set, pods, services, service accounts, persistent volumes. The application deployment is considered successful only when all of these components are in a ready or running state. Therefore, a full, easy to restore backup of any application in Kubernetes needs a backup of all these underlying Kubernetes resources. Failures for misconfiguration by developers. Well, contrary to the traditional way of handling infrastructure, Kubernetes has been helping teams become agile by adopting two key DevOps concepts. First, removing the barrier between developers and operations, basically making the application developers the owners of the respective infrastructure. And second, the shift left approach, which basically means shifting the testing, quality, and performance evaluation phases early in the software development lifecycle away from our precious production deployments. But misconfigurations can still happen, which might cause data loss or corruption, or render a particular part of the cluster in a failed state. Again, we need a solution that is Kubernetes native, which can reliably back up all the required Kubernetes cluster components without the need of manual intervention or any change from application developers or operations team. Application-aware data backups. Well, in other words, it's also called application-consistent data backups. They not only capture disk snapshots at one point in time, but also flush pending I/O transactions and in-memory data to disks before snapshotting, basically providing a holistic backup capable of faster and reliable restores. That's good, but how is this different in Kubernetes? Well, if you see the diagram of our highly available database, if you see the diagram on the left side, our highly available database and cache applications, they are deployed as 3 replica stateful sets in the cluster with pods running on different nodes. A truly application consistent backup needs to capture the state of all the pods at the same time, which requires the solution to not only discover, but also access the application and its state for a backup. Security. Well, all the above points reiterates the need for a Kubernetes native backup solution which can discover and access multiple resources in the cluster. This ability in itself can pose a security challenge. Backup solutions must have only enough permissions to securely access application and data components, create a viable backup, and securely store the backup with proper access and encryption settings. The access to the backups and ability to restore must also be tightened using Kubernetes and Cloud IAM and RBAC to prevent malicious access to data and backups. So now that we know the differences between a traditional and Kubernetes native backups, let's move to the different components which should be a part of the Kubernetes backup. What we see here is a functional view of a Kubernetes backup. We see here stateless Kubernetes resources, which can be backed up as live manifests. Stateful Kubernetes resources like persistent volume, which basically represent a cloud storage, such as hard disks, backed up as CSI volume snapshots. But there's an important third component. What if the data store used by the applications in Kubernetes is running outside of the Kubernetes? For example, an AWS RDS instance or an Azure cache for Redis cluster. Though these are fully managed services from cloud vendors with their own tooling for defining backups and restore processes, they become a vital part of Kubernetes, or rather, cloud-native backup strategy to provide a holistic and application-consistent cloud-native backup and restore process. Let's dive into the existing solutions in the market that provides us Kubernetes native backup and restores. Many of these you can also find on the DoK landscape page. This list is definitely a non-exhaustive list. These are the solutions that we, DoK Explorer interns, have had the chance of going through while our research project. For today, as we move towards the end of the presentation, I'll take up Cloud Casa as one of the solutions to describe how it solves the Kubernetes native backup and restore problem. So, backup as a service with Cloud Casa. With Cloud Casa, you can protect all of your Kubernetes clusters, cloud application data, manage cloud storage. You can have unlimited container storage snapshots, and you don't have to pay any upfront costs, or you don't need to manage any servers or install any servers. Well, that's a pretty good set of features for a cloud-native backup as a service solution. So, as we move towards the end of the presentation, I would like to thank everybody to take out the time to listen to us, and a big shout out to the DoK Explorer interns, the team without which this project wouldn't have been as fun as it had been. And yeah, we are looking for more interns, more like-minded people to always join us to get into this, to get to know more about the cloud native, Kubernetes native problems, and to discuss about such solutions. And a very special thanks to the 3 mentors in the DoK community, without which our project wouldn't have been this fun or this smooth. Abhijit, Bart, and Sebastian, thank you for helping us out with Cloud Casa, with data on Kubernetes. It has been a phenomenal experience, and hope you guys have enjoyed the presentation. Hope you guys enjoy the rest of your KubeCon. This is Tapan Halani signing off.
Very, very good. Thank you, Tapan. So, that was very, very, like I said, if you want to find more about the DoK Explorers Initiative, we have a Slack channel that's specifically focused on that, and so there is going to be a lot more content coming out about that. That being said, we are right on time for lunch, so we will have lunch, and then we'll be back in about an hour. We got more talks in the afternoon. Keep the energy up, folks, all right? Positive spirit. Let's keep interacting. Let's keep networking. Let's keep sharing, caring, and loving, and let's go have some lunch. Enjoy. Cheers.
Spann out here. Spann out here. Spann out here.
I got the blues. Take me away. On a scale, take me down the way. Well, my state sail was stateful. I'm taking my mind away. I got these auto scaling blues. Can take my heart today. I've got these auto blues. They're shaking me down all the time. Cause my load balance is holding, darling. You know I'm gonna break it down. Till the sunshine can break through the darkness, singing me down and breaking my soul. Baby, don't run, gotta start scaling blues. These SREs, they've been shaking me down in my shoes. Cause the hard times are coming, got those alerts bringing news. Which cloud you gonna take? Where you gonna make your place? Cloud native all day, singing my soul and you're picking my space. I got that auto scaling blues. You're taking my time. How many words can you put with Kubernetes to rhyme? Come on, Dave. Taking it, breaking it down. You think I was the only boy living in this town? I got the auto scaling blues. Can't bring my low balances down, balances down, balances down. Oh, a hard time is coming. I think I wanna wear that crown.
Data Dave, I think I got my blues out. Woo! pues tío, hoy va a ser bastante sencillo. Vamos a grabar unos vídeos promo para el DoK Day en KubeCon. Lo de siempre, ¿vale? Voy a sacar el cuerno de la funda, voy a hacer mis movidas y tal. Lo más importante, muy importante tener en cuenta que no me grabes desde aquí para abajo, ¿vale? Porque si la gente ve que estoy casi en bragas, que van a pensar que soy gilipollas o algo raro, ¿vale? Que no lo soy. Ante todo, hay que ser un profesional. Como dice mi suegra, hay que hacer las cosas en condiciones, ¿vale? Entonces, voy a abrir la funda y lo de siempre, ¿vale? Pero bueno, por favor. ¿Dónde está mi cuerno? Alguien tiene que decirme dónde está mi cuerno. Me cago en todo. ¿Dónde está mi cuerno? Ya sabéis que tenemos poco tiempo, hay que hacer ese evento. Y si no tengo mi cuerno, no puedo hacerlo en condiciones. ¿Dónde está mi cuerno? ¿Quién lo ha robado? Es que me cago en todo, hijo de la gran Perkins. ¿Dónde está mi cuerno? Chicos, lo voy a buscar por todos lados, ¿vale? Primero, borrar, no subir nada de lo que hemos grabado hoy, ¿vale? Y lo voy a buscar. Lo voy a buscar, es que no sé dónde estará, pero lo busco, ¿vale? Os llamo en cuanto tenga más información, ¿vale?
Sí, tío, Bart ha perdido el cuerno. ¿Qué te voy a contar? Otro día en la oficina.
Joder, ¿dónde está el maldito cuerno? ¿Cuántos recuerdos tengo de él? Nos define como comunidad y forma una parte íntegra de nuestra historia. Y ahora, desaparecido. ¡En esas cajas! ¡Está en las cajas! ¡El cuerno! ¿Dónde estará? ¿Cuerno? ¿Dónde? ¿En qué parte? ¿Dónde estará? Tengo que ir casa por casa, lo voy a encontrar. ¡El cuerno! Nos define como comunidad y forma una parte íntegra de nuestra historia. ¿Cuerno? ¿Dónde estará? ¿Dónde? ¿En qué parte? ¿Quién me está llamando? ¿Dónde está el cuerno? ¿Me cachas en la mar? Dime de una vez.
Hey Bart, tienes DoK Day en breve, pero ¿cómo vas a hacerlo sin el cuerno? Te he dejado un regalito en Twitter de DoK Community. Si te cuesta, igual te doy una pista. Ya sabes que solo nunca encontrarás el cuerno. Usa tu comunidad.
All right, everybody, you gotta help me. Go to the DoK community Twitter right now. The puzzle is gonna be posted on there so we can figure out where the horn is.
From Derry Quay we sailed away on the 24th of May. We were boarded by a pleasant crew bound for America. Fresh water we did take on board, 5,000 gallons or more, in case we'd run short on the way to New York, far away from the Shamrock shore. So fare thee well, sweet Liza dear, likewise to Derry town. And twice farewell to my comrade boys who dwell on that sainted ground. If fortune it ever should favour me, or I'd have money in store, I'll come back and I'll wed the sweet lassie I left on Paddy's green shamrock shore. Well, we sailed 3 days, we were all seasick, not a man on board was free. We were all confined to our bunks, no one to pity poor me. No father, no mother, no sister did hold up me head when 'twas sore, which made me think more of the lassie I left on Paddy's green shamrock shore. So fare thee well, sweet Liza dear, likewise to Derry town. And twice farewell to my comrade boys who dwell on that sainted ground. If fortune ever should favour me, or I'd have money in store, I'll come back and I'll wed the sweet lassie I left on Paddy's green shamrock shore. Side in 24 days. We were taken as passengers by a man and led off in 6-foot-long dray. We each of us raised a parting glass in case we should never meet more, and we drank a health to old Ireland and Paddy's green shamrock shore. So fare thee well, sweet Liza dear, likewise to Derry town. And twice farewell to my comrade boys who dwell on that sainted ground. If fortune it ever should favour me, or I'd have money in store, I'll come back and I'll wed the sweet lassie I left on Paddy's green shamrock shore. I'll come back and I'll wed the sweet lassie I left on Paddy's green shamrock shore. I'll come back and I'll wed the sweet lassie I left on Paddy's green shamrock shore.
Yo, immunity in the DoK community. So much skill, you know that we bet the horn. Yeah, that's right, DoK community. Get ready for DoK Day, October 24th. If anybody wants to battle me, you know where to find me, and we'll bet the horn on it. Who's that? Stateless Stew? You want to battle me for the horn?
Yeah, that's right, homie. My style. Joe, DJ, spend that.
Yo, I'm taking that horn like the firstborn. I make waves and storms, stateless raves and swarms. Take your state, you mourn. You say your source is open, what kind of scam is that? Get a haircut, fool, looking like an underfed cat. Database and storage, boring, I'm flooring and goring. Keep my data safe outside of Kate's backed up and restoring. You call this a community? It's just you all alone. Stateless, my greatness delivers like the mailman alone. Let's go.
Everybody from the 313 putting the staple hands up for the DoK CEO. And everybody from the 313 putting the staple hands up for the DoK CEO. Now while he stands tough, gonna rock him, sock him, drop him if he doesn't keep his hands up. Yo, this tunnel vision got you on the wrong mission. Don't be rating my state, that be running with precision. Just an urge like Urkel Steve, believing, heaves and leaving, freaking, leaking, freaking, speaking, tweaking, blinking, stinking, reeking. Double trouble on the daily double, you weren't ready. We burned a Yeti, boop, stir Betty through webbing. Luger is heavy, dream so rug, got Freddy Krueger sweating. Sharpened claws like Vegas stew in a stew of Freddy. Saurus, Stega, Mega Data, Raider, well, Joe, Beta, Betty. Uber's wedding, Jada, Pinkett, speaking, clicking with super trooper steady. Grateful, stateful, laps with the data, belongs on Kubernetes.
Oh, wind from the south makes every garden so green, brings the fish to the waterfall, abundance of fruit to the tree. It is far to the north, I think you are wanted to blow, to the country I know. He was a father, a brother, a sister, a lover, a son. Now he's pressed to the Navy, now he's nothing to no one. The rats and mosquitoes are all the companions he sees, and he longs to be free. Mayday, 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 mayday. They're dancing the ribbons, entwining the family tree. The years are nearly done, and these decks will be bleached by the sun, and the foreign wind will blow, and the Gulf wind will carry us home. From the south, from the south. It is far to the north, it's far to the north. You are mine, let it blow. Oh, and from the south, from the south. It is far to the north, far to the north. You are mine, let it blow. Oh, and from the south, from the south. It is far to the north, far to the north. You are mine, let it blow. Oh, and from the south, from the south. love.
That was a nice lunch. It's good to eat. Get some water, get some coffee. So we're going to be kicking off the second half of the day with an action-packed panel about databases on Kubernetes. Why are they important? This is something we've talked about a lot, but not with the mixture of people we're going to have with us up here on stage. We didn't really make a final decision as to whether you prefer to do it sitting or standing. Do we have a preference? Standing? Standing's fine. Wow, they solved that. Good job. That's good. Solving stuff. That being said, I hope you enjoyed some of the entertainment videos that we were sharing. If you don't know the community, if you're new to the community, we really embrace doing things differently, artistic stuff. If you play an instrument, please let us know. I also found out that our amazing sound team converted a church into a recording studio. It's called Plymouth Rock Recording. Check it out. It's in Detroit. It's amazing. I hope to go there this week while I'm here in Detroit. But that being said, we can get our panelists up here, and we can get rocking. And if we need to share microphones, we will. And we're all friends here. So please come to the stage, and let's welcome our panelists with a round of applause.
Woo!
Hello, hello. If you want to sit, you can. That's fine, too.
Sit where?
Just right here. You can sit there if you want.
I like the interrogation light.
I can scoot in. Yep. All right, we're good to go, right? Yeah. All right. Does somebody want a chair? I'm good without a chair. I'm good.
It's much more lively like this.
Go on the edge
Xing,
and you get the less bright.
You got enough spot there?
Yeah, make Gabriele get the light. All right, well, good morning, good afternoon, and good evening, wherever you are. Coming to you from Detroit, and I hope everyone is doing well and staying safe. If you are new to that phrase, that's Bhavin and I run a Kubernetes Bytes podcast. So that's how we open every show. We figured we'll open it the same way. Bhavin, what's going on today? What are we doing?
Yeah, so we are here, we have all of our not all of our, but a few of our favorite Kubernetes Bytes guests that have been on the podcast to discuss different topics. We thought, let's bring everyone together for database or data on Kubernetes to talk about databases on Kubernetes and why they are important. So that's what this quick panel is about. If you're looking for introductions, as Ryan said, Ryan and I run the Kubernetes Bytes podcast, but why don't we introduce ourselves quickly and then we can get to the questions. Patrick, you want to go first?
We're going to go that order. Hi, I'm Patrick McFadin, antagonist in the Kubernetes community and data. I work at DataStax. I work in developer relations. I also work on the Cassandra project, which is why I have a cool T-shirt.
Nice. Hi, everyone. I'm Gabriele Bartolini, and I'm from EDB. And I've been using Postgres for more than 20 years. Postgres is my passion with open source. And here I am today talking about running Postgres and databases in Kubernetes.
Awesome.
And I'm Xing. I work at VMware at the Cloud Native Storage team. I'm also a co-chair in the Kubernetes 6 storage.
Great. Okay, so we do want to actually send a little poll to those in the room. Who here is actually running databases on Kubernetes today? All right, so a good amount of hands. That's awesome. That helps us out a little bit. So what's our first question?
Yeah, so I think, I know a lot of people raise their hands, but the basic question that we always get at our day jobs and for the community participation that we do is, why run databases on Kubernetes in the first place? And I think that's the best place to start. Let's just get some opinions out of the way, and then we can jump into other questions. So we can decide on an order. Whoever wants to go first, let's go.
Go that side and this way. This
All right.
Yeah, that works.
Xing, you're up then.
Okay, so I think DevOps are already running applications in Kubernetes. So they want to be able to manage their data layer the same way that they manage their applications using the same tools and APIs. And also with Kubernetes, you can easily deploy and scale your stateful workloads.
Yeah. Thanks. So should I go on?
Yeah, go ahead.
I think that my best answer is that it depends actually on the personas. So for example, if you are a developer, maybe I'm talking about Postgres because that's in the database I know, and I don't think it's right, that I talk about other databases. But anyway, so if it's already difficult to talk about one. So if you're a developer, you might be interested in, for example, the capabilities of databases like Postgres offered to you, and you want to bring them in Kubernetes. If you are a Kubernetes administrator, you might be interested in declarative configuration, infrastructure as code, and things like that. So you're looking for an operator that can help you manage databases in that way. But my favorite is, from a kind of higher level, is about, again, what Xing was mentioning about DevOps. We call it DevOps, but it's actually culture. So it's about the generative culture that I always say Ron Westrom, if you look for that, is a very interesting model where you can break the barriers between developers and, for example, administrators and database administrators, and put together databases with the applications inside Kubernetes. That's my favorite view. So that's a higher reason for using databases in Kubernetes.
Thank you, Gabriele.
All right, if you're running a database outside of Kubernetes, then you cannot call yourself cloud native. Don't. I will call you on it immediately, because you're running your infrastructure in two different places. Might as well run a mainframe. Go ahead. They're still out there. But we're not going to do that, right? We're going to run everything the right way. And until we have a better orchestration framework, Kubernetes is the winner. And if you don't believe me, then why are you in Detroit? This is the future that we are trying to build. We've always been trying to build, which is highly automated infrastructure that just does what we need to do. But we're getting to the point now where our infrastructure will conform to our application and not our application conforming to our infrastructure. And how do we get there? We need to be able to do things declaratively, bespoke. And right now, databases are not that. When you install a database, you pray, you make promises, you create this edifice that everyone has to pray to, and you create these gods among men, which are called DBAs. That era is over. We need to stop doing this. All infrastructure is infrastructure. SREs need to be running the show, and we need to move on with our lives. Is that enough?
Oh, yeah. I think if I wanted to add a couple of things, right? Things that are native to Kubernetes can actually benefit your databases or data services that you're running on top. So like things like high availability, things like pod disruption budgets, things like the ability to perform non-disruptive rolling upgrades. So those are some of like tactical benefits that you should be aware of that definitely help modern databases and make it easier for you from a day 0 and day 2 perspective. But yeah?
I agree. I mean, I think to your point, Gabriele, having sort of one place to run both your databases and your applications, people are wanting that experience. And maybe, it's one of those things where you have a single database and you don't think, why should I put it on Kubernetes? And maybe I think it's one of those things that might be a new conversation to a lot of people. And it's still early days, right? So, a little bit lead into our next question, which is, we've been in this community for 5-6 years now. Databases on Kubernetes is a challenge when it comes to our cloud native architectures. So I think the next question is, where have we come in this technology? Speak to maybe a little bit about how you started in this Kubernetes and cloud native space, and where it's come since then, and kind of where you see a lot of the advances in that time frame. We'll go in reverse order. You could just go, Patrick.
Where I'm always in the middle.
Yeah, pretty much. Like, when you started working with data and databases and Kubernetes, how did you get into that space, and really what has transpired since then?
Well, it all because I work on Cassandra, and no one installs one. It works together as a team, and I've always worked in scale infrastructure. So I think from the earliest times that I've worked with infrastructure, we've automated as much as possible with Bash. And then DevOps happened, and Kubernetes was the obvious next extension for me. What always bothered me was that every time we do something in DevOps, the database was never included. And I've always worked in data infrastructure, and it's like that seems like a problem. And then in just working within the Cassandra community, it was clear that people were trying and failing, or trying and exceeding way more expectations. And those were the more interesting stories. But you know, I think the origin is, it's like, I've always wanted something like this. And here we are, we finally have a chance. We got this, come on people, focus. We could actually pull this off this time and not have to run an install script. Imagine that. Go ahead.
No, I'm totally with you, Pat. You know, to me it was the evolution of my, the DevOps. I don't like to use DevOps, but you know,
you don't
DevOps. Yeah, I know, but
DevOps
otherwise,
you.
you know, I can't, you know, communicate properly. But that was the evolution. So I remember, for example, I started to talk about DevOps with Postgres 10 years ago, and with Vagrant at that time. So that was always, you know, the constant quest to improve at the time we were talking about deployment, okay? So I was also one of the developers of a very famous failover management tool in Postgres called Rep Manager. But what I really liked of Kubernetes is that Kubernetes is the single authority between databases and applications, and that's why I say Postgres or database in Kubernetes, not on Kubernetes, this technology, because if they are together, the same authority can control applications, routing, and databases, okay? So when I discovered Kubernetes, I saw that was possible, and in my opinion, so far, that's the best experience you can get of a Postgres database in general, inside Kubernetes, because of these, you know? So, and that also covers day 2 operations. So that goes beyond deployment, okay? So, anyway.
Yeah, no, I like that. I mean, coming from sort of the world of that developer sort of experience or database experience with Vagrant, and getting a lot of what Kubernetes gives you for free, is a valid, I think, a really great reason. How about you, Xing?
Yeah, so I will talk about that from the CSI point of view, because normally we know that operators differ from each other a lot, but we typically see the operator use a workload API like stateful set, and stateful set use persistent volumes to store data, and that persistent volumes are provisioned using a CSI driver. So CSI in Kubernetes has been GA since 1.13 release, so it's been quite a while now. So it has basic functions like create, delete volume, attach, detach, mount, unmount. It allows different storage systems to provide storage to containers through common APIs. And one feature I want to mention is the CSI topology. That's GA in 1.17. That allows Kubernetes to do intelligent scheduling. So it dynamically provisions the persistent volumes at the best place where you can run your pod and allow you to deploy and scale your stateful applications across different data domains and different failure domains. And then the other thing I want to mention is the raw block volume support. That was GA in 1.18, I think. So that allows a container to have direct access to your the raw block device rather than through the file system, which is required by some databases that require high performance and low latency. And the third thing I want to mention is CSI snapshot. That was GA in 1.20, and that's the basic building block to support data protection in Kubernetes. And also, we have a volume cloning, volume expansion, and we have a CSI capacity tracking that was GA in 1.24 release, and that allows Kubernetes to look at capacity when scheduling the pods. And the last thing I want to mention is the non-graceful no shutdown feature, which just went alpha in 1.24, that allows the stateful workloads to fail over successfully to another running node if the original node is shut down and not detected by kubelet. So there are a lot has happened to make it easier for us to run stateful database workloads in Kubernetes.
Yeah, I think that evolution of like CSI describes sort of where this whole community has come of running data on Kubernetes too, right?
And local persistent volumes as
Yeah.
well. I mean, that was for I forgot, but for us it was a game changer.
Yeah, and even that last one you described of, having the ability to fail over easily. Like, I know if you've been running databases in Kubernetes, it's probably something you've hit at one point or another when using persistence is, the thing fails, but it's just stuck, right? And I think, as we get, further along, and we heard earlier from some of the talks that said, we ran databases on Kubernetes and it wasn't the best experience, so I went elsewhere. I think, the evolution of this community is getting better and better every time.
Yeah, and I think it clearly shows, right? Even if you do a quick Google search for like why stateful apps or why database on Kubernetes, you won't see the debate that was happening earlier in the days by should you even run stateful apps or databases on Kubernetes. As you like Xing clearly laid out the evolution of how the CSI project worked, and it showed you how things have improved. So now it's not even a question like whether you should be running databases on Kubernetes or not. Like, let's find a better way to do it, and let's find a way to just run it even in production. So I think that leads me to the next question. What are some of the best practices, lessons learned, things to do or things to avoid, and when you're thinking about running databases on Kubernetes? And let's start with Gabriele this time. Like, I don't like this back and forth.
Okay, yeah. I mean, I think the best advice I can give is to start from day zero. Okay, because if, for example, if you want to deploy database in an existing infrastructure that's been designed to run stateless applications, there's no way. I found myself installing the database, a Postgres cluster, and the storage was going 1 megabyte per second sequential reads. There's no way you can run a database that way, okay? So I think start from day zero. Plan for the database, so work with the infrastructure team to do that. And then possibly, and that's one of the advantages of Kubernetes, is that through configuration, you can actually choose the topology. And at the moment, still we are thinking in terms of a single Kubernetes cluster. So I think the next challenge is to have a better way to manage resources across Kubernetes clusters. But otherwise, you can share, for example, your Postgres cluster with other workloads or dedicate nodes for even bare metal machines that run a single Postgres instance. And that's all done declarative, and I found that, amazing. So.
A lot of flexibility. Patrick, Xing?
Great.
So I would say use common Kubernetes APIs when possible, and also leverage Kubernetes declarative nature and self-healing abilities.
All right, little spoiler. Jeff and I just wrote a book.
It's a great book.
Thanks, Portworx, for sponsoring. Chapter 11, we talk about this a lot. There are 3 things: people, process, technology. People are the most important thing. You are not going to get there today with the people you had yesterday. Sorry. And it doesn't mean that you have to fire people. You just need to rethink the way you do infrastructure. And that is a big sea change. That will stop you from being what you want to be in a cloud-native world. And let's just have a little real talk here, right? Process, we've already talked about that. Technology. The thing that I think that most people need to understand is that the technology may look the same, it may quack like a duck, but it's definitely not a duck. And I'll give you a couple examples. Cloud native technology now is converging towards object storage. I'm going to move away from you when I say this. Block storage is dying. It's going to die. Get over it. Flink, Pulsar, Spark, the Cassandra project, we're working on this now, is going to use object storage as the main storage means. It's not going to be block storage. Block storage is hard. It's multifaceted. This is a way that we all have to go. Come on. We're going to the future. Hang on. But I mean, when you think of like the 3 things that you need to tackle, always start with people, then process, then your technology. That's my advice.
Yeah, and I'm just thinking about, we often hear talking to people on the show or just in this industry, is that not trying to boil the ocean, do too many things at once. I think if you try to just say, oh, we're going to do databases on Kubernetes and throw all the databases we have and some new ones at the same time, it's not going to work out, right? So starting with day zero, start with maybe a single database. And grow with that experience along with your people and process along the way, because it does take a lot of change, not just throwing Kubernetes at the problem, right? When do K8 sit is another topic, I think, that maybe we could tackle a different day. So I think we still have a little bit of time, and maybe our next question is more around where do people get started? We're a community here. I think we all share different experiences with how we got into working with Kubernetes and now with data. Where would you recommend people to go to get started? It could be with your own experiences or just what you've seen in the community.
You got to call it out.
Go ahead, Patrick.
Thanks. I mean, come on, we all know, what are you going to do? You're going to Google it, right? No. I mean, really, this is a wonderful time to be alive when it comes to learning things. You don't have to buy a book, although it would be nice if you did. But YouTube is such a wonderful resource, and I'm going to call out DoK for putting a lot of great resources at your fingertips for free. But it's also understanding what you need to know, and sometimes that can be a lot more difficult. Check out the case studies. See what other people are doing. There's plenty of people talking about this. Learn from each other. Get on the DoK Slack. Ask questions. How many of you would say no if somebody said, hey, can I talk about your implementation? Of course you want to talk about it, because it's your baby and you want to talk about it, right? So if you see something that catches your interest, go talk to the person who did it, because they will tell you about all the bad things that happened. That's what you want to know. You don't want to know about the good things. You assume that something good happened. Learn about the bad things. And then your learning should go down the track that you're going on. You want to do streaming, you want to do analytics, you want to do databases. There's plenty of resources out there. And then finally, learn how to spin up your own Kubernetes cluster. And that is the hard way, but you will learn so much.
Should I go?
Yeah, go ahead.
I'm going back to the people factor that is, in my opinion, the most important aspect, especially when you think about DBAs. Okay, so a DBA that faces Kubernetes, I've had people saying, I was hoping to retire without having to study something new, and restart again, okay. But I think my suggestion is to start with CKA. I think CKA, I don't believe in certifications, but I think the CKA, it's important the journey that gets you there. You are forced to do a lot of exercises, practical exercises that help you build a muscle memory that then you find in a daily job. I was a former football player, and you have to learn how to dribble, okay? Dribble is a fundamental, but it's not that when you play in a football game, you actually dribble because they chop your legs immediately, okay? But you need to know how to do that, and you need that kind of muscle memory to work every day. So I think CKA is my advice, because that helps you become familiar with Kubernetes, and then when you're there, I think you start seeing a completely different world. And then open source is, I owe everything to open source in the first place, okay? So open source is really, what the source for you to learn new things and be curious, be creative, take initiative. That's all I can give as an advice, When we started, probably Patrick and I think there was no internet, when I started. And
we were happy.
Exactly. There were no phones, I remember, I had to buy a C++ book. It took 2 months to get to Italy, just to give you an idea, Now there's a lot of information out there, and it's all for you and for us to learn.
So I'll just talk about it from a SIG storage point of view. So there is a community page for SIG storage. There are actually a lot of video recordings from previous SIG storage sessions. So there are also a few one-on-one sessions that I think it's a good resource for you to go there and take a look and get started.
Okay, I'm really angry that none of them mentioned the Kubernetes Bytes podcast. Like, even though they have been guests, like that's a good resource. It's a community resource.
You need a YouTube channel now.
Yeah.
But I didn't want to spoil you. Because I didn't want.
That's good. No, I think communities like this DoK, communities within the CSI 6 stores, they are absolutely not just joining them, but the people within them, right? You're going to learn a lot from people who've kind of been in this space for a long time. So absolutely agree with Holly's point.
Yeah, and that's how we met, right? Like, I know Gabriele and Patrick because of the DoK community. I know Xing because of the 6 storage community. So that's how you can create these connections and learn from people. Yeah. Okay.
Cool. So we have, we'll open it up for some Q&A in a second about databases, but we do not only want to talk about databases, we have some more interesting questions for you guys and gals. One, which I know I'm going to point at you first, Gabriele, which is, do you like Detroit style, New York style, or Chicago style pizza, or none of the above?
Yeah, you cannot ask that question to an Italian,
What? So tell us about it.
I've lived in Australia, and the worst I could see was, the pizza with pineapple, there, or Vegemite, even Vegemite, But, that was the outrageous to me. No, just kidding, I think everyone should eat the pizza they like.
No.
Choose.
Yeah.
I don't know Detroit. I don't know Chicago.
Okay.
We need to fix that.
So
we need to get you a good pizza this week.
Okay. You take me to the pizza.
New York all the way.
New York. All right. Any preference?
Well, I actually like the veggie pizza that I bought from Whole Foods.
Okay, nice. That's a valid point. So none of the above. Whole Foods. I like it.
No. I have a thing. Okay. So I know there are 3 options. I went to a restaurant and there was something called a Boston pizza. And we are from Boston, right?
That's not a thing.
Yeah, that's not a thing. But they're serving it as a Boston pizza. And the topping that was on top of it was fried eggplant. I was like, ugh. Don't do this. But yeah, okay. New York pizza.
I'm going to point out why this is hard to do a panel. I'm the only one who answered. Everyone else said, I don't want your answer.
New York pizza.
Yeah. You got 3 choices. I got 10 more. Yeah.
None of the above was a valid answer. So.
No, none. All right.
All right, here's one where
I picked Detroit.
Yeah.
Okay. In Detroit.
Just to even it out.
All right, here's one where you have a little bit more to answer, which is, what would you name your boat if you had one? Or maybe you do have one. I don't know.
And we can't say Kubernetes. Like, that's an easy answer. Yeah, let's get that out.
A stumper.
So I was thinking about this question. I know, like, I'll give them some time to think.
We won't tell you that we sent the questions ahead of time to them. Okay.
For me, this is a stupid answer, but I would like to call my boat afloat.
Afloat?
Yeah, my boat is always afloat. I don't know.
Okay, I like it. It's always afloat.
I'm going to go with Allura, and only because that was a really cool name of a ship in a book that I liked.
Okay.
Yeah, I was going to say, of course, I still love you, but that's already been used. Yeah.
I would call it La Pinta.
Okay.
Of course you would. Are you from Genoa?
The name is really hard. I really can't come up with anything.
Your name works as well, I guess.
Maybe I'll just call it like maple, because with a lot of maple trees in England.
I like it. Yeah. I like it.
Naming things is one of the 3 hard things in computer science.
Yes, exactly.
That's why we pay marketing teams so much money.
Depending. Okay, so I know we only have a little bit of time up here. We wanted to cover, why Kubernetes, where we've come as a community. I think we've come a really long way. And then, hopefully the getting started was a useful question for everybody. But we do have a little bit of time, and I think we'll open it up to questions that you may want to ask myself, Bhavin, or any of our panelists. Do we have a little bit of time, Bart? Cool. Any questions?
Any questions? Perfect.
There we go.
Hi, this question is from Ms. Yang. So I'm fairly new to Kubernetes, only started using it February of this year. And as we're getting requests for new clients to start using the container platform, one of the requests that it's always part of their system requirements is storage, of course. And they're always requesting consistent volume storage. For me, my understanding was I don't have to provide that. They just declare that in their manifest. So wouldn't be the answer? I mean, would the answer just be for me to tell them what the storage class is, and then you reference it in their manifest, and then define how much storage they want?
Sure, and this was directed towards Xing?
Yes.
I actually not.
So is the question basically, you have clients asking for consistent file storage. Do you have to provide them something specific, or do they actually configure the manifest and the YAML with their own storage?
Correct, yes,
okay.
That's right.
I think that really depends on what they need, right? So there are so many different storage systems. They're all very different. I think you will need to ask your client what they really want, and then make a decision. I can't really recommend one particular one.
Let's just
for
say
you.
they're telling me I need a 100 gig persistent volume for my application to work. Since they're using Kubernetes, normally I would I'm thinking to myself, I'm not going to provide that for you, but I'll give you the storage class for you to reference in your manifest file, and then you declare 100 gig in your statement, in your parameters. Is that correct?
Yep.
Okay, that was it.
So for example, our operator for Postgres works that way. It's storage agnostic. You can define the storage class. And actually, there's a talk. I'll be speaking on Thursday about this stuff with Chris Milstead from OwnThat.
Yeah. And I think to Patrick's point before, this goes back to the people and process too, about how your teams are set up. How are you giving that control to your teams that are defining their applications, or do you want a team that's really looking at sort of controlling that a little bit more, providing those storage classes with limitations and quotas and things like that? I think thinking about how that process and those teams work definitely is a first step. But the control is there to give them that option to define how much they need.
Hey, I have a question on the performance of the storage.
A little bit louder?
Yeah. Can you hear me now?
Yes.
Yeah. As we are, I work in a lot of cloud migrations, moving customers to public clouds. So where we see usually when customers are moving to a cloud, they tend to prefer more on the instance store, mounting the NoSQL databases or even relational databases for some customers. So with the CSI, there's a lot of Kubernetes networking in the middle, right? So how do you see, are there any new improvements when you compare to the kind of model where on a VM, instance stores are taking place, instance stores are running the databases? So when we compare that kind of model to Kubernetes I/O, is it equally comparable?
I think that depends if the storage is over the network or local. That's the same.
It's the same.
That really depends on the database you're deploying. Like, when you deploy a Kate Sandra deployment, it's usually we use node local. So you're going to get, the CSI is important at that point. So you're going to be at the storage that's local. You're not going to be doing network storage. Network storage is a bottleneck, so avoid it at all costs. And thanks for keep making my point about what a hot freaking mess storage is. Thank you. Anyway, I think we actually have someone from SIG Storage here that can help.
Or storage vendors.
Yeah, storage vendors.
So did that answer your question?
For example, in the past, we ran, before we started this journey, tests on bare metal, and we were able to go as fast as on running FIO on bare metal inside Kubernetes.
Okay.
So with local disk. That's why we started 3 years ago to work on this, because the technology was mature back then.
Yeah. My experience was like 2 years back, so it was performance.
It's gotten better.
Yeah, it's gotten
Much better. The work on CSI drivers is, making things better and better. So.
Are there any benchmarks that when you compared that you posted?
We have, but I think you can make them yourself. It's pretty easy. You run FIO and that's it.
FIO and IO stats.
You can chat with us afterwards, too. I'm sure we can give you some more details.
That's the best way.
What? Sure.
Yeah, so regarding databases and Kubernetes, I just want to make a distinction between two use cases. There's a use case where you can run databases on Kubernetes all day and no apps and just consume the database. And that's kind of, we see that behavior that manifests in customers to consume Google Cloud SQL or AWS RDS all day. And there's this other use case where you co-locate your app with database and try to. I somehow do not see the latter at all. I see either the first one or Cloud SQL, Google Cloud SQL or RDS. So do you guys actually see that? Because there is this tribal knowledge amongst, call it database admins or cloud admins or infrastructure. They have this tribal knowledge where they had heard somebody that tried to run database on Kubernetes and failed. So they at least want to isolate in a different cluster.
It's like when they started to run databases in virtual machines.
Yep.
Everyone thought, oh, yeah, you can't run databases inside virtual machines.
You know who said that? DBAs. And you know what? Who's wrong? DBAs.
Sorry if you're
Remember my advice before? Forget the DBAs. Move on.
So are you aware of large-scale case studies where this has happened? Okay, sorry. Are you aware of any large-scale case studies where people have repatriated their databases from outside Kubernetes to inside?
Yes.
Okay.
Yes. I wish I could have more stories to share, but there's NDAs and things like that.
Sky UK, they have a case study online. They did that. Yep.
Thank you. Yep. Thank you, everybody.
Thank you.
Awesome. Sylvain, can we get a picture? No, wait. Stay on stage, please. We're gonna do something very avant-garde. We need 5 hands on the horn.
Here we go.
Xing. How are you? Good. Everyone's on there? Very good. Thank you very much, everybody. Awesome job. We've got questions, we've got answers, but I think the biggest question on everyone's mind is, you can get pizza at Whole Foods? And when am I going to try that? We always have lots of surprises here in DoK Days. Our next speaker happens to be writing a book with Patrick. In case you didn't know, Patrick's writing a book. But he's also an amazing community member. His name is Jeff Carpenter, if you'd like to come up. All right. And so can we get his slides going as well?
Thank you, Bart. So, that was an amazing panel. Panels at conferences are hit and miss, let's be honest. That one was awesome. And I don't just say that because you really teed up my talk. So thank you very much. Okay, so we've just been talking about, can you run databases on Kubernetes? What are the pitfalls? What are the recommendations? Let's project forward. I'm going to push us forward here, okay? Let's talk about the Kubernetes native database. And you're thinking, is there just one? Or what is he talking about? Well, what does it mean for a database to be Kubernetes native? I'm going to try to give you a definition, and I'm going to try to persuade you that this is a thing and why it matters. So let's go. Next slide. Okay. So we're here because we're into cloud native. This is the world that we are living in, right? So we think cloud native, we think about things like containers, we think about microservices, we think about automation, we think about good observability and monitoring, all of these things, right? So what would that mean for a database to be cloud native? Okay, let's hold that thought. I'm going to pop one more on you here. Hit the next slide. Okay, what would a Kubernetes native database be? Is that the same thing as a cloud native database? Or is it cloud native plus some special sauce? Or is it an entirely disjoint set? What does that mean? Okay, let's go for a third one, because I'm just dropping terms on you without defining them. I love this. It's great. I'm in my happy place. Serverless database. Okay. I'm expecting some furrowed brows and maybe some quizzical looks here. Is that a thing? Could a database be serverless? Yes or no? Raise your hand if you think a database could be serverless. Okay, okay. Maybe a little more optimistic viewpoint than I was expecting. That's great. Okay, so I got about a 20% hit right there. Let's keep going. Okay, so yes, we are writing a book. I want to talk about this not in the normal sense of, hey, I'm here, I'm going to plug my thing. But I want to share this as, this is a love letter from Patrick and I to the community. We got involved with this almost 2 years ago with the DoK. And after about maybe 4 or 5 months of being involved and immersed in all of these great podcasts and things that Bart was running through guest after guest, I was like, there's a book here. I know there's a book here. And if I don't write it, someone else is going to write this book. And I would hate for that to not be the thing, because I have a passion about this and want to do it. But also I was like, I don't know about writing this whole entire book by myself, which is why I reached out to Patrick. And boy, I almost fell off the stage there. So anyway, I want to share that because I want this to be a resource for the community, and I don't want this to be the only data on Kubernetes book. There needs to be like 15 data on Kubernetes books or more, right? So this is my challenge to you, that this is just the beginning. And by the way, this talk is based on chapter 7. So I'm going to leave a bunch of stuff out. So when the book comes out in December, you'll be able to read it. Or you can go to the Portworx site and get the early release copy now. Or it's on O'Reilly Learning if you have that. Okay, let's keep going. Okay, so one of the things that we do in the book is we take the CNCF definition of cloud native and we try to project that into the world of data infrastructure. What does that mean? And so what we came up with was a derivation of these 5 points. That let's say a cloud native database or any cloud native data infrastructure needs to embody these things. I would love for you to tell me what I'm missing, but afterwards. Okay, so number 1, leveraging compute, network, and storage as commodity APIs. So no special sauce here. You need to be doing it through industry standard APIs. Second is separate the control and data planes. So the code that is managing your database is separate from the database which is managing your data. Number 3, make observability easy. So logging, metrics, tracing, right? These should all be features that are built into this data infrastructure for it to be considered cloud native. 4, make the default configuration secure. No default passwords, people, right? We've moved on, we're past this point now, right? But also, in the Kubernetes world, in the container-based world, you don't have to leave all the ports open by default, right? So this is like a principle of least privilege applied in the data infrastructure world. Number 5, prefer declarative configuration whenever possible. So those of us who are familiar with how Kubernetes works, this is music to our ears, right? This is the language we speak. All right, so with those principles in mind, I want to push forward into the next slide, where we're going to actually look at a couple of databases here. I'm doing this super fast, and I'm not doing these databases justice, but I want to give you a couple of things and pull out some points to see if we can define what it means to be Kubernetes native. So bear with me. Okay, so the first one we'll look at is TIDB. This comes out of PingCap, and this is a MySQL-based database, but it also layers in a columnar database alongside it. So they've achieved something like that they call hybrid transactional and analytic processing, or HTAP. So what they're doing with this is there's a separation of concerns. There's a separation of compute and storage. So the layer that's at the top of this diagram is the TIDB instances. These don't do any data storage. They just do query processing. So they're compute-centric. The storage cluster is a mixture of TIKV, which is MySQL, and TI-Flash, which is a columnar database. So these, notice, can be scaled independently from each other and from the query layer. And then also you can run Spark alongside it. And behind, or connecting everything together, is a metadata layer known as this PD layer. So what they've done is they've broken up a database into microservices, each piece of which can be scaled independently. One thing that's really interesting is this database only runs in Kubernetes. You cannot run this thing outside of Kubernetes. Okay, so go to the next slide. Now, when I say that it's Kubernetes only, does that mean that it's Kubernetes native? Maybe, maybe not. So they have an operator. TIDB has an operator, and it controls all of the components, and you describe everything that you want through custom resources, CRDs that they define, which is great. So they have a TIDB cluster, pretty obvious. That's the basic capability. And then you can extend it and attach to it a TIDB monitor that hooks up Prometheus to it, and so on. They've also made maximum use, you heard this referenced in the panel, making maximum use of Kubernetes APIs, where the scheduler didn't do everything that they needed in terms of pod scheduling. They've extended the scheduler using the Kubernetes extensible API for this. So another great utilization of the existing technology, embrace and extend. So let's keep moving. Okay, so when you create a TIDB cluster, it allows you to specify the number of instances that you want of each of the components, whether it's TIDB, TIKV, TI Flash, et cetera. And then you can optionally, as I mentioned, attach a Prometheus Grafana stack to it. Now, I was talking with Ed Huang, his co-founder of PingCap and one of the inventors of this database, and he said, well, this is a Kubernetes native database, but it's not totally cloud native. And I was like, wait, what did you say? That didn't quite register with me. And what he meant was that a couple of things. One was that they had their own custom metadata server that they built, and he's like, we'd like to replace that with etcd, which is a more Kubernetes native kind of tool. Fair enough. Another point was that they were interested in using object storage instead of doing everything based on persistence volumes. Now, you heard this discussed quite a bit in that panel, so I'll not belabor the reasons why for that, but just a couple of interesting data points. All right, so let's go to the next slide. So we'll switch gears and talk about AstraDB. Okay, so full disclosure, AstraDB is a database product. You can download the white paper that describes the design of this. We're working on open sourcing the other bits. We'll eventually get there, I'm sure. So, but what I wanted to talk to you about is the open source design that we talked here about refactoring Apache Cassandra into microservices. So if you subscribe to this managed service, this is what's going on behind the scenes. So there's a few things here. One is that it uses a mixture of persistent volumes and object storage. It also, as TIDB does, it also integrates a Prometheus and Grafana. And it has a layer that allows API access of different flavors, a project near and dear to my heart because I'm working on it, called Stargate. And interestingly, and a novel thing that maybe we didn't talk about that much today is the idea of multi-tenancy and the idea of multi-cluster, which we did talk about. So these are two important features of this database, that it shares across multiple tenants and it can be run across multiple clusters. And I mean Kubernetes clusters. Okay, let's go to the next slide. So Astra also defines CRDs and also has an operator that manages the database, uses Kubernetes ingress on the inbound side to route traffic from different tenants to the right instances of services that are responsible for serving queries. So we do have allocation of different microservices to specific tenants, but many of them are shared across multiple tenants. There's an IAM service to which all the authentication and access control are delegated. And the storage, the way that the strategy for storage is that data is initially cached in local persistent volumes, and then when it's to be written out to disk, the SS tables, which is how Cassandra stores data, those are written out to object storage. And one of the things that's really cool about how this decoupled architecture is that there are processes like compaction in Cassandra that combine down multiple SS tables to remove and deduplicate data. That can run as a background process that just goes and operates on those files in object storage. Okay, let's go to the next slide. Okay, so I'm going to zoom way back out, and let's see if we can derive any principles here about what it means for a database to be Kubernetes native. Okay, so, and a lot of these are going to look pretty similar to the principles that I showed at the beginning about cloud native data infrastructure, and that's by design, right? So we have maximum leverage of Kubernetes APIs. So use stateful sets and persistent volumes where they make sense. Use etcd You can run your own copy of etcd if you need to. It doesn't have to be the core, the core control plane one. Use ingresses. Extend the scheduler if you need to. The second one is use automated and declarative management. So use CRDs and operators where that makes sense. You shouldn't be running your data or managing your database or configuring it through user interface anymore. This should be happening through an operator, and you should be, the way that you should be saying what you want is through making a change to a CRD. We can get there, right? This is aspirational. Third is observable through standard APIs. So, for example, putting a Prometheus endpoint on all your pods so that metrics can be scraped from it. Secure by default. I mentioned what the table stakes are here before, right? But in terms of port settings and default passwords, but also having the ability to integrate with identity management solutions. That's one of the most commonly requested features of any of these databases is, can you make it integrate with my old LDAP server? All right, let's keep going. Okay, so now I want to project this even farther into the future. So if the things that I mentioned in the last slide are table stakes in terms of what it means to be Kubernetes native, where's all this going? We see this expanding in a few different directions. So I got the idea of drawing this out as 3 axes, 3 dimensions. And then I kept thinking of dimensions, and I decided not to try to extend this into the 4th dimension. Let's go with 3. Okay, so 1, and all these are reflect the idea of scaling in different directions. So microservices allow you to scale the different pieces of your architecture independently, and it's a key part of being able to separate compute and storage and optimize the resources that you're using for each part of the database. Multi-cluster and multi-cloud. So these are important because you want to be able to scale your database to multiple clouds. There's a lot that needs to happen here in terms of federation, but we're pushing in this direction. Multi-tenant is a key thing that allows you to use resources the most efficiently, and including maybe even scaling to 0 if a particular tenant isn't making use of some capability. And then finally, we need to be doing everything that we're doing in community, in conversation with each other, in DoK and other Kubernetes communities, and working in open source. Okay, next. The one last thing that I want to say is a big thank you to, we had about 20 people that we interviewed for the book. And so there were some common themes that emerged from all these conversations that Patrick and I were able to have with Kubernetes and database and data infrastructure experts. We didn't just talk about databases. We talked to streaming folks. We talked to Holden about running Spark on Kubernetes. And a bunch of other analytics stuff like Dask and Ray and Flink are in there as well. Common themes that came out of this that we heard again and again. High-level categories of things, right? More improvements to stateful sets. They're great, but can they do more? Resources that would help us, like custom resources or common resources definitions that we could share about across projects, right? Could there be common definitions of tenants or database backup and restore jobs? There's no reason that every project should have to have a different definition of each of these things. And then we heard a bunch of different things about allowing a little bit more fine-grained control of underlying hardware resources, like having more hypervisor support, having a little bit more stringent quotas on different compute and storage utilization, and the ability to get a little bit more out of storage by asking it to go ahead and stripe a disk for you, things like that, okay? So that's kind of a summary. There's a lot that the data infrastructure community can do to make databases and data infrastructure better. And there's also things that we could do to make Kubernetes better and to kind of meet in the middle. That's really it, I think. Go to the last slide. This should say thank you. Thank you. So just really want to thank this community. This is not a project that Patrick and I did. This is not a project that's possible without all of you. So thanks.
Awesome. Jeff, thank you so much. No. You're not running away. We got to get a picture and do other things first. We got time for one quick question. Question? Someone's got to have a question. Can you repeat when the book's coming out, please?
Okay, so digital will be early December, and then print copies may be arriving by Christmas. I know it's the hot thing that all your kids want this year.
Stocking stuffer. Great stocking stuffer. Apart from that, any questions? Otherwise, we're going to ask him what kind of pizza. New York, Detroit, Chicago, Whole Foods.
No, Pizza Bianco, downtown Phoenix.
Oh, wow, that was very quick.
That's another cop-out. I will absolutely cop out.
Okay, well, now we know where to go for pizza in Phoenix. No, but wait, we got to get a picture with you with the horn. Let's give Jeff another round of applause. He's an amazing community member. So lucky to have him with us. He'll steal your microphone. You take the horn. Awesome, thank you. Good. Our next speaker is also no stranger to our community. Peter, if you could come up to the front, please, so we can connect your computer. Let's give Peter Zaitsev a round of applause. If you don't know him, he's the founder of Percona, one of our very, very active community members. Always nice to hear from them. And so he's going to be continuing the conversation that we're having about cloud-native databases. So once we get him connected, we'll be good to go. We've got plenty of more talks for the rest of the day. Got another panel as well coming up, so plenty of action. There we go, we got that. Just get your microphone, you're good to go.
Okay. Hello, everyone. Well, that is a very interesting talk to follow, because I'm going to talk about the best practices, but about the databases which we work in, and these are the databases which were born and designed well before Kubernetes and cloud native was a thing. So that's kind of how to run fucked up database on Kubernetes, right? So that is what talk is about. But before we get to that, let me maybe frame where I'm coming from in this ecosystem. Now, I've been in the open source database space for a long time, and what we see a lot right now, there is a lot of push of their running databases in the cloud as proprietary offerings by cloud vendors. You know, you can think about MongoDB Atlas, Amazon Aurora, and so on and so forth, right? Which I think is, on one side, fantastic usability, which developers love. On the other hand, it comes at a great cost, both literal, like money, as well as loss of convenience, right? And whatever, maybe selling your soul to the devil kind of thing. And I think in this regard, they're using cloud native thing, you know, whatever you would call it, cloud native databases or Kubernetes native databases, doesn't really matter for me, but if you are going to really look at, really focus on treating cloud as a commodity and really see how you can get more value from open source solutions, that can be more wonderful. Now, you probably saw that already because we're all here members of Data on Kubernetes community, but I also wanted to refer a couple of services from Data on Kubernetes, right? One thing is what there are a lot of folks are actually running data-intensive workloads on Kubernetes, right? And this is wonderful, because if you compare that to a few years ago, right, there was a lot of talk, well, Kubernetes is only for stateless application, you know, nothing stateful, especially not the databases, can be run on that. And guess what? The databases is actually the most common workloads which are run on, Kubernetes, right, from data-intensive applications. And the other data point is where Kubernetes operators, where we can see what a very large number of folks are using or planning to use Kubernetes operators here. And I think that goes very well in line with the previous talk when we were saying, hey, if you are going Kubernetes way, well, use their API and Kubernetes primitives to their full extent. Now, why do we find the operators wonderful in Kubernetes space is really what they allow that automation, both day one automation and day two automation, right? When Kubernetes came out in the early days, I remember a lot of folks implemented that very simple Helm charts to provision the database of your choice in Kubernetes. Oh, that's wonderful, that works, but you know what? It does not really go the distance, because when you because databases, unlike your apps, right, you can typically just pre-provision them from the ground up, right, because they have to persist the data and all the changes to those data, right, and that means they typically have quite a long life cycle, right, and a lot of challenges really happen in that day two automation. You know, managing backups, upgrade, dealing with failures, and so on and so forth. The last thing I wanted to mention about the general thing about Kubernetes, or in my arguments when I do to people to say, hey, running the databases on Kubernetes is okay, you will be fine, is what actually a lot of folks are doing those, right? Obviously, DataStax folks just, spoke about their solution, but there are a lot of folks running Kubernetes powered databases as a service solutions right now. Okay, with that, let me move some of the particular best practices. The number one, as I mentioned, is, hey, use operators. For many open source databases, you'll find a lot of ways to deploy the databases, right? Some will be, Helm charts, some will be more kind of full-blown operators. Look at the operators first. The second one is also making sure you're thinking about availability, right? Folks who are running databases for a long time sometimes say, well, you know what, I have this wonderful server which was up for 5 years, never went down, it has that very robust RAID, and so on and so forth. Well, no, you do not rely on single node in Kubernetes, and you want availability and also which is automated. Next one, if you are using those kind of legacy databases, well, typically you don't have a choice of an object store, but at least you want to use persistent volumes, right? Because otherwise you may end up in losing all your data, right? And I think that is one of those, I would say, mistakes, right? And why many developers who tried running databases on Kubernetes may still have a PTSD, because they deployed a database on Kubernetes, didn't use persistent volume, something happened, and their data disappeared in the void, right? Which just doesn't happen if you're a physical service, right? Because, well, at least it's somewhere on the hardware I can touch and maybe, recover data from in some way. Next one is you want to keep the data per pod small, right? If you have your, monolith database, 50 terabytes in size, well, maybe it is not the time yet to take that in the Kubernetes, right? Many of databases, they implement some sort of sharding so they can have data per pod is controllable, right? Wherever it is, Cassandra or MongoDB. The next one is maybe kind of conflicting with the previous one, but you want to use also appropriate node sizes and in general hardware configuration, right? I have seen the Kubernetes clusters deployed with relatively small VM or physical node size. We just do not fit the database parameters yet. Yes, maybe you do not want to have that 50 terabyte node, but you may need to have a pods which have 16 gigs of RAM, right, or more to deal with your database, and that requires your nodes are scaled appropriately. Next one is you want to configure resource requests and limits. That is also a surprise for many people moving to Kubernetes, because if you are running VMs, in many cases, your kind of resource allocation is sort of semi-fixed, right? I configured 4 CPU cores, and that is what I get in a normal case, right? If you are having a database deployed in Kubernetes with pod having no configuration, it may use all the CPU resources available, but then if there are some other tenants, it may be kind of squeezed to basically nothing, which especially in production, use cases can be very unfortunate. Also, you may need to make sure you are setting anti-affinity rules properly. Right? Well, many operators will actually do that for you on its own, but you know what? If you happen to have a 3-node clusters where all of them are running on the same physical node, well, that is not a good idea, right? You're not getting your high availability. The next one is about the database on itself, right? Well, wherever magical Kubernetes is, by default, it's not going to tune your database. So configuration, indexes, queries, all of those need to be taken care of for their optimal performance. And here, let me have a shameless plug from Percona. We have a tool. It's kind of based on the Grafana and Kubernetes called Percona Monitor and Management, 100% open source, right, which allows you to optimize that queries nightly. Next one is understand how to scale your database of choice. Some of the databases are wonderful in terms of you can scale them out, right, by just having more pods deployed. Others don't. You only can scale up, right? And again, up to certain limits. As I mentioned, you probably do not want to run a 50 terabyte database on with a heavy load, right, on Kubernetes those days. At least you want to make sure to understand that so you're not having surprises. In this case, hey, you know what? I need to scale 10x because my product manager told me what we're expecting, dramatic growth of users. Well, guess what? Can't really do it. Next one, maybe more technical, is what you want to control eviction with a pod priority. One thing about the databases, especially with many legacy ones, they do not like to be kicked in the nuts, right? They often have to kind of resynchronize and do some other stuff to rejoin the cluster, right, which may reduce their performance or availability of your cluster may be degraded, right? So you want to make sure that doesn't happen more than that absolutely needs to do. Security-wise, you want to make sure you are not exposing your database more than you should have. Of course, that is not Kubernetes related, but what we see in Kubernetes as well as in many clouds, some not security conscious developers are looking for an easy button, which is kind of expose it to the world, because that means it's very convenient to access that for us from wherever we have. Well, bad idea can be dangerous. With that, of course, encrypting data at rest and data at transit is a very good security practice, and especially with the modern, CPUs, right, libraries, it doesn't really cause very large overhead, but can be quite helpful. Next one is you want to use Kubernetes secrets to pass the database credentials to your applications, right? As the previous speaker mentions already, well, default passwords, right, is not a good idea, and hard coding passwords somewhere in configs is not optimal either. Number 14, don't forget backups. When you have a clustering, redundancy, availability, whatever, that does not eliminate needs from backups. Again, not Kubernetes specific, but is important to highlight, especially what the good operators actually make robust backups quite easy, right? A lot more convenient to contribute than your kind of traditional Linux VM-based deployments. And number 15 would be to consider running the databases which are really designed to run in this cloud native space or Kubernetes, right? There is TiDB, which was mentioned, Vitess, they do a very good job, Neon, doing a very interesting work with Postgres, Yugabyte, and some others. Finally, let me finish with a few things beyond their the Kubernetes operators. One thing we note is what while a lot of folks who live and breathe Kubernetes, they love operators and are able to use that technology directly, while there are some other folks saying, well, you know what, we kind of like that Amazon RDS look and feel. You know, click to provision a database, you know, all that Kubernetes YAML kind of hard for us, right? And that is, I think, where we can see more of an open source developments for that. You know, remember I said in the past, a lot of folks are doing database as a service based on Kubernetes, but typically these are, you know, all that management plane, right, is proprietary. Well, that is one of the things we are building. In PMM, we also are building interface for provision database as a service using in Kubernetes. It is currently a work in progress, but again, as it goes with open source, we would very much appreciate your feedback and maybe even some of your code. Well, with that, that's all I have. Hopefully that was at least a little bit helpful.
Very good. Thank you. Let's give him a round of applause. We got time for one quick question. Any questions? Any answers? Any suppositions? Savon, what would you like to ask?
The pizza.
Oh, okay, yeah, French pizza. We'll get to that. Yes, Gabriele.
Yeah, Peter, I wanted to ask you, what's your... Sorry.
Okay.
Sorry, I was focused on the question. So, what's your take on Jeff's opinion about cloud native versus Kubernetes native databases?
Oh, is it the same or different? Well, you know, I think Jeff is a smart dude. If you said those are like in different bullet points, they must be different.
Would Jeff lie to us? Absolutely not. Okay. All right, with that, let's give Peter another round of applause. That was a great talk. Perfect. However you want. Yeah. Lovely. Thank you. Good. All right. Our next speaker is also going to be using his own laptop. Arek, you're in the building. Arek is also no stranger to MongoDB, a wonderful person who we had on a live stream not that long ago. He works at a company called Beamery, very, very active in the MongoDB community, and also just, like I said, a very, very cool person. We're all about cool people. If you know cool people, tell them to come to the DoK community. I also mentioned previously, if you have any artistic talent, does anybody make pizza? That does count as an artistic talent? Did anybody? Okay. Oh, Gabriele, well, that's cheating. All right, that's kind of unfair. They'll take away your passport if you don't do that right. But yeah, we're interested in food. We're interested in art. We're interested in music. Anything that you feel like you have to share, you definitely have a place to do so in the Data on Kubernetes community, whether you're with us here in Detroit or online, wherever you happen to be in the world. So that being said, we'll just get Arek to be able to share his screen. And sound check?
Test.
Sounds good.
Okay.
Yep. Cool. All right. Sorry, let's just see. He should be plugged in. No. Maybe he needs. Arek, maybe you need to. Remember the preferences from yesterday about being able to mirror? Yeah, that was it. It's all good. Don't worry, I got plenty of time.
1 second.
Okay. Yeah.
It was somewhere here.
Where's the
Oh, that's okay. Yeah. We can run databases. We can run databases on Kubernetes. Cool. We can run databases on Kubernetes, but sometimes plugging in the HDMI cable is also tricky. So always have things to learn. And there we go. All yours, Arek. Take it away.
Hi, everyone. My name is Arek. I work as principal SRE database engineer, and I'm also MongoDB community champion. Today, I will be talking about the best practices of running MongoDB on Kubernetes with help of MongoDB Kubernetes operators. I hope my talk will be useful for you. Maybe you will learn something new, and I hope you will like it. We will start from the introduction to the MongoDB architecture. Then we will talk about MongoDB Kubernetes operators, community operator, and enterprise one. I have also pre-recorded demo for you. Okay, let's get started. We can have 3 types of MongoDB clusters. Standalone instance, only good for test or development use cases. Replica set. Replica set is good for production. The data is replicated via upload collection from primary replica set member to secondaries. When primary for some reason crash, MongoDB will elect new primary and you won't have downtime. Sharded cluster. When your data grows, you should start thinking about sharding. Sharded clusters can improve performance by horizontally scaling your data. However, sharded clusters are more complex than replica set or standalone clusters. MongoDB cluster management is not a trivial task. You need to write your own automation for cluster provisioning, for rolling upgrades, for adding or removing new shards, for user management, and so on. You need to set up your monitoring and alerting system. Plus, you need to think about your backup solution. The recommended way of operating MongoDB is to use Ops Manager. Ops Manager is a Java application that helps you to deploy, monitor, backup, and scale MongoDB clusters. Every node connected to the Ops Manager has MongoDB agent installed. The agent is associated with MongoDB process. MongoDB agent is responsible for backup, upgrades, configuration, monitoring, restarting of MongoDB database process. Ops Manager is also using MongoDB replica set as its internal database. Users can interact with MongoDB clusters connected to the Ops Manager via Web UI or via REST API. Ops Manager provides also consistent backup and restore to the point in time. However, managing of Ops Manager itself is also not easy. Fortunately, we can run MongoDB on Kubernetes, use MongoDB Kubernetes operator, and let the operator automate operation for us. MongoDB Kubernetes operator is extending Kubernetes API by MongoDB specific objects like sharded cluster or replica set or even Ops Manager. The operator uses the best human knowledge of creating and operating Mongo. Currently, we have 3 types of MongoDB operators. MongoDB community operator associated with MongoDB community server. MongoDB enterprise operator. Now you can run Ops Manager together with MongoDB enterprise server on Kubernetes. And there is also Atlas operator associated with MongoDB database as a service cloud. But we will not talk about Atlas today. On this slide, we can see some example of operator duties. Provisioning storage and computing power, setting up network, managing users, or changing those settings if needed. So you don't need to have idea how to do this. Operator will orchestrate everything for you. Every MongoDB pod has two containers. MongoD container and a sidecar, MongoDB agent. Apart from managing MongoD process, MongoDB agent is responsible for readiness and liveness probes. MongoDB community operator. If you want to run MongoDB community server on the Kubernetes, you need to use MongoDB community custom resource. Currently, only replica set is available with community operator. So you cannot deploy sharded cluster or standalone instance. But you can have security, you can have users management, you can have secure connection between MongoDB pods and application and MongoDB, plus you can have persistent storage. MongoDB Enterprise Operator supports any kind of MongoDB cluster. Standalone, replica set, and sharded cluster. And also, we can run Ops Manager together with Ops Manager internal database on Kubernetes. And now, I have pre-recorded demo, and I want to show you how it looks. I prepared a very small and easy script. So I want to create MongoDB namespace. And via kubectl apply from official MongoDB GitHub repository, I want to create custom resource definitions. And I want to install the operator. So this is very easy, only 3 commands. Let's run this script. And we see that all custom resource definitions, service accounts, roles, etc., which are necessary to running MongoDB has been installed. Let's check namespaces. So we have our MongoDB namespace. Also, let's see that we have pod, the operator pod. Now we extended Kubernetes API by MongoDB related objects. If I display custom resource definitions, I see 4, MongoDB, MongoDB multi, MongoDB users, and ops managers. Let's use them. I need to also create all config maps and secrets which are necessary to run MongoDB and ops manager. OK, let's build ops manager. But first, I want to show you the Kubernetes manifest. So what I'm doing now, I'm just telling Kubernetes, please build for me object kind MongoDB Ops Manager in namespace MongoDB. I'm specifying desired version. Also, I want to have service type load balancer. Of course, I want to have security. And I need to have internal database. So that's the replica set, which is backing up Ops Manager. Let's execute this now. and display pods. And we see that our ops manager, together with internal application database, is up and running. Also, the operator created network for us, so I have all necessary services with external IP address and port. Let's put this into web browser. We have certificates, which I created before. And let's log in into our ops manager. And here we see that we have one organization with first project. And here we see our pods. Those pods belongs to internal database of ops manager. Let's move forward. Now, I want to deploy sharded cluster, which is quite complex without Kubernetes. If you want to deploy sharded cluster manually, this will take you lots of time and energy. All I need to do, I need to specify new custom resources, kind MongoDB, type sharded cluster. I want to have 2 shards. I can have 5, but I just want to have 2. With replication for HA. I want to have 2 MongoS's and config servers. I need to also specify config map to ops manager, which we just created. I want to have persistent storage for database. I want to have, of course, security. And I want to have persist multiple storage volumes, one for data, second for logs. Plus, I want to have MongoDB user. So I will use MongoDB user custom resource. I'm specifying the name, and I need to point this user to our sharded cluster. OK, let's execute this. So now I'm just applying Kubernetes manifest, type sharded cluster, and operator will orchestrate building of sharded cluster for me. I don't need to care about storage setup. I don't need to care about network setup, etc. We see that pods are starting to be visible. We have MongoS. We have config servers. And we have our 2 shards together with replication. If we see logs, we can notice that MongoDB agent is installing now MongoDB binaries. So MongoDB agent is orchestrating, in fact, everything from Ops Manager. And cluster is done. And see, here we see that our MongoDB agent is responsible for monitoring, backup, and automation. If we display object kind MongoDB, we see that our sharded cluster is up and running. Also, all stateful sets, which is storage part, has been created on behalf of operator. I didn't have to do this manually. The same with services. So network setup has been done, and now I can use this cluster. I want to show you also one more interesting thing. If we go to our processes, and if we go to shards, we see that we have 2 shards together with replica sets for HA. If I go to one shard, I can monitor my database very easy from this place. So there is lots of charts. I will not show you all of them. For example, you can see replica set oplock window. I can also see real time what is going on now. So there is no application which is connected. That's why there is nothing really fancy. But this is how to very easy monitor your MongoDB cluster from Kubernetes. And there is also Performance Advisor, which will help me to improve my schema or create indexes which there are missing, if they are missing. Last thing I want to show you is a multi-cluster. I want to build disaster recovery, and I want to run my MongoDB replica set on different Kubernetes clusters. What I can do, I can use multi-cluster. So from one central cluster, I can run replica set members on totally different Kubernetes environments. That's a custom resource definition for it. I just need to specify that I want to have object kind MongoDB multi. Currently, only replica set is available for multi-cluster. And here, I need to specify config path to my ops manager, plus I need to specify my 3 different Kubernetes clusters. And this is how to run DR on Kubernetes with help of MongoDB. Quick summary. Operators reduce time, cost, and complexity. That's the best human knowledge to operate MongoDB on Kubernetes. You can quickly scale your database up or down. Also, the operators are taking care about storage part, and this is very complex part if you want to run your database on Kubernetes. Plus, the operator follow the best practices like affinity, pod distribution budget, resource management, and so on. Thank you very much. It was a pleasure for me to talk to you on data on Kubernetes Day. Thank you.
Fantastic. Excellent job, Arek. Grab the horn. Let's get a picture. Yes. Perfect. Love it. Thank you so much.
Thank you.
We're going to invite our next speaker to keep the flow going. If you've got questions, you can talk to Arek in the break, or you can also just tag him on Slack directly. Very open, very active, and happy to help out. Next, Julian, if you want to come up. Yeah. Julian is a Data on Kubernetes community veteran. Well, we'll get you down here, unless you want to hold your laptop at the same time. So yeah, we'll get him plugged in. Julian actually participated in DoK Day last year when we were in Los Angeles, and he knows I've told this story many times, but he was working on a circuit board with a soldering iron and happened to electrocute his fingers. At first, when he said that this had happened, we were like, okay, Julian, you just don't want to give your talk and you're being shy. But he sent us pictures from the emergency room, and sure enough, he had electrocuted his fingers. He came back from the emergency room and still gave his talk. So I think if that isn't commitment, I don't know what is. Let's give Julian a round of applause. That's the real deal. To top that, Julian decided to ride his motorcycle to the last DoK Day. That was in Valencia. He rode all the way from Germany. I forget how many miles that was or kilometers, but it was, once again, a few people have shown the amount of commitment that he has. 1 second really quick. We're just going to get his... Oh, he's plugging it already? Cool. Good. Lovely. Well, that being said, Julian, it's all yours. Go for it.
Thank you very much for the nice introduction. I was building that 48-volt lithium battery, right? And I was using a voltmeter to get a measurement. But I used the cable that is actually used to be used for a power supply. It does not have an insulation at the connectors. So when I unplugged it from the multimeter, the 2 ends attached while being connected to a 48-volt battery that serves up to 10 kilowatts of power. So it basically sublimated the metal, which created a metal powder surface on my finger. When I entered the ER, they actually thought that it was a burning, which it wasn't. So in the end, it was actually not that bad. So I still do build those batteries. So. All right, today I'm sharing a little bit of our research we are doing, as part of our efforts to build Kubernetes-based operators to run data services. So a few words about myself. I'm Julian Fischer, and I'm running a company called Any9s. we are building cloud development platforms with a strong focus on data service automation. We've been automating data services for nearly 10 years based on virtual machines across infrastructures at scale, as well as now, obviously, on Kubernetes, natively using pods. Don't want to bore you with that shameless self-advertisement, so let's get to it. Primary goal here is today, so when I talk about an operator, I'm not talking about an operator that operates a single database. We are mostly seeing situations where companies want to create hundreds or thousands of databases, so automating the life cycle to operate those standard database use cases. It's not about that special case where you really need custom stuff. It's that is the general attitude we have towards automation. Now, with an intercluster instance, this is a bit different because whenever you want to stretch a Postgres database across infrastructure regions, across multiple Kubernetes clusters in this case, I think we are looking at a more custom use case because those inter-region Postgres scenarios, they require a bit of knowledge about the application. Otherwise, the latency can become problematic quite easily. So we are sticking to the conceptual level a bit. If you remind a few talks I gave earlier at the DoK, one of which was how to create a asynchronous streaming replication cluster on Postgres, where we basically created a stateful set within a headless service. No failover, anything fancy, just setting up the streaming replication. So that's a bit of the idea of the local cluster, just to understand the topology. If you would like to be reminded how this works, at learn99.kubernetes.com, there's a tutorial on how to do that. You can follow through. I'm giving a lecture about this at a local University of Applied Sciences. So if you have time and you want to look into that, it's a good predecessor to revisit the talk here. So we are assuming there's a local container image. You could use the official Postgres, or we are using for building our operator the Patroni cluster manager, which comes with its own container image. Usually you define a headless service to be able to address the individual pods using DNS entries that will be maintained for you, and of course a stateful set. Configuration values you can keep in a config map, and your credentials in a secret. So far, standard stuff. Now, what if we take that and want to stretch that across multiple Kubernetes clusters? So our first assumption was, well, we just take one cluster, assume that this cluster will run a stateful set each with a replica of one. So there will be one pod per cluster. Here in this example, 3 clusters, 3 pods, and how can we connect them in order to form a Postgres cluster? Now, the gist of this talk, and that would be the main takeaway, would be it all boils down to the question, how can you do the network connection across those Kubernetes clusters? So pod-to-pod communication across cluster boundaries is basically the thing we are researching. And it was a time constraints research, so we digged up 2 ways that appeared to be feasible. One would be Istio, and the other would be Cilium. I'll go into greater details into Cilium because Istio didn't turn out to be as simple to set up. So we got 2 engineers, they got the same time frame, and one got to manage a working solution based on Cilium, and the other got stuck with Istio. Doesn't mean that Istio is bad or shouldn't be considered, but it's just hasn't worked out in the same time frame. So this may tell a story, or may be up to the individual, performance of the engineers. Now, one of the takeaways when looking at Istio is that at least the way it was set up in our experiments was that Istio uses a sidecar. So basically, whenever you create a service instance, there will be another container in your pod that runs a gateway, and you will talk to that sidecar container in order to get multi-cluster communication, which has some drawbacks. And 2 stick out. One would be this is not available during the pod initialization. So if you do something in init containers that require multi-cluster communication, this could be a constraint. And the other would be the sidecar container obviously requires a bit of resources. And if you do that like many times, which I don't think is really the case with intercluster service instances, however, if you do that many times, the overhead will multiply. So that being said, there are ways to combine Cilium and Istio. I think there are also ways with Istio that do not require a sidecar. So all of that you'd have to research a bit closer in your particular context. So one takeaway from looking at how to automate a data service across multiple Kubernetes clusters was also, well, you don't have the advantage of stateful sets if you have multiple clusters. So for example, ordinality and stable network identity is something you'd have to take care of yourself. And whatever automation you have that's, assuming there's a stateful set or the constraints of the stateful sets to be there, it cannot be just transferred to the multi-cluster scenario right away. I don't think it's a big issue, but still, it would be nice. Maybe you could even create a controller that imitates the stateful set, but in a distributed way, using a state replication mechanism that provides you with sufficient consistency guarantees. So, right, so this just shows that there is a pod, a container in the pod that gives you a gateway. In the example that we've been experimenting with, we are using that Patroni-based approach. If you're familiar with Patroni a bit, then you know that if you try to do leader election in Postgres, you need somehow to ensure that there are not two masters at the same time if you're using asynchronous replication. So there's a primary, that's the modern terminology, I think, and there are two secondaries. For example, you don't want two application instances writing to two different primaries. So etcd here provides guarantees that you can ensure that only one of the primaries can be, one of the nodes can be a primary at the same time. So in the intercluster example, we just took an etcd and stretched it across the same nodes. So in this case, two clusters, but you get the idea. And then configure Patroni to use that etcd cluster as its distributed configuration store. Now, going down the path with Cilium, same approach, but using Cilium, the conclusion was, or the observation was that it's not using a sidecar. Everything happens at the Kubernetes node level, where there's a Cilium agent using a technology called eBPF, I think, which is basically like a bytecode injection into the Linux kernel. It's really fast, so it's much faster than IP tables, for example, at scale. And very nicely, once you've configured Cilium, it's transparent, which means you can have multi-cluster communication through a service. So you'll create a service with a special annotation, and you do that across all the three clusters, and you have multi-cluster communication. And from there on, it's basically building, that stateful set-like experience using pods and services. As of today, Cilium is supported across major platform providers, so you can basically get it for Amazon, Google Cloud Platform, whatever. If you're in an on-premise scenario, it's worth checking whether whatever the Kubernetes flavor you're using provides, a Cilium for it, and whether it's compatible with your networking. But I'm positive that it'll work somehow. So yeah, I think there's not enough time to go into the Cilium details, but it's worth mentioning that it uses that eBPF approach, which is rather interesting. So in the end, you have a similar setup. You'd have two or multiple clusters, and you'd have the pods where the service instance run alongside with its etcd, and they would be communicating to other pods in the other clusters using a service. So it's actually a very neat thing that worked out of the box without too much hassle in a very time-constrained experiment. So I personally think it's, from the technical perspective, not really a big problem to get this up and running. It's more an interesting question, what are exactly the use case scenarios for this? Because, for example, asynchronous streaming replication with, let's say, Germany, Europe, and Asia will create large replication lags, and whenever you do a switch over, you'd have a serious risk for data loss. So, for example, this would be applicable in a situation where you have very little writes and many reads, and you know, strict consistency is not a big issue. So they've also, the research put together a bit of a comparison. I will spare you reading that to you now. To me, the takeaways were that Cilium was easier to set up. It doesn't use a sidecar or doesn't force you to use a sidecar approach. However, it requires you to have a certain degree of control over the Kubernetes cluster. So if you have a Kubernetes cluster as a given thing and you cannot modify it, then you may not be able to use Cilium, which appears to be not really the case. Most of the Kubernetes distros will give you the ability to create a Cilium installation. However, I'm not ranting about Istio in any way. I think it's also worth having a look. But if using the sidecar approach, keep in mind there will be some additional resources. All right, conclusions are pretty simple. I think it's feasible. The experiment shows that it's a straightforward thing to do. The applicability is one of the things you want to look at. And yeah, that idea with distributed stateful set is something I'll take as homework, because maybe somebody already did that and I don't know of. Definitely worth looking into. As I said, if you're interested in how to set up Postgres manually, not to build a production-grade solution, but just to know how it's, you know, how the streaming replication works and so on, there's a tutorial here for free. There's also video recording of that, so if you want to do that, would be a way to go. There's a little demo on how how the experiment basically works. We sped up the entire process. It basically creates 2 kind clusters or 3 kind clusters on a local computer, installs Cilium, and once these are created, we manually create a record in the current primary and ensure that it is replicated to the secondary. So that's basically the visual showing you that we can replicate data across cluster boundaries with the concept I just showed you. So from the effort perspective, I can tell this wasn't, you know, weeks or months, well, weeks maybe, but not months of work. Also, that wasn't their primary objective during that time. So as I said, it's pretty much a straightforward thing to do. We keep you updated with, whenever we touch that topic again, may come up with additional updates in subsequent talks. Feel free to reach out if you have demand for this and would be curious to see this implemented somewhere. We are always looking for use case scenarios that we could learn from. All right, let me see. Video's been, I think, over. If there are any questions at this point, just feel free to ask. Otherwise, well, thanks a lot for your attention. Hopefully that was worth the time.
We've got a question. And is it or is it not pizza related?
It's difficult. It's about MySQL. No, just kidding. Now, how does the backup fit in that architecture?
Well, backups you'd usually create from a primary in such a situation, because that would be the one that's mostly up to date. And the backup in our operator, for example, would be declared. So you'd have a CRD to declare a backup. It's basically a local backup. Whether you want to replicate a backup across regions would be something interesting.
Yeah, mine is more about using as a fallback the actual object store backups, for example, WAL files, in case the network communication goes down temporarily on the other side. That was just if.
I mean,
that
you
could
mean
be an
what if
option.
one region goes down, and what happens then? Is that the
No, if the network communication maybe temporarily goes down, you could use the object stores. The world files that are stored in the object store as a temporary, as a fallback mechanism. So I was wondering if you had planned the backups in that scenario or not.
No, I don't think it uses the backups for that scenario.
Okay.
Well, you could make the operator do something like that, but one of the interesting questions would be, how do you get a backup, globally distributed, where you could try to access, the object store where backups are stored, but if the entire region is, out of order, you need to replicate those objects from the object store as well somehow, which I think most cloud providers can do rather.
Yeah, exactly. I mean, there's several, maybe.
Yeah, interesting thought though. Thanks.
Yeah, no worries. Thank you.
Perfect. That being said, we got to move on to the next talk. Thank you very much, Julian. Give another round of applause. Get a photo. And Jonathan and, John, if you want to come up here. Perfect. Julian, you need a third hand. Okay. Good. Thank you very much. Perfect. All right, our next speakers. We've got Jonathan and John from EDB. They're going to be plugging in and showing us all kinds of goodness, possibly about Postgres, possibly. Saw some really cool street art. If you get a chance to walk around in general in Detroit, there's amazing art. And I saw some street art with an elephant, and I needed to tag Gabriele in the tweet. But anyway, definitely enjoy it. Check it out. And let's keep moving. We got a break after this. All right, let's go.
Hello. My name is John, and this is...
And I'm Jonathan.
This is Jonathan, and today we're going to be talking about highly available Postgres clusters in Kubernetes. A little bit about me first. I've been working with Kubernetes for 5 years. I started at my previous job on an infrastructure team, and they split that out from like traditional infrastructure to create a new Kubernetes team, and I was a part of that, managing production OpenShift clusters. So I did that for 4 years. And then last year, I joined EDB to work on Kubernetes and Postgres, which seemed to be, a pretty cool challenge, and it turns out it is a ton of fun. I do Golang by day, working on the cloud-native Postgres operator, and then I'm like learning Rails at night, which I get made fun of a lot for that, but Rails is fine. So.
And I'm Jonathan. Yes, I'm not San Francisco Giants fan, so yeah, that probably you realize already. I'm not handsome, but sometimes I really like to have fun, so that's why I'm probably the funny one here, not like John. I'm on the Kubernetes World Science 2019, working second quadrants, just for work, 2 years before I started with Kubernetes, obviously trying. And starting on the second quadrant was joining just on a PostgreSQL stuff. So now I'm starting to love PostgreSQL almost every day. Well, sometimes I really hate it, but it's databases. And working on computer science 2003, yes, and I'm a bit old.
So Cloud Native PG is a fully open sourced Kubernetes operator for managing Postgres. It was originally created by EDB, which is the company that we both work for. EDB is a company that has the most PostgreSQL contributors of any single company. So we have extensive Postgres knowledge in the company, and we're bringing that to the cloud-native world through CMPG.
Okay, one of the things our talk is going to be explain how basically the operator works and how it's doing the work under the hood. And we will have a little bit of a demo, something pre-recorded with Ashkinema because, networking always producing some issues. And first you need to know, obviously, we are in a Kubernetes conference that on Kubernetes, so you know how to apply YAML files on the cluster. We are just going to use the standard kubectl commands, just get, delete, probably edit. Sometimes, yeah, we need to use edit. We will explain how our pod and our PVC are created. Probably you will have some questions. We are going to explain you how that starts. And, well, if you don't know what PostgreSQL is, well, probably you should not be here, or you will learn.
Okay, so what do we mean by highly available PostgreSQL? We mean that we need enough PostgreSQL nodes to have quorum in case of a disagreement. So that the minimum number for that, as I'm sure you all know, is 3. Being on Kubernetes doesn't necessarily mean that everything is highly available. Just running on, you can't just run it on Kubernetes and then be like, oh, it's highly available. So what we mean, so we'll talk more about that. Storage is important. Our operator is storage agnostic, so we can work on whatever storage you currently have configured. There are storages that we would prefer and would not prefer, like would not prefer NFS, but if your Kubernetes cluster has the storage class, the operator will run on it. No, we do not use stateful sets, and this is a very important point. In our operator design, it's something that might confuse you if you're new to using the operator. There are a lot of reasons we had for not going with stateful sets, primarily being like the ordering of how you want to bring up, how you would want to roll nodes is different depending on the operation you would use to start rolling out the nodes. So some changes you might need to start a replica first, and then switch over, and then other changes you might need to restart the primary first. So because of that, we have our own controller to handle the spawning of Postgres instances. We do not use the stateful set controller. So that's an important point. That could be its own talk, probably.
Yeah, you will have some questions about it. Okay, we decided our operator in 2019. We started with a really small team, just 3, 4 of us. And we decided to rely everything on the Kubernetes API. That's a really important point right now. And actually, the talk that, I don't know, it's not here, he already left, about cloud-native database, that's really important. And using the Kubernetes API and rely on it to be the single source of truth, it's actually really important, especially if you are in the Kubernetes, because you will have your application and your database will have the same single source of truth. Now, Cloud Native PG is fully open source. We open sourced it this year in May. Yeah, in May, at the beginning of the KubeCon Valencia. It was actually really nice for us. We were looking for that for a long time, to be honest. And one of the greatest things in our operator is the failover. Automatically performs fast failovers. It's an important point. If you have been working with PostgreSQL, you know that the failover is actually not something so trivial. It could be really difficult. And also, we have been working on adding replication slots. Actually, this came from the last KubeCon in Valencia, so a lot of people started suggesting, hey, you should add the replication slot. Yes, we know we should. Do it. Okay. Now we have replication slots. It's really solid in the latest version. We are supporting our version, the versions of Kubernetes 122 to 124. Actually, 125 is also supported, but the reason that we haven't said that yet is because we are going to say it with the next release, which is 1.18. But it has been tested there anyway. Our latest version, we wrote this, it was 117.1. We planned to release 118.0 this week, but KubeCon, half of the team is here, the other half is on the other way, coordinate, not possible, so we are delaying the release for the next week.
Okay, so we have a demo coming up after this, after we're done talking. So the proposed architecture for the demo, what we're going to create is what's known as a cluster object. And a cluster is, it's an extension to the API added by the CMPG operator. And when we create the cluster, I'll say we're creating, the cluster will be 1 primary and 2 replicas. When we create the cluster, the operator will create pods, PVCs, services, secrets, PDBs, and config maps. The pods will be the actual instances running Postgres. The PVCs, of course, for the data. The services will be for things such as connecting, of course. So like if you want to connect to your Postgres instance through a connection string, you could do it through the service. A metrics endpoint. Secrets for the password for the users. Pod disruption budgets to configure so the pods can't all be on the same, don't all go down in a way that could cause corruption. And config map for, of course, configuration. The cluster is not the only extension to the API that CMPG adds. There are, of course, backups. For example, in poolers as well. Backups are very easy to configure. I remember somebody in a previous talk said a backup, a Postgres operator has to have easy to configure backups. They are easy to configure. We're just not covering that in this talk. So.
Yeah, well, literally, stop talking. One of the things is that how to install the operator. That's one of the questions that everyone needs to answer. Okay, that's quite easy, and that's how we design it. Just apply one YAML file. The YAML file that you will actually need is the one in the release page on GitHub. It's just kubectl apply and the URL, and that will work. And if it doesn't, please tell us. We are on Slack all the day, 24/7 mostly. So when we apply this spec, we can go and start doing the demo. And you're going to take over the keyboard, right?
Yes.
Okay.
Turn my
Okay, so we apply the YAML file, and let's do this. Yeah. Okay, we have an internal script which is set up cluster.sh. You can go into the repo and we'll create basically the kind cluster. It will compile the operator. There's load helper images. It's an additional exception function that we add in this script, which is basically to add images that we will require for some testing or even to run the operator. As you can see, it's loading PostgreSQL, PG Bouncer, HTTP, min.io, that actually we use for testing. Okay, this is the same script that you can use for test locally or run the end-to-end test. And at the end, it deploys the operator, obviously, just a YAML file, as I said, the manifest. And right away, you can start creating the cluster, which is one job, the initdb job, and then creates the first pod. And there's the other jobs are join jobs. That, as you can guess, is to join the next pod into the cluster. And we have a nice command that is kubectl cnpg. Probably you can reduce the size of the font. No, you cannot. Okay, this doesn't matter. And where you have information on the kubectl cnpg plugin, we try to provide yeah, go up a little bit. A lot of information on this plugin because, yeah, you are managing a database and your data is there, so you need to know almost everything. So you will know which one is the primary, the standby, the kind of replication, which in this case is async, yeah, in the standby and everything. But the important thing here is what can we do with the operator, okay? We can edit the cluster just like kubectl edit. That's where the kubectl commands are important. And go down, and for example, we can go, you will see that the configuration, there's a lot of things here. You will see the initdb, because probably sometimes people will want to use a different encoding. The database, the initial database will be up, the images that you have there, and there's a lot of things. And this one is important too, the monitoring stuff. The operator has inside Prometheus exporter compatible, a Prometheus exporter basically. We expose the port, and you can actually just query any of the pods asking for a lot of information that we provide by default, which is basically a big set of queries that is running inside the cluster. One are running only on the primary server, and others are running on the replicas only, and some running on all of them. And one of the interesting things that you can do, and this is, you know, when you are working with Postgres, this is one of the more complicated things that we were doing, and I learned this in the hard way, which is the synchronous replication. Basically, you have one query that gets inside the primary, and only will it return and say that it was successfully when it's replicated to, in this case, is a minimum of one, yeah, when it's replicated to one of the replicas, okay? So let's apply it. And that's it. Can you run the kubectl status? CNPG status. And you can see that the quorum already changed. Now it's not async is quorum, meaning that we have asynchronous replication there. And that is kind of one of the hardest things when you are doing the basic PostgreSQL. Okay, but how hard is to do some other stuff like replication slots? Replication slots are really complicated at the end of the day, and we know that. Well, we implemented this a month ago, but sadly, the talk is a bit shorter, but can you open the file, the cluster YAML file? And we are not able because we are almost running out of time, but it's just that. You can, there you go. Replication slot, high availability, enable true. And that will enable your replication slot. What's the idea of replication slots? Signs. One of the things that when you are replicating, you can rely on the WAL files. But the WAL files, at some point, you may have problem with the storage, and that happens, especially if you are using NFS or something like that. So this will allow Postgres to stream everything directly to the other replicas, and you will not be losing data. There's some more on documentation on this one. Can you go back to the slides? Next slide. There you go. First of all, we're hiring. We're about to close because we're running out of time. We're hiring. We're looking for Go developers and with operator knowledge. And that's important, the operator side. The Go, probably you can learn, but the operator is really important. And that is totally agree on you build it and you own it. We work as a team, and all the members here is owning the thing that is doing. Like my man here is working with some support on Velero and stuff like that. And it's great. Yeah, he needs to write documentation today, by the way. And loves to play in a global team. And finally, but not least, thank you very much. And this is the site to get the operator. Cloud-native PG, if you can, please give us 1 star on GitHub. It's really nice. So that's it. Any question? Thank you.
All right, let's give it a star and give it a round of applause. All right. If you've got questions or if you want to work with these wonderful folks, you can talk to them in the break. We're going to take a 10-minute break right now. All right, actually, we can take an 8-minute break, you know, Kubernetes K8s. So let's take an 8-minute break. Let's be back here in 8 minutes to continue with the final talks of the day. Let's get a picture with you lovely folks. Yep. Okay, whatever you want. Thanks, guys.
Hello?
Oh, no, I just got to let him know. All right. Excellent.
Yeah, it's on if you want to turn it off for now.
Same to get folks to come back in, but we'll start in like 1 minute, okay? All right, perfect. So we're going to get started again with our final push with the last talks of the day. By the way, super excited to see how many people have been with us today in person. It being the first time we were adding the in-person component, we weren't exactly sure, but the audience has been fantastic, good questions. So give yourself a round of applause. It's not easy. And the online people, give yourself a round of applause as well. We love you very much. Hope lots of folks are clapping at home. So previously in the panel that we had with people working on Fybrik that were helping out, ING, we were talking about, financial data, banking data. What about the case of healthcare, all right? Where patients have their data? It's going on Kubernetes. What's going to be going on with that? So to talk about that more in detail, we will be assisted by Olivia and Prasad. And with that being said, feel free to jump right in and start your talk. Go for it.
Hello, everyone. So I'm Olivia from Avacia, and I head up marketing and product UX at Avacia. And this is my colleague, Prasad. He's the chief product officer and a co-founder as well. So today, as Bart said, we'll be talking about a use case of a healthcare system that we developed on Kubernetes. And all of the technology, the multi-cluster, and everything that we've been hearing today, we have a multi-cluster, multi-tenant orchestration platform called KubeSlice, and we built this healthcare system on KubeSlice that I will be describing a little bit. I'll start with presenting the use case, and then we'll go into the technology a bit as to how we did it. So, show of hands, how many of you have had or know about colonoscopy? Because this is, yes, so if you're above 45, you're required to have a colonoscopy now. We know how fun that is. So in this particular system that was built on Kubernetes, there was an AI model that was assisting a doctor to do colonoscopies in real time. So actually, I have a picture here. So it was like that. There was a bounding box that was telling a doctor that there is a suspicious polyp here, look at it. So the components of the system was we had edge servers, we had stuff running on cloud, a multi-cluster system, and we had the feed node, which is in the operating room, where all the data was being collected, sent to the AI model that's running on the edge, and then some processing and learning happening on the cloud. In addition to that, in addition to this AI, real-time AI detection system, there was also a workflow automation component that we had, where it was all hands-free. Yeah, talk about a hands-free system these days, right? So it was all NLP-driven. So the doctors would actually talk commands into the system So when they see an AI model and they see a bounding box like this, they'll say, take a picture through voice, and the system takes a picture. And then the doctor will say, sessile polyp, or whatever medical terms that they use. And our workflow automation system was smart enough to understand all the medical terms, and then it was directly written into a report. So all of this, so talking about data and healthcare on Kubernetes, so the system that we developed needed to be very secure. It needed to perform with ultra low latency. What we mean by that is that the whole back and forth from capturing those video feeds from when the scope is inside your tummy into going to the AI model running at the edge and then going to the cloud and coming back, that whole round trip latency needed to be less than 120 milliseconds. And then, we're capturing frame by frame, and then the model is learning and the model is detecting at the same time. That inter-frame latency needed to be 17 milliseconds. So there's a lot of processing, real-time processing. It needed to be secure. And then coming back to the whole topology, and before I get to this, I'd like to say that even last week, this was it was actually being used in New Delhi in India by Apollo Hospitals. Those of you are aware of the name, it's a big hospital brand. And with Airtel and AWS as partners. And also in the US, we had one of the largest ambulatory service providers, AmSurge, and together with Verizon, we tested all of this back and forth multi-cluster connectivity and the latencies and what enabled us to put a system together like this, and this is where we are going with the system, or where there will be multiple regional hospitals, and each room would have a feed node collecting data from the patients, and there'll be multiple edges that's processing the data, and in this hub and spoke model, there will be real-time inferencing for the doctors and the nurses, and also real-time voice processing as they are recording their findings into a report. So this is the whole workflow automation part that I alluded to a little bit earlier, where the doctors would actually, as they are seeing those monitors and the bounding box, the green bounding box that's assisting them during a real-time colonoscopy, they're talking commands to the system and actually writing reports in real time by voice. And with that, I will hand it over to Prasad, who will talk about how this multi-cluster connectivity and communication happened, how we had a multi-tenant architecture where KubeSlice, our fundamental technology, how that creates a slice for every hospital, or how we create that isolation between, say, the voice and the AI and the voice and the video streaming data that's going back and forth.
Yeah.
Over to you, Prasad.
Thank you, Olivia. So as Olivia described, right, one of the foundational things which we have needed to do is that we needed to have a network which is L3 and above, right? So API-driven systems are not going to be possible. We needed to have RTP streaming. It needs to be encrypted all the way in. So, and essentially, ingress and egress works well, but not everything for the data side, right? So how do you bring about low latency east-west traffic rather than north-south traffic, right? That's one thing which we wanted to look into. And obviously, Kubernetes is necessary for us to be containerized up workloads. Nothing can be more easy than Kubernetes from an edge, and as well as feed node running small K3s and different shapes of this thing. One other thing which at the edge node we had to have processing using NVIDIA for our image kind of a thing. So CUDA core needed to be there, so that we need to have a dedicated nodes to make sure that we image processed. And then The communication is very important for us because of the, as Olivia described, inter-frame latency cannot be more than 17 milliseconds. And the overall round trip was, you realize that the scope is inside the body, right? And doctor has a mic'd up or a phone, which would, the Bluetooth is going to indicate if there is any bounding box or a detected polyp in there. So all that round trip is important for us, the system to work. So that's the reason why we built, as latency is, as I described, image needs to be stored because you're constantly learning. In the cloud, we have a learning system which has already processed a whole bunch of images, but as in new images coming in, we are kind of constantly learning. And at the edge node is where the inferencing module sits, and then the feed node is actually detecting. So we actually have two screens. One screen is from the scope provider, whoever it is, Boston Scientific or whoever. There will be that, and then there is another screen wherein the bounding box is showing up, so that at least the doctor is not distracted. So all of these things needed to have more data intense kind of a transport, right? So what we built is a cube slice, right, which is essentially a way of sharding the Kubernetes cluster, right? And then create a virtual cluster across multiple clusters. You have a cluster in the cloud, you have a cluster at the edge, and you have a cluster at the feed node, right? And all of these things are kind of forming how it needs to communicate to each of these, right? So obviously, everything has to be end-to-end encrypted because, HIPAA compliance, the different patient data which is going in there. Although a lot of these things are obfuscated, but you realize that when an image is there on top of it, a patient name shows up or something like that. We need to make sure that everything is kosher from a standpoint of encryption, storage, and all that stuff. Right. So tenancy is needed because different, either hospitals or different divisions. Let's say our first entry in colonoscopy doesn't mean to say upper GI versus lower GI. You can't use the same system. And then cardiology has other applications inside it. So it's the same hospital may have different divisions who are going to be using the same inferencing system. So you needed to have a tenancy associated with it. Am I running late? Sorry. I'm trying to make cognizant about the type. Obviously, if you look underneath the hood, the architecture from a slice standpoint, we actually have dual interfaces inside the pod. You have a CNI interface, which is essentially the lifecycle management of the cluster. But we also created something called an overlay interface. Overlay interface is something which we use to have this real-time data growing across from pod to pod standpoint. And then, obviously, in order for the services to discover itself, we needed to have on the slice, what we call it as a slice is a kind of a way of describing. It's a CRD, it's an operator, everybody talks about it. In all the clusters, we have an operator running in it, which actually instantiates all the pods and then gives an address. The advantage which we wanted to take is that, we don't want it to have IP address management across all these clusters. We wanted to get rid of all that IP address management. We need to be able to get the edges as fast as possible and not have a long life cycle with respect to addressing and all that stuff. So this overlay address gave us a much easier way of defining a slice, right? And there is a bunch of components. We have software-defined network built into the cluster. Not, there are different ways. So if the AWS and Verizon brings the edge, that's one way. Mac is another aspect, which with respect to Airtel, we are trying to use AWS Outpost as an edge, and then bring it up. AWS, with association with us, did this trial in India. But irrespective of what, we wanted to be self-sufficient in how we run these clusters, right? So that's the reason why we needed a better way of isolation, better network, which can do layer 3 and above. It can do RTP streaming. It doesn't have any firewalls or /natting. So when you have a multi-cluster, you're actually creating a virtual cluster from a networking standpoint. So every pod on the slice is able to talk, be it in a cluster in cloud or edge or feed node, right? So that's the most important thing from a latency standpoint, which you had to do, right? That's about it. If you look at our YAML file, because everybody started showing YAMLs, our YAML file is very simple, right? We have certain, doesn't show, right? Other than the PowerPoint. Okay, so we have a booth in SU46. If you want to see, I can show you all that there.
And I'd just like to add, we have, please check out kubeslice.io. I've open sourced a lot of our components and our tools. So, as someone said, go and start it, like it, use it, and please do reach out to us.
Very, very good. That being said, do we have any questions? We got time for one question. Or maybe two if they're really fast. We're good? Well, you know where to find them. You know where to check them out. Excellent presentation. Thank you so much for sharing with us today. Let's give them a round of applause. Come on, let's get a picture. And Victor, if you're up, all right? No, wait, we got to get a picture. We got to get a picture. Yeah. All right, here. We all get the horn. Very good. Fantastic. Thank you. Next up, we have someone who's never given a talk in his life, never produced a YouTube video, very, very shy, afraid of people. Victor is an amazing developer advocate. Very much looking forward to what he has to say. So just going to let him get set up and then get that started. As always, make sure you're starring everything on GitHub, sharing all the good news, checking stuff out. We got plenty of content that we've been sharing today. If you arrived a little bit late, everything's going to be on YouTube, so don't worry about that. And we'll just let Victor get set up. Still got a few more talks, so please, please, please stay with us, and online people as well, wherever you may be. And yeah, it's always interesting that every DoK day always has a little bit of a different flavor, a different vibe. Today's flavor has definitely been pizza focused. I do have to ask, does anybody eat pineapple pizza? Okay, that's a thing. It seems like on social media there's like so much hatred towards pineapple pizza fans. I'm not like a mega pineapple pizza fan, but I certainly don't hate on it. I think it's also really good with jalapenos. Personal opinion. Thank you, Ramiro. Good. Oh, good. Somebody else too? Good, yeah. Good. We got some good people here then. All right. Well, yeah, but it's interesting how conflictive that debate is if you really want to get something started. We could also try it. Who's a Pepsi fan?
Screen mirroring.
Coca-Cola? All right. Alternative cola beverages? No, Dr. Pepper?
Mirror.
No Dr. Pepper. Oh, we got one Dr. Pepper fan. That's good. Very proud Dr. Pepper fan. That's good. Root beer? That's one of the things. I live in Spain. In Spain, we don't have root beer, so it's something that I miss a lot. Ginger ale or ginger beer? Any fans?
Exactly.
We got one. That's cool. That's good. Yeah, all different flavors, all different. This is what we really focus on in DoK Days, what we like to eat or drink.
Okay,
any tea drinkers? Because I've seen a fair amount of people. All right.
Okay.
Coffee? Decaf? Now this is where I draw the line. Okay, I appreciate your honesty. But in my family, we say death before decaf. All right. Victor, you should be good to go then.
Yeah, okay.
Awesome. Good.
Okay. So I will try to do something different compared to other talks, because most of you are probably ops or DBAs or something in that direction, right? And talks for success, good tips how to do your job better. My focus is on a slightly different direction. My focus is more towards enabling experts like yourself to create services so that your users can consume them directly, right? So think of what I'm going to show as some form of creating platforms that will enable the rest of the people in your company to do stuff themselves, right? What we typically call today internal developer platforms or something like that, right? So my name is Victor. I work for Outbound. We're the company behind Crossplane. Crossplane is what you will see today, among other things, and et cetera, et cetera, et cetera. Not important, all that stuff. What does matter is that the goal of my presentation is to get rid of Jira tickets, Slack messages, you know, those, can you create a database server for me? Can you create a cluster for me? Can you define a stateful application that will use that database for me, right? Because the reality is that most of the people did not spend 57 years studying AWS and 17 years studying Kubernetes and 3 years studying in service meshes and all the good things that we need today, right? So how we're going to do that is by creating tailor-made services, right? So one way to accomplish that shift left towards enabling developers to do stuff is to subscribe, use vendor-opinionated services like Heroku, right? Which fails, which is actually a great type of solution, but the direction I'm going is into making services yourself, making that platform yourself so that it's tailor-made, it's doing exactly what you need to be done in your organization, in your environment, right? So tailor-made services done in a way that anybody, no matter the level of knowledge, can consume them. Make sure that they are auto-documented, because nobody likes writing documentation as something separate, and that goes and becomes obsolete next day. And finally, even though I will not show this part, right, the ultimate goal from this perspective is that everybody, app developers, interact directly with Git rather than the system. I will not do that today, mostly because I want to show you how things work in the background, right? So what I will do is go through the whole process of everything that application developer would potentially need to run a stateful application by himself or herself, together with the database in a cluster, everything created by himself or herself. So requirements, now there are a zillion ways how we can run databases and stateful applications and what's not, but today my example will be based on running applications in a Kubernetes cluster, having a database server somewhere, which could be in the same cluster, it could be in AWS, Azure, Google, depending on what you do, what you use. I will use AWS today, but the logic is the same anywhere. Next, that application developer would need to not only a database server, but also at least one database in that server. It would need a schema for that database, a way to develop an application, and finally, a way to move that application to permanent environments, like staging, production, whatever the cycle is, right? So this is the scenario. Those are the requirements that I want to do. Now, the way how I will do that is by combining a couple of tools. I will use Crossplane to generate those services and to operate those services. Basically, essentially, in this concept, Crossplane will serve as a way how to convert operational knowledge of different types of expertise into services that others can consume. Schema Hero for the schema itself, Octeto for development, and a lot of Bash. Right, I scrambled this demo. I like doing demos. I don't like talking for long overnight, so I did not. You will see a few shell scripts instead of CLI, which is normally what I would do if this would be more serious than a demo, right? So let me get right to it. Let me go through the demo. So the first thing we need in that hypothetical situation, shift left, self-sufficient application developers, the developer would need a cluster, right? I will do just that. And I will switch to my terminal, right? Now, if you're the type of person who likes web UIs with a lot of colors, not going to happen. You will see only terminal. So let's say that first thing we need is a cluster, right? So I need to be able, as a developer, I'm an application developer today. I have no idea what the heck people are talking about when they talk about Kubernetes, AWS. I mean, I do know, but I'm not an expert. Let's put it that way, right? Because nobody can be an expert in everything. So first thing I need to do is to define a cluster, right? And imagine that some SRE, DevOps, DBAs, whomever, spent time with me, and we came to these requirements that for me to run a cluster myself, I there are certain things that I care about, and most of the things I don't care about. Like I don't care about subnets, right? No developer really cares about subnets and similar things. I do care about whether the size of the nodes of the cluster will be small, medium, and large. And I'm intentionally saying small, medium, and large because in this hypothetical situation, I do not know what medium means in AWS, and it's probably very different in Azure. And I want to have a starting number of nodes in a cluster. I want to be able to select where the cluster will run and what will be the type of the cluster, in this case in AWS EKS, but I could have changed these labels to Azure, right? Depends all on how many implementations of this service somebody created, right? And by the way, this does not come out of the box. This is me creating a custom resource definition using Crossplane and a controller that will convert this input into whatever is really required to run, in this case, a cluster, right? So what I will do is create this. And I will do that in the easiest possible way, and that's saying I have a namespace for me and my team called A-team. I'm going to apply whatever is defined in example skates AWS EKS.yaml, right? So I'm applying it to the cloud. Now I'm cheating a bit, right? Because it takes 20 to 30 minutes, approximately one episode of Game of Thrones to create a cluster in AWS. I did not want you to wait for that, so I executed the same commands, but it didn't do anything that I'm not doing right now, just that I'm repeating what I did before, so that you will not need to wait, right? So my cluster is created. I'm having coffee. 20 minutes later, I can say, give me the status of what I created, namespace, A-team, get cluster claims, and you will see that my cluster is up and running. This is all custom, right? This is made for me. I can see the status of the control plane, the node pool, active, everything is synchronized, everything is ready. Now, I mentioned before that documentation is important and that it's auto-documented. So if I would actually really like to know how to do those things myself, I can go to auto-generated documentation and see all the fields that I mentioned before, right? This is the schema, these are the parameters you can use, these are the statuses you will get, and all those things, right? And while I'm here, let me quickly go through, where is it? Just so that you have an idea of what involves behind that very simple YAML. Basically, you can see here that I have a couple of implementations, like, hey, this is if you want to run a cluster in Azure, cluster in Civo, here and there. I'm using today AWS. So this is what is happening behind the scenes, right? This is the, if I find it ever, here, right? This is my definition that whenever somebody creates what they call cluster claim, I will get an EKS cluster, and I will get what is this? A node group and subnets and VPCs, and I will install some applications in that cluster. I will make it production ready, right? But for me as a user, all I'm interacting with is that custom-made interface, right? So I have a cluster. Let me go back to the terminal. What I need to be able is to access that cluster. And I created it in A-team namespace, and I can say, get me secrets. And you can see that I got a secret with authentication to that newly created cluster. I can access that secret. I will do that through a silly script here that I created. This script basically essentially doesn't do anything special. It will just do kubectl get secret, output to JSON, parse it, decode it, and all the good stuff that everybody does. So I'll just have a script that will help me with that, A-team EKS. Here we go, right? This is now the kubeconfig that I can use to access that cluster and operate it in a similar fashion like I did before. And I can prove that to you by exporting kubeconfig and saying kubeconfig is here. There we go. And if I now say get nodes, you can see that my cluster that I pretend I created right now, but I actually did 5 hours ago, is up and running. Now, the next thing I need in this scenario is a database server, right? For me to create a database server, I can do it in a couple of ways. I can say, hey, and I continue the logic of custom-made services, custom-made resource definitions, I can define something like this as a developer and say, I want something called SQL claim. With labels, I'm saying that I want that database server to run in that same cluster. I want it to be Postgres, and a couple of parameters, like version of Postgres, small, medium, big, all the good stuff. I'm not going to use this one today. I'm going to use a slightly modified version, and this is almost like finding Voldo, because basically, essentially, for me to run a database service one place or another, the definition is the same, right? Above and below is the same. The only essential difference is in matching labels, that here I'm saying I want the database server to be in AWS and I want it to be Postgres, right? While the previous one, same definition, just through labels, selecting different implementation. Now I'm going to apply this and say in the namespace. Now, until now I was working with one cluster, management cluster. Now I'm switching to the new cluster that I created. Namespace is going to be dev. I want to apply whatever is defined in examples SQL aws.yaml, right? So, what did I do? Namespace. Almost there, right. So I created that SQL claim, custom resource, and behind the scenes, it will create the subnets and VPC and DB this, DB that, RDS, whatever is really required. All the things that somebody else would create for me if I open the Jira ticket and assigned it to somebody who knows that stuff, right? And if I would like to see the status, I can say, namespace is dev, get me all SQL claims, and you can see that my database is ready, and I have authentication to the database stored in a secret called mydb. Now, what else would I need as a developer, right? I have a cluster where I will run my application. I have a server, in this case RDS, could be something else. I would need the database, right? And this is now where Schema Hero kicks in. You can use other tools. Now, the good thing is that as a developer, I don't need to care about installation of Schema Hero and making it run, because that's all part of the creation of the cluster, right? I made cluster already production ready. So among other things, the Schema Hero is already running over there in that cluster. And when I created SQL Server, among other things, it also created one database in that server, and I can check the status of that by get databases, PostgreSQL, SQL crossplane.io, and you can see that if the demo works, it usually fails. There we go, right? So the database itself is created in that server. I didn't do much. I mentioned that I need to be able to access the database. For that, I will use an ugly script that I created ad hoc that will essentially do the same thing, similar thing what I did to get authentication to Kubernetes cluster. It will just parse the secret, retrieve it, and show me on the screen all the information about, that's the password, that's the port, endpoint. That's how I access that database. Is there anything else? Oh, yes. I need some tables in the database. I will use Schema Hero for that. Now, I'm switching from Crossplane to Schema Hero, really. So I'm going to say, where is it? Kubectl, namespace, dev, apply, whatever is defined in file, examples, SQL, Schema Hero, Postgres, YAML, right? This is just a very simple table, to-do list, or something like that. In that database, list of videos, something like that. Doesn't matter. It's schema. Actually, if you're curious to see how it looks, it's very simple.
We gotta hurry up, Victor. We gotta hurry up.
Huh?
We gotta hurry up.
Okay. How much time do I have?
That much.
Putting a lot of pressure with me. Okay, and that's about it. Then I just deploy my application and run it. I have a cluster, I have a server, I have a schema, and I have everything, and I did not really need to know much about Kubernetes or AWS or anything else. See, when you say go fast, I go fast.
That was the fastest Game of Thrones episode I've ever seen. That was good. Let's give Victor a round of applause. Amazing. And nobody died. Nobody died. Unfortunately, we don't have time for questions. We got to get to the next speaker, but thank you very much. Great job. It's wonderful. That being said, we got to get a picture of the horn, of course. No, Ben, yeah, our next speaker, Ben, you can start getting plugged in. Victor, let's get a picture with you. I think the season finale of the new Game of Thrones came out recently. Maybe, yeah. No spoilers. Somebody probably did die, or at least one. Maybe a dragon, maybe not. Cool. So yeah, Victor, if you can. Oh yeah, you can be on the stage. I'll be. Speak to me. That involves so much flexibility. Let's give another round of applause for Victor. Very easy to find. Very active in the cloud native ecosystem. Has some awesome content on YouTube as well. So definitely stay in touch with him. Our next speaker, I think, has given about 55 talks in the last 2 weeks. If you follow Ben on Twitter, he's very active. You gave 2 talks yesterday in Regents?
I gave 2 talks yesterday, like 2 talks in DevOps Belgium 3 weeks ago, and back then 3 in London last month. So
and now you're here.
You're
on the road, you're on tour. Anyway, Ben, it's all yours. Take it away.
Okay. Hi, guys. Full disclosure. Okay. I love pineapple pizza. Okay. Throw me rocks. Okay, so take the whole presentation as part of the of this with this principle. So this is a really a talk for those who are just learning Kubernetes observability and how to look at the data-driven observability around Kubernetes and a little bit about security around stateful applications. So most of the Victor can do whatever he wants and does great YouTube videos and he's invited to these talks, but he's not limited. I was told, right, Bart, that I need to pre-record the demos. So yeah, so I'm going to all the hands-on stuff is pre-recorded. I'm going to show you a few slides, about what I'm going to show you. Then we are just going to view together a video I created yesterday. So just really a few words about it because about me. I'm CTO of Armo, a small Kubernetes security startup. I'm coming from the deep security world into cloud native, and giving a lot of talks lately. So what I'm going to show you, I'm going to show you a very simple setup of Minikube with MongoDB installed as a stateful set. We're going to look at Kubernetes Lens as a way to observe this application, how the stateful set looks, PVs, PVCs, and disk usage. Then we are going to look at a little bit my, the project. I'm a maintainer with Kubescape. We're going to look at the security of this application. We'll look at vulnerability scanning. And how is RBAC looking like? Then we'll do a little sneak preview of Grafana and Prometheus, how you can view this application under this. So it's really for for us to begin with. Let me check the video. This is, I hope so. You see. So again, we're starting by a very simple Minikube. I've installed with Helm Prometheus, Grafana, locally with installed MongoDB, from Bitnami, installed Kubescape as an operator, and just took the secret of Grafana, so later we can log into Grafana for the first time. So as a first step, well, I'm going to show you that everything is running here, as expected. So you can believe me that everything is here and right, okay. And the our MongoDB is here, and we are going to Kubernetes Lens. Under Kubernetes Lens, you have my Minikube, and honestly I have to tell you that at the end I connected also one of my Jenkins instances to show something. But in general, if under Kubernetes Lens you're opening the cluster, you'll get a few nice overview about what you have, and you have these stateful sets under the workload page. within the workload, okay, you can see these different parts, okay, of the workload definition. And you can see this single instance of pod, okay, under its instances, and you can go scroll down, okay, and what you can see here is actually the most interesting thing we have here is actually the volumes and the mounts. Okay, we have the Bitnami MongoDB directory. And what you can see below, okay, if you're looking at your stateful set, is actually the persistent volume claim we all longing for. So if we're looking inside, okay, we can get information, okay, about the persistent volume claim, okay, when it was created, its size. Honestly, I really try to hook up to the disk information, okay, inside Kubernetes Lens, and the result of all of my trials was a bug issue I opened on Lens, which was accepted. So there need to solve some issues. So I reconnected to an actual live cluster we have with Jenkins, where we have under the stateful set. We have Jenkins, and here we can see a little bit more about the disk itself and what we have, under the file system inside Lens, which is pretty neat because there is always this discussion whether we as hands-on people we like UI or not. I do think that though I really like CLI, okay, UI can be very, very helpful, especially with debugging and looking around things and understanding them really, really, really fast. But in this case of this Jenkins instance, okay, we have a real volume, EFS volume behind this volume claim. And you can see here, yeah, actually the volume claim should be, if I remember correctly, I found it a little bit later, downwards. Yeah, EFS claim. So it's always the question, okay, of what kind of volume you want to use under AWS. I honestly, in case of Jenkins, I was really preferring EFS instead of EBS because of the debuggability around Jenkins. I like to back up stuff outside the pods and stuff, and therefore I really like the EFS and its usability, so I can have another machine bound to that same file system and talk to it. Obviously, on the other hand, there are performance issues, okay, with it, but in this case, we are not really caring about it because this is not a high load system. So going from this, okay, returning to our Minikube, okay, we can see also that within the Lens, we can see Kubernetes events which are popping up. So those who want to, have observability inside can see them. So now we are switching, if I remember the recording correctly, we are switching into the security space. Sorry, I want to skip here a little. Yeah. So as I told you, okay, I've installed Kubescape operator. Okay, Kubescape is an open source security platform for Kubernetes, which is scanning for configuration security issues and vulnerabilities in your cluster. So here I went to the UI. In the UI of this cluster, which I call DoK Demo Minikube, okay, I'm going to check out all of our security controls. And first of all, okay, I want to see only the failed controls and then those with the highest severity. And then we can see a few interesting controls. Okay, one is that we are seeing here a privilege container. So privilege containers are sometimes okay in Kubernetes. Therefore, we are saying, well, we accept it. On the other hand, okay, we see that there is a potential security issue in the stateful set of MongoDB. because this control fails because it thinks that there is a credential inside the YAML file, which is kind of funny because honestly, I think that this can be an issue, in Kubescape itself, because the definition, it thought that there is a password inside the YAML file, which weren't. But on the other hand, it was a security issue in the sense that, you allowed empty password files, which are not really good. So another control is which pods have network access. In this case, these all were good. And while we are reviewing, also the security issues, there is another security issue which is called resource limits, which is both a security and obviously an operational issue. If you're not putting limits on your workloads, can be an issue. And this is in this case Grafana. The Helm chart came without limits, which is not a good idea. And also MongoDB stateful set for some reason by default is not coming also with limits, which is also not something good. So in general, this small cluster can give you like half an hour work of reviewing all these potential security and DevOps and operational issues. Beyond that, I don't remember if we have here something interesting, like things like etcd is not encrypted. Also, whether host path mounting is acceptable for these workloads. In this case, all of them are known workloads, so I've said that I don't want to see them. So we're heading toward image scanning and vulnerabilities. So within Kubescape operator is scanning your images in your Kubernetes cluster. So there's a good question of whether you should scan your images, in your registry when you're creating it, or you should also scan them, inside the Kubernetes cluster. And if they are already scanned as part of the registry or even before, why you should scan them inside your Kubernetes cluster? Does anyone know the reason why? Sorry? Yeah, exactly. Because vulnerabilities are, is not a constant. It's not one thing. Every day we find new vulnerabilities. And one day we don't have a vulnerability in our application, and the second day it turns out there is the log4shell issue. And then we'll get a different. Therefore, we must monitor our images inside the Kubernetes cluster. So in this case, we have monitored the MongoDB stateful set. And we see that there is a single critical issue. So at the end of the time, if Bart says that I have 2 more seconds for me to show you something cool, hopefully I will be able to show you something more interesting about this. So I'm also showing here the RBAC of this cluster. What with the different roles and bindings and the different subjects you can review inside your cluster, which is super interesting. When we're talking about security observability. And I really suggest you to a little bit monitor the RBAC inside your cluster. Because this is important for your security. So since we don't have a lot of time, I'm a little bit skipping ahead. This is more RBAC stuff. So again, I've installed also Prometheus. So very easily, if you are, if you haven't known Prometheus and Grafana before, it is really the cloud native way to do observability. Logging into my Grafana, which takes data from the Prometheus DB I have on my system. Inside, we have these different dashboards, which can the generic dashboards for reviewing the cluster health and different usage inside the cluster. We have more dedicated dashboards, for in this case for Kubernetes stateful sets. which is like, in my case, okay, was in Minikube was not really nice because for some reason I didn't get the data through. Yesterday when I tried to set up, okay, this demo. And you know, also these persistent volume issues, okay, which you can, you know, raise in very, very simple dashboards inside Grafana, which I think is really, really useful. And those who haven't used them before, I think this is the really right way to look into these things. So this is about, you know, the recorded demo. So I wanted to really, just for 2 minutes, okay, return to the question of vulnerability scanning. So I don't know if you recalled how many vulnerabilities MongoDB had during the scan. Anyone remember? I don't. So it must have more than 20, okay, if not more than 50 or 100, okay. The Kubescape operator uses Gripe, okay, which is part of the Encore project. Okay, it's a great vulnerability scanner, but it's the same for any other vulnerability scanners like Sneak and Trivy, all of them. They're giving you overwhelming results, okay? And if I'm as a security engineer, okay, I need to, you know, solve these issues, trying to get updates, trying to get ahead of top of these things, okay, it's really hard because most of the time I need to, in a big cluster, I always have to run and update images. So what I wanted to show you in really a sneak preview of a cool project we've done with Kubescape, which is, let me just do the slideshow from here. So this is a vulnerability scan summary of Nginx, I think, yeah, Nginx deployment. So if you can see, okay, there is a summary here that it has 396 vulnerabilities altogether after the simple static vulnerability scanning. And during the runtime, we've detected only 4. What Kubescape does, I mean, this is the POC project, okay, and we've just released, you know, really the really first version of it, is actually it uses eBPF to detect which software packages are used during the runtime of the pods, and by understanding which are really loaded into memory, we are simply creating a different alternative vulnerability scan results which are not containing those vulnerabilities we are related to packages which are not loaded into RAM. Why is it? Because most of the packages are coming from your base images or build tools, and they are not really used, so they cannot be exploited. So this is really, you know, this is not a real, by the way, this is new, I'm not sure that this is the right result, okay, because in the sense that this Nginx doesn't do anything, it doesn't even load SSL, okay, so it is the dumbest Nginx you can ever find, and I'm sure that most of the Nginx you're using, okay, are much more, you know, loading more and more software packages. But I wanted to show you that you know, you can make vulnerability scanning more relevant, okay, and more easy to digest. So this is about us, and hope it was, you know, I did it in right enough time.
You did. It was fantastic.
Okay. Thank you very much, guys.
Thank you very much. Great job, Ben. Great job. Great job. I think Ben's going to have to get a T-shirt with World Tour 2022 to put all the talks he's given different places. Let's get a photo. All right. Fantastic. Another round of applause for Ben. Thank you. All right, so next up, as you know, we very much like challenges in our community, and we've had about every different kind of format you can possibly have for a talk. This talk will be given by Akshay, who's live on Zoom, and then he will be accompanied by Peter, who's here in person. So Akshay, I think he's asking if he can be unmuted, if we can get his microphone activated and hear him. That will be the first step. And then we'll have Peter to fill in for the demo at once Akshay gets through his. Akshay and Peter work for a very underground startup called Google. You may have heard of it. And we've had the pleasure of having Peter with us before for a live stream. And this will be the first time we'll be having Akshay. Let's see. Okay, somebody will. Who will? I have the ability. Oh, wow, it's all on me. No pressure. Let's see. As a panelist, you should be able to, but that's what makes these things exciting. Let's see. Yep, asking him to unmute. Akshay? Akshay? Tell him to start talking.
Cool. Hey, everyone.
Speak and be heard.
My name is Akshay Ram. I'm joined by Peter today. Both of us work at Google. We're super excited to talk about stateful applications in Kubernetes today. And also happy Diwali for all of you in the live stream and the audience who may be celebrating Diwali today. Let's get started. Today we're just going to talk about stateful applications and in terms of the value prop, what we see as a cloud provider of value customers see running stateful apps in Kubernetes. We're going to take a little bit of sneak peek on our roadmap as to how we're trying to actually improve the quality of stateful applications in Kubernetes, specifically as a cloud provider contributing to Kubernetes. You're going to take a look at a little bit of architecture of how we see modern SaaS applications like database software as a service applications being built on Kubernetes to benefit from all of the modern capabilities Kubernetes offers for stateful apps. And finally, you'll see a demo where we'll kind of show you a sneak peek of a feature which we're working with the upstream Kubernetes community to migrate stateful sets across clusters. I won't take too much time on this slide. I think this has been spoken about enough. Stateful applications and Kubernetes is a thing, and I just want to validate that we see that here as well. It is really an upcoming space. So when we spoke with customers, there are 3 ways of operating stateful applications on Kubernetes today. The first is customers who want a lot of control. For example, if you're a customer who wants to take the Redis or the Postgres container image, run it as a stateful set, operate it this way, you get control over both the application and infrastructure. It's a complete do-it-yourself kit. And of course, with great power comes great responsibility. So there's a bunch of customers who said, yeah, I don't need this much level of control as a DIY kind of model. I want more support. And that's where Kubernetes operating model comes into the picture, which is like the second model which we heard from customers. Here, customers share responsibility between themselves and the stateful application provider. For example, if you're using Elastic, you can use ECK operator, which is an operator vended by Elastic, to kind of share the responsibility of running the app. So you get a little bit of a partially managed model when you operate in this way. And finally, we also see a large number of customers prefer managed services. Google is known for the data cloud. Similarly, there we have a large number of managed services burgeoning there. So we see, but also we see a lot of these managed services being built on Kubernetes. So what it means from an end user, you just have a database endpoint, so you exchange credentials, and everything is fully managed. But underneath the hood on Kubernetes, it is a large multi-tenant stateful application. So then we double click and ask customers, why are you running these apps on Kubernetes? The DIY customers who are running a lot of the infrastructure themselves and the app, it came down to 3 reasons. The first is we take this for granted, but relative to VMs, Kubernetes gives you a lot of out-of-the-box capabilities. For instance, we spoke to an internal SRE team here at Google, and they get a lot of stateful primitives, CI/CD, managed Prometheus. All of this comes out of the box with Kubernetes, and it's something which they really benefit from in their day-to-day operations. The second is actually really important, organizational gravity. I'm just going to use an analogy here. Just like the sun bends space-time and gains a lot of gravity and attracts planets into its orbit. Similarly, what we see and hear from customers is as Kubernetes gains a lot of organizational gravity, customers actually want to kind of consolidate their operational practices between stateful and stateless app and use Kubernetes to kind of operate both apps to prevent silos in their organization. And finally, just like the stock today, there's a burgeoning ecosystem which is building and developing around Kubernetes and stateful applications. So we hear from a lot of customers, they want to benefit from this as well. Why do the SaaS customers choose Kubernetes? I think the first one is obvious, but also really important is SaaS customers need to run in a multi-cloud infrastructure setting, and Kubernetes really enables that, and we at Google really want to support them. The second is these SaaS customers, if you think about it, are some of the most managed services for data. and they really want to build on modern internals, and they don't want to build all of this on VMs themselves. So running on Kubernetes actually gives them a lot out of the box so that they can kind of modernize their applications. And finally, last but not the least, empathy, of course, because a lot of people, everybody is running Kubernetes nowadays. So it gives these SaaS customers a kind of a vocabulary to kind of speak with their customers in shared vocabulary and build a little bit of empathy. So we've taken a look at, the value proposition of why customers run stateful applications in Kubernetes and how we observe it as Google. Now we're going to take a little bit of, what we hear from customers at the pain point and how we're structuring a roadmap to really improve the quality of life of these applications. The customer feedback boiled down into three main areas. The first is stateful Kubernetes actually churns nodes a lot, and this is for the better of the entire system because there's scaling, there's patching, there's all of these data operations which is being done at a very fast pace in Kubernetes, which is great for security patches, for being a modern application. But of course, some of these stateful apps are not kind of architected to that kind of level of churn. So customers said they need a lot of safety controls in order to have peace of mind while operating their stateful apps on Kubernetes. The second piece we heard from customers is to run a stateful application well on Kubernetes today, you actually need to daisy chain a bunch of different YAML. And what customers are more looking for is built-in primitives to Kubernetes, and that's where they see there's a lot of value. And finally, storage itself is something customers want fulfilled behind the Kubernetes API. There's CSI, of course, has been around for a while, but customers see opportunity to improve this further in terms of how storage works with containers. So we work backwards from that feedback. There's two layers here. The first layer is essentially the orchestration layer where we can build in some of these safety controls, some of these data protection controls, observability, and also work with the OSS community to make Kubernetes more stateful friendly. And of course, the second layer is actually the storage layer where we work at the storage primitives to kind of make them more container friendly, whether it's block, file, or even local storage if you need. Double clicking on a few of these at the first layer, which I presented. Backup is becoming a big thing in Kubernetes today. We're working with the community as well as we have features out of the box for you to back up Kubernetes today on GKE. And I'm sure you can use partner tools as well. All of them work on GKE today. And this gives you out of the box granular control to back up your data. And it kind of assuages customers' concerns of that peace of mind value proposition. And the use cases here are typical in terms of rollback, zonal failures, of course, upgrades, and of course, compliance, archival for compliance purposes. The second part of the layer of stateful orchestration is coming to upgrades. What we learned from customers is PDB is not optional when it comes to stateful applications. PDB are pod disruption budgets, which allows Kubernetes to kind of account for how much disruption your application can handle. So we see a lot of customers using that. And also we see a lot of customers be successful by using some of the built-in capabilities that their cloud provider offers. Like for example, at Google, you get built-in blue-green and maintenance and exclusion windows. So you get cloud providers provide some of these. So definitely make sure you leverage some of them for your stateful apps. And then, of course, observability is a big deal in terms of customers wanting out-of-the-box Prometheus. I think Prometheus, as we also learned in some of these other talks, is there's so much value in seeing both the app and the storage metrics all in one stack. So Prometheus really enables that. And we also see customers want more and more simplicity with solutions like Autopilot to really simplify their quality of life while operating stateful applications. And finally, at the storage layer, there's not much here in terms of we are really working on making storage work seamlessly for you so that you don't have to focus on the details. And we are building integrations, whether it's Cloud File Store for your content management, persistent disk for your database, local SSD or instance store or any sort of local storage for your AI/ML apps or your caches. That is layers where we're working across in the community as well as internally to make it better for customers. So what are the takeaways? The takeaways, what we really learned from customers is the first is day 2 ops is actually a day 1 consideration. We see customers who are most successful are the ones who actually consider their decisions on data protection, on pod disruption budgets, on how they view their observability. All of these decisions made on day one, because they reap their benefits on day two by day two ops becoming a no ops. So that is definitely important for your stateful apps. Second is storage. What we see from customers is there are a lot of storage selection. A lot of customers do use the defaults, but there is a lot of other storage classes out there. So figure out what really fits well for your application, whether it's AI/ML, a content management system, or a database. Third is, of course, you want to actually think about how much control you need, whether you actually want to DIY an application yourself or use a SaaS and benefit from everything managed. And finally, I think this is where we see like Kubernetes and even the managed Kubernetes from a cloud provider really change the narrative from Kubernetes not being ready for stateful to Kubernetes becoming a platform for modern stateful applications. We've seen the narrative really being changed. As I'm going to hand it over to Peter, who's going to talk about MariaDB, who's built their SaaS on Kubernetes, and who's going to walk through a demo on how we're working with the open source community to make the quality of life of stateful applications better. Peter, you want to take over?
Sure, yeah. Let me just pull these slides up. So let's talk through a case study of a customer that chose Kubernetes. So MariaDB emerged in 2009 when databases ran on virtual machines or bare metal and Kubernetes didn't exist. And MariaDB revolutionized their architecture using Kubernetes to build a modern SaaS platform for their customers. By leveraging automation that Kubernetes provides, MariaDB is able to reach massive scale and high availability with SkySQL. And the SkySQL is a SaaS platform globally available in 29 cloud regions and supports multi-cloud and hybrid cloud environments. So how did MariaDB build SkySQL? Well, just as MariaDB's customers rely on MariaDB to reduce database complexity, MariaDB relies on GKE to reduce their Kubernetes complexity and infrastructure complexity. And all of the core components of SkySQL are deployed in GKE, and MariaDB's services are also deployed in Kubernetes clusters. So MariaDB is both a customer of Kubernetes and a vendor. And let me capture a few of their highlights of why they chose Kubernetes in their own words. So number one, multi-cloud and hybrid cloud flexibility. The ubiquity of having Kubernetes enables SkySQL to be delivered to end users across clouds. Modern orchestration. This gives MariaDB the ability to have built-in automation, self-healing of their infrastructure, and safely manage SkySQL at scale. And as Akshay pointed out, empathy. Kubernetes puts MariaDB on the same plane as their customers, as they're used to using the same API. As their customers are familiar with Kubernetes, MariaDB is also using Kubernetes on a day-to-day basis to manage their infrastructure, so they can build bridges to their customers through that interface. So what are we working on? We see customers looking for built-in safe operations on Kubernetes. And one example that is a pain point, stateful workloads, is upgrades. We've seen a lot of customers find challenges in managing upgrades, especially control plane upgrades, and as they're a one-way door. Kubernetes control plane upgrades don't support rollback. This has been an open issue for many years, and it's been challenging to solve. So the community hasn't actually tackled control plane version rollback. And we've seen customers move stateful sets across clusters to gain the added safety of having this option to roll back to a previously known safe control plane version. We've also seen customers wanting the flexibility of moving stateful workloads across clusters, whether it's for cluster rebalancing, maybe they reach capacity limits, or due to feature changes, they want to move to a cluster that has a different feature set or different configuration. And doing this today is a major challenge. There's multiple considerations, as we've seen in some of the other talks about multi-cluster. There's network to manage, there's orchestration to manage, there's storage to manage. As much as we'd like the world to be about Chapter 7 in Jeff's talk, everybody's using object storage that's globally available. It's not the reality today. a lot of workloads are using block level storage and disk level storage. So with that in mind, I'm going to roll a demo. We're working on a new building block for Kubernetes to enable these safer operations, and one of the building blocks is a new KEP we've introduced in alpha for 126, so targeting 126, and it adds greater control over stateful sets. So it enables a stateful set to be split up across clusters to gain finer-grained control during a migration. So let me roll the demo, and I'll kind of talk about what's going on and some of the building blocks in play. So let's see here. So I'll just preface this. On the bottom left, we have a cluster that's running Redis, 6 nodes, or 6 pods, sorry. On the right screen, we have the cluster that we're going to migrate this workload to. Currently, there's no relevant objects in it. The top left, we have the success metrics for Redis commit log. And on the right, we have a locust load test that we're going to generate traffic against this instance and see that it maintains availability during migration. So this is rolling at 2x speed. And we kick off the load test. Immediately we see the disk references move over. So these clusters are in the same zone. We're able to reference the same disks as long as we have relevant resources in the same zones. And now we're using this building block that we've introduced to move replicas over. So we're taking replicas one by one and spinning them up in the new cluster, so creating a new stateful set object, creating new data references using PV, PVC, migrating over config maps, and using the ordinals to orchestrate which slice of the stateful set is going to be moved to a new cluster. And this migration, it uses readiness gates, and it uses the readiness conditions of a pod, and also the stateful set, so managing ready replicas and replicas as part of the stateful set API to know when it's safe to move replicas over. So if you encounter an issue in new control plane where replicas don't start up successfully, you can pause migration, you can roll back migration, and migration won't proceed unless it's safe to do. So we can start seeing traffic from some of the existing pods start to drop, and traffic start to spike from some of the new replicas. We see the yellow line in the top left corner. That's starting to ramp up as DNS propagations occur for the client. And we can see, our request per second stays relatively constant during this migration. So we're still maintaining a base level of availability. Okay, so with that, we're going to close it out. If you find this topic interesting, multi-cluster migration, QR code is a link to a talk that I'll be giving on Wednesday with Matt Schallert of Chronosphere, where we showcase this migration of Chronosphere's M3DB database. And yeah, date and time there, but thank you all for coming out, and any questions, you can open the floor.
We got time for one and one only question. We also do have time for a big round of applause for Peter and Akshay.
Thank you very much for joining this session. During
Got
this
any
talk,
questions?
I'm going to show what...
Going once, going twice. All right, well, you got all the info right there. Check out the talk on Wednesday. Definitely going to be good. I'm going to try my best. But I will have some difficulty because we'll be at the DoK booth, and you're all invited to come check us out there, too. We'll be rapping in person. We'll be wearing costumes and doing lots of cool stuff. But thank you very much, Peter. Absolute pleasure. All right? Cheers. Awesome. Let's give him another round of applause. Next up. Oh, we got to get a picture with the horn. Well, oh, and if he's on stage.
I need to crouch down.
No, I'll be here, and then we'll make you even taller. Oh, wow. Oh man, this is good. This is good. Thank you, Peter. Good. Awesome. This is good. Next up, we've got a talk from a wonderful person from Red Hat. It's pre-recorded, so if we can roll that video, we should be good to go. We got his Twitter name down here as well.
Thank you very much for
anyway,
joining this session. During this talk, I'm going to show what are the main. So, as you already mentioned, what we are going to cover during this session, how to build an event streams pipeline, and what are the challenges that you are facing during the build of this application. So the first problem that you're facing is always about ingesting the events reliably. So you have a source from where your events, your data are coming. You want to ingest all this data with high throughput, low latency, without losing events, so in a reliable manner. And for this reason, I can say that Apache Kafka is the most used, the most important data streaming platform for that purpose. On the other side, then you want to integrate different systems, because it's possible that the source and the destination of your pipeline are not able to talk the Kafka protocol. So in this example, data are coming from UDP, and you want to put them in Kafka. For this reason, the simpler solution is about using the Apache Camel integration framework, as we'll see. The third step is about applying and running some real-time processing on the events, because you want to get insights in real time on the data that are flowing through the pipeline. You want to make decisions in real time, and the Kafka Streams API can be used for this purpose. Finally, you want to show your data on some dashboards, for example. And the most used solution for that is Grafana, backed by InfluxDB as a data source where we will move the data from Kafka. Finally, we want to run all this solution, all these pieces somewhere, so we are going to use Kubernetes for running the applications and deploying the Kafka cluster using Streamz. So let's see the overall solution, the overall picture of this project. On one side, as I already mentioned, we are getting Formula 1 telemetry data. Of course, we don't have real Formula 1 cars, but we can use the Formula 1 game running on Xbox or any other platform, which is able to send the telemetry data in real time while you are playing on UDP port. So the first problem we have is about reading from UDP and moving this data to Kafka, which is running on Kubernetes in the cloud. Apache Camel, as an integration framework, allows you to write a simple application with simple routes using a DSL language in order to read from a source, write to a destination in a really simple way, as we'll see. When the data are ingested in Kafka, we want to run a Kafka Streams API application for doing some real-time processing. In this case, the simple example is average speed in the last 5 seconds for all the drivers. Then we want to show this data in Grafana. Because Grafana doesn't have Kafka natively as a data source, we are moving this data still using Camel, using as Kafka as source, InfluxDB as destination, so as a time series database, where all the data points are then used by Grafana for showing the data in real time on multiple dashboards. Let's take a look at all these pieces that are making this solution. The first one that I want to mention is Streamz. Streamz is a CNCF project since 2019. It's a project based on the operator pattern, which extends the Kubernetes API with some Kafka-related CRDs. So it means that when you deploy Streamz as an operator, you also get Kafka as a native custom resource in Kubernetes. So you have pods, deployment, stateful set, but even a Kafka custom resource, where you can set all the information, then the operator will take care of it and will start the deployment of your Kafka cluster. But you can also handle the configuration of everything on all the brokers, the security aspects, even handling the updates, so the rolling updates of the brokers with the new Kafka versions, or updating parameters and configurations, things like that. But it's not also about this, but even handling the topics and the users. So in a Kubernetes native way, you can create topic with a Kafka topic custom resource. You can create users with a Kafka user resource. So you have to deal with the Kubernetes resources, not more Kafka tools for handling all of this. It's not just about Kafka, but an entire ecosystem around Kafka. So you can deploy even Kafka Connect, Mirror Maker 2, but there is also support for cruise control, for running SAR rebalancing of your topic partitions across the cluster, HTTP bridge for having an HTTP endpoint and accessing, for example, from mobile application, the Kafka cluster, and then OAuth for authentication, Canary for checking the working status of your cluster, and so on. Then let's move to the first step, which is about moving the telemetry data from UDP to Kafka. As I mentioned, Apache Camel. Apache Camel as an integration framework provides you a DSL for writing your route, where you can specify the source, the destination. You can just apply simple configuration for that. So what is the source? In this case, UDP by using netty. Then what's the destination, which is Kafka. So you can configure the route by specifying the bootstrap service in Kafka, the destination topics and things like that. And then Camel will take care for you, running the route and moving the data. In this case, the telemetry data are moved to 3 different topics in Kafka. The first one is just moving the raw packets, so it will be a route like from to directly to Kafka. Then we can apply on the route different operations like filtering, mapping, and so on. So we are getting in some events from the telemetry data like the speed trap and lap data. And so we can apply the filter on the events. And then we are aggregating data across all the drivers, because the telemetry data are coming from the Xbox game, not per driver, but in a different way. So we are aggregating and writing the data to a specific driver's topic, so that we will have for each message where the driver ID is the key, the information related to that driver in terms of speed, engine revolutions, and all this kind of stuff that we can have in Formula One telemetry. When the data are in Kafka, then we want to run some real-time processing. Kafka Streams API can be used for that, a simple application which is getting the data from a Kafka topic, in this case the telemetry drivers. It's processing, as an example, the average speed for all the drivers in the last 5 seconds and writing to a destination topic, the average speed topic. The last step is about showing this data in real time on Grafana dashboard. So we have first to copy the data in InfluxDB as a data source for Grafana. So again, a Camel application where the source will be Kafka. You can configure the destination as InfluxDB tables, and then reading from these 3 different topics, the drivers, the average speeds, and the events, the Camel application is just applying a process method in order to transform the Kafka message in data point to write into InfluxDB. So all the information about telemetry, the motion, the car status, the average speed, the fastest lap, and the speed trap as events. Now, say that, let's see all this kind of stuff in action. As you already mentioned, we are using Grafana for showing the telemetry data. So here I have 3 different dashboards that we will see be filled by data in a few. And the most important part, let's switch to the Kubernetes cluster. In this Kubernetes cluster, I have, first of all, the StreamZ cluster operator, which I used for deploying my Kafka cluster, made by 3 Kafka brokers and 3 zookeepers. Also, the cluster operator deploy another operator, which is called the entity operator, which is in charge, as I already mentioned before, to handle the topics and the users in a Kubernetes native way. Then I also deployed Grafana and InfluxDB. And for showing the Grafana dashboards, I'm just port forwarding from the Kubernetes cluster. Then we have the 2 main F1 telemetry applications, The one about processing the data in real time, so the stream's average speed application, and the other one about moving the data from Kafka to InfluxDB for Grafana. Of course, the application that is in charge to move the telemetry data from UDP to Kafka cannot run on this cluster, but it's running locally because it's getting the packets from UDP and then sending them to the Kubernetes cluster running in the cloud. Now, because right now I don't have the Xbox running, I don't have the Formula 1 game running, I'm going to use some data that are already stored in a SQLite DB. So there is a Python script that is able to listen on UDP, and while you are playing your Xbox, getting this data from UDP and storing them in a SQLite database, so that you are able to reply all these events as they are coming from the Xbox. So I'm running this player, the Formula 1 2022 Miami Grand Prix simulated on the game before, and it's just going to read all the records from the SQLite DB and sending them to UDP. So we are just emulating what's happening when you are playing the real game, where the packets are coming, as I already mentioned, from UDP. So let's start the player. It's going to send these packets. We'll see soon, for example, 500 packages sends and so on. Now let's move to our Grafana dashboard. We will see here that the Grafana dashboard are going to be filled by all this data. So they are coming from the application running on my laptop. They are ingested by Kafka and then through the Camel application moved from Kafka to InfluxDB and showed by Grafana. Here, all this kind of information for all the drivers, speed, engine revolutions, the G-force, the damage on the wings. So there are a lot of telemetry data coming, speed trap and fastest lap as events. There are no events right now, but the process is still happening, right? The other dashboard is showing information for each driver. So you can select one of the driver here. I selected Charles Leclerc, and you can see some different information overlapped because it's in general really useful for a Formula 1 telemetry engineer to correlate telemetry data on different graphs but overlapped so that he can kind of see the correlation between engine and speed, throttle and brake, and here more information about the brakes temperature, the steering, the G-force, when there is an accident, for example, or acceleration, or information about the tires, the temperature, the damage on the tires, and so on. The last piece is about the Kafka Streams API application, which is processing the average speed in the last 5 seconds. As you can see here, there are some drops in the graph because we are using a so-called tumbling window where it's getting sampling for the last 5 seconds, processing the average data, and then the samplings are just throughout. So for the next 5 seconds in a new windows, new samplings will be used for processing the average speed. So it's not a sliding window where all the sampling are used for, or the samples are used for the new coming window, but it's a so-called tumbling window. But it's processing and showing you what are the different average speed for all the drivers. So this is the solution actually in action. Let's back to the presentation, and here's some resources. So the link to the Kafka project, where you can find all the information for running this solution on Kubernetes, the decoding library, which is used by the project for decoding the UDP coming from the game. There is also a video on YouTube about my son playing the actual game, so you can see the game running and at the same time the Grafana dashboards as we just saw right now. And there is also a blog post that I wrote for the Grafana community showing what I already showed you during this talk. So thank you very much for joining. I do really hope that you enjoyed this talk. And if you have any kind of questions on this project, just ask and ping me, for example, on Twitter. The Twitter account is Pipatierno, and I will answer absolutely. So thank you very much, and have a nice day on Data on Kubernetes Community Day.
Fantastic. Thank you very much, Paolo. Let's give him a round of applause. Very, very good talk, very practical, hands-on. And as he mentioned, check him out on Twitter. He's also in the DoK Slack if you have questions. And we should definitely get his opinion about pizza. I think we need to have a DoK day that's just focused on pizza the next time. That's going to be very important. Now, we've got our panel. So I'd like to invite all of our panelists up to the front. And if we can throw up the slides for the last talk, that would be fantastic. We have multiple people, multiple microphones. You want to do this sitting, standing, the other panelist standing? Standing room only. On stage, off stage, half on, half off, whatever you want to do. Absolutely. I will start out by saying that the only person in this community to have ever done an impersonation of me is this wonderful human, Lisa, right here, and she did a fantastic job in the last DoK day. But
you cut your hair now. We don't
it was about time. I think everybody else has got a microphone.
You guys should get on the stage.
Okay, cool. We're just going to get the slides up and running on there. So we know. Yep. 1 second. We can all take a deep breath. How's everybody doing?
Cheers.
We're there. We're good. We're good. We're good. We're good. This was a subject that was touched on earlier in the day in Holden's talk. And obviously, I am not the authority here on the subject, which is why we have these fantastic people that all form part of our community. But wow, another DoK day, almost coming to the end, finishing strong. There we go. Now you can get in order, like the usual suspects. That's kind of good.
Oh, how funny.
And
I put these up so randomly. Oh no, sorry, I thought we changed that out. There is a version of this slide that doesn't say that Melissa's hiring, but since the cat's out of the bag, Melissa's hiring. But anyway, and Bart, stop underselling yourself. Everybody is an authority on this subject more than you know, and everybody has a role to play on this topic. So our talk is called Data-Driven Diversity, Equity, and Inclusion. So first of all, show of hands, who has downloaded and read the Data on Kubernetes report, the 2022 report that has just been released? Okay, you did not
good job.
pitch your report enough today, because this is a very important data set. And you have a lot of experts here who are really familiar with this data, Patrick included, a bunch of folks in the community who have been talking about this for a while. And so we wanted to bring in some of the data from the report and talk about really where it can fit in and help us out with diversity, equity, and inclusion. And of course, for those of you that saw, many of us did this talk at the last DoK day, and we really dove into the equity part of it, because if you're talking about D&I and you're not talking about DE&I, you're really not talking about the accountability part, the wage gap. So we drilled into that a lot, and so we probably won't do that today because we only have 15 minutes, but go back to the last DoK day and you can check out our talk then. We really had a lot more time to get into it. And then I think we did a follow-up as well, which was like a whole DoK webinar on it. So check those resources out. But in the meantime, I think we want to start with, did everyone see Holden's talk earlier today? Is Holden still here? Oh my gosh, it was honestly probably my favorite talk of the day. Holden's talk was about Spark and Yarn and nothing to do with bias, but I love how she started her talk with a slide about bias and saying, here's my bias that's written, unwritten into my talk and gets written into my data because these are the biases that I have, and these are what you should know about, including the fact that she loves her dog. And it was fantastic to see all the dog pictures. But we really, I thought that was a nice tie-in to now the end of the day, where we're talking about bias that gets into data unconsciously or even sometimes consciously. So let's start with the Data on Kubernetes report. One of the things that it talked about, the second thing, pain point, I guess, the first was security, but the second pain point was the talent, or lack of talent, whether it's writing operators, Kubernetes operators, or just hiring, and because you're building your own, you basically need to have, if you're a car company, all of a sudden 20,000 software engineers also, and now they all have to be Kubernetes experts, right? And who has that? So you see all of these industries trying to hire. So I would love to hear Melissa talk a little bit about that skills gap that's causing, and also the employment opportunity that's bringing us.
Yeah, absolutely. So if you haven't seen the Data on Kubernetes report, please download it. It's on our website. The stat that Lisa is talking about is, in this report this year, organizations are adopting Kubernetes, data on Kubernetes like crazy. And the number 2 challenge that they identified was a lack of qualified talent. And this gives a lot of people an opportunity to build skills around DoK, join the community, and find employment. And the pairing with that, another data point in our survey that connected was 41% of them are looking to hire or reskill in the next 3 to 6 months. So there is a huge need for data on Kubernetes skill set now, and will be in the future as these things continue to grow. One of the key ways that women and other underrepresented minorities can participate in learning skills like this is community. Open source is all about people. Technology is all about people. The way you can connect with people is in communities like ours, in communities like Kubernetes. It's a way to, as Holden said earlier, she's hiring. I'm guessing a number of other people in this room are hiring. In open source, in communities, is a great way to make connection with peers and other folks globally around the world who can help advance your career. And I'm curious, with the rest of this group, we're all in different communities. What's been your experience with communities? Have you seen that be a path to career growth?
For me personally, it has been my path.
Wait, Courtney, I don't think your mic is on. Was Courtney's mic on? Could you hear her?
She's got louder. Oh, is that better? Yes. Yeah, okay, speaking up. So for me personally, community was a total path to career growth in tech. I do not come from a technical background, and I jumped into tech specifically through community, and it's been a fantastic journey so far. But especially for anyone who is not tech background oriented, it can be a daunting journey, and I mean, I personally really struggled with my own insecurities about whether I'd be able to understand the people that I was talking to. And communities are a fantastic place to get past that insecurity that can arise when you don't have a computer science background, obviously. So for me, this is starting with Data on Kubernetes community and moving now into a DevRel role for a startup. My personal professional growth in this industry has been spectacular thanks to community.
And we just have to do one thing, because I love how Courtney says she's not a technical person. She just completed the CK8 course today and has the button and has got the certificate. Can we give her a round of applause? She did that today. Yes. Yes. All right, now that I've thoroughly embarrassed her. Okay. Also, one of the talks earlier today was talking a little bit about ML and AI, and this is a place where a lot of bias gets written into technology. It might be machine learning, but it was still created by human beings, and there's a whole bunch of ethics questions around this. So luckily, we have a data scientist expert up here. So I want to ask Tiffany to talk to us a little bit about what's going on with bias in ML and AI.
Yeah, I would love to share more. And I love what Courtney said about community, because that's such a big thing for us as well in machine learning. I think there's a lot that people don't know about data science and building data product teams, especially because it's somewhat of an uncharted territory in industry. And the more that you can contribute back to the community, or at least be able to share what you're doing, the more transparent it becomes. And so you don't have all these questions about, like, why is this? Well, you'll still have those questions, but you'll begin to have a more curious approach to how can you edit and make models better, because a lot of times we're building these software solutions and we deploy them with the thought that, like, this is going to be it, this is the solution. And in machine learning and data, in that data world, the data changes, right? And then the patterns change, and we see that a lot. And you have to be willing to, when you put something out in production, be willing to look at that again and see if there are biases and see how it impacts people, because I think that's a really big part of that AI, ML, data science lifecycle that we can bring into and borrow from, like practice-wise, from the community.
And Audrey, you have done some work in this area as well and had some thoughts to share with us.
Yeah, so I'm a producer of Open Source Data podcast where we had Professor David Danks. He's a computer science and philosophy professor from UC San Diego and has done extensive research in computational cognitive science. And what he touches on is starting with ethics from when people are students, right? So a lot of the issues that we're finding or that he's seeing is the people and their core values. Ethics is super basic, and he gave an example of, if you're driving to a meeting and you're going to be late, are you going to race and not abide by the law, or are you going to be on time to your meeting? And so those inner conflicts are what we deal with daily. And the point being is that we need to bring those core values with us to work and have these ethical conversations when we have dilemmas come up. And it doesn't need to be a whiteboard, it just is being brave enough to mention it to your colleagues in a group setting.
Yeah, another thing that is creating this skills gap is the fact that during the pandemic, a lot of women left the workforce in tech and have not come back, right? We've seen a lot of data on this for various reasons. And we used to talk about this because we all tried to build inclusive communities and where people don't only join but stay. But now we have people leaving for completely different reasons. And that skills gap, especially with underrepresented minorities, grew because of personal situations. And so if you came from privilege and you could have higher daycare or had computers in your house already, or just lots and lots of reasons why there's a lot of people that struggled a lot more during the pandemic than some of us that are very privileged and fortunate. And so we just heard that 41% of the companies are hiring within 3 to 6 months for this particular technology skill, and that's in a recession when a lot of companies are doing layoffs, right? Or recession, not recession, whatever we're in. But so how are we going to get with the challenges that a lot of people still have, and we were just having an interesting discussion about who is working from home, who is coming back to the office, and Kim brought up some good points about if the women are staying home because we can work from home, because the kids are back in daycare, is that causing clicks in the office? Like what networking is happening? So I would love to hear, whoever wants to jump in on that, and maybe Melissa, you want to start just talking about how we're going to bridge that skills gap.
Well, it's interesting. I've read a few different studies and listened to a lot of different research on how can you keep women and underrepresented minorities in the workforce. And there are a lot of different ways to do this. Many of them start organizationally, where can you provide things like daycare, paternity leave, maternity leave, things like this that enable people to have a work life, have work and life balance. And I think we need to, if you run an organization or are in creating these types of policies for an organization, really think about that, because this is a way you will get and retain people in your workforce. So that type of research, we need more of that in this world.
And where would you suggest people start? Like when it's coming to hiring, people say, well, it's a pipeline problem, and there's a few of us that just refuse to let you off the hook for saying it's a pipeline problem, right? So where would you recommend that we start to solve this problem? Anyone who wants to jump in on this? I mean, is it in the schools? Are we looking in the wrong place? Are we training in the wrong place? I love the program Bart is constantly shouting out about technology skills in prisons, within incarcerated staff. So when the incarcerated people come out of prison, they can go straight into tech jobs. It's an amazing program that the DoK has supported from the very beginning. In every single webinar that you do and every live stream, Bart makes sure that some money goes to this organization, which, the Last Mile, is that what it's called? Yeah. Amazing organization. So we need more of that, right? So how do we make more of that happen?
If I may, Bart actually has this awesome idea that I'm trying to elevate at the Kubernetes Community Days program that I run with CNCF. And It's called CNCF Firsts. And so what we're trying to do is elevate voices that would normally get rejected at a KubeCon, for example. And so part of that is becoming a mentor. So perhaps the ambassador program that we have includes that. And yeah, if you just give people that, that skill set in their back pocket and elevate them, then the confidence is there. And then part of that is expanding your network, which goes back to the community question. And it really is all about who you know. So make your network fast if you can.
Go ahead, David.
Yeah, I would echo what Audra and Melissa said about starting with opportunities. And I don't think that there's one like golden solution. Like the best that anyone can really do is start where they are and with what you have. And that can be something as simple as like offering to mentor someone or offering to write a blog post that can help, that's geared towards someone who's just starting out, you know, or sharing your experiences as a data engineer or as a data scientist. I think small things like that can help inspire people to take their journey to the next step, especially when they are like overcome by a lot of challenges that like a lot of us like who are in tech now, we've kind of solved for some of those things, or we don't think about them as much because, you know, that's sort of after the fact, right? But for the folks that are just like waiting for that one opportunity or that one reason to stay in tech for another day, you know, a big difference can just be you reaching out to them or you saying like, hey, I noticed that you're new to this, or you're just learning or just starting out, like, how can I help? Or I'm happy to be a resource. And it can be something as simple as like a LinkedIn request, and you can help sort of be a mentor or even just a leader for those people to understand that there may be a path for them.
And I would say also, I had this experience with Melissa in the Data on Kubernetes community. I was like, Melissa, I really want to stay in this industry. I'm not really sure what my skill set can do or where I can fit in. And she said, well, why don't we have a 15, 30-minute call and talk about it? Those very small things, yes, time is of the essence. Nobody has enough of it. But the 15, 30-minute call with somebody who is taking an interest and just doesn't know where to go is priceless. That call, frankly, made a huge difference for me in understanding what my skill sets were in the tech industry, not in a different one. So sometimes mentoring happens without you even realizing that you're doing it. You're just being helpful and kind, and kindness makes the world turn. So personally, I think that is something that everyone can proactively do. And one of the other things that I always think is very cool is when I come across a tool that has documentation that's definitely developer first, but not always experienced developer first, that has some sort of entry point where somebody who's just getting started can actually understand what's going to go on and walks a very beginner level through, or has a link to a YouTube video where somebody gives a very beginner tutorial. These are things that are super helpful, not just to people who are just starting out, but sometimes to people who are transitioning from development into DevOps, for example, and they're learning operations and they really don't have any experience there. So those types of actions are small but very impactful.
And I'll just make an offer. If anybody wants to talk about how you can get started in DoK, please reach out to myself. And I am guessing anyone on this panel would be okay with that as well.
Absolutely. Bart has started this first speaker initiative as well and challenged everybody. Bart and I are also CNCF ambassadors and challenged all the CNCF ambassadors, most of us who run pretty large user groups, to reach out and find the first-time speakers, those folks who have never given talks before, especially from an underrepresented group. And it's not hard to do. I mean, we've both just like done it multiple times in the past month. So you can do this. You have to be deliberate about it. Courtney just texted her manager and it was like, hey, you know, we're from a pretty diverse company and I'm from a pretty diverse company, and like, hey, you know, let's talk about how we did this. And I'm sorry if I'm putting you on the spot, but her manager was very sweet, and he was like, oh, I don't really want to brag about that. And I was like, that's it's not bragging, but if we're not deliberate about this and talking about how we do it, it's not going to happen, right? This is not, obviously, because we haven't been deliberate about it, and that's how we got in the position that we're in. So if you're not deliberate about this, and if you have something to share, then, you know, by all means, please share it and talk amongst your friends, and let's hold everybody accountable for this. One other thing about the report that I thought was really interesting, and then Bart, I don't know if you want us to take questions or if you want us, I know we're keeping you from beverages, so I'm aware of that. But one other thing I'll say about the report, because I really do want everybody to look at the data in this report. The folks did a great job putting it together. It is accessible to you as part of DoC, Data on Kubernetes community members. But one of the things they did is tying it back to like production Kubernetes workloads and the productivity and finances, quite frankly, that come out of that, the economics of it. And a lot of the early adopters are showing a lot of profitability from running these stateful workloads in Kubernetes. And it kind of made me thinking about the concept of generational wealth. You know, you hear people talk about this. This is a real thing, especially in the United States, because, you know, if you don't own a home or you can't have family that passes things down, if you don't get that starting point to have a head start, the gap is so hard to overcome. And so you see this, you know, between the haves and the have-nots, and a lot of it comes from generational wealth. And we have the same thing in technology. So if you think about the companies that came in early, and, you know, adopted Kubernetes and started running stateful workloads on Kubernetes, you can see in this report how well they're doing now. So my point here is about lending privilege, and what we're all trying to say is, if you are one of those fortunate companies and you are profitable because of this thing you figured out how to do, help people along. Like, there's a lot of learning, there's a lot of gap filling that we need to have happen, but it has to happen deliberately. So lend that privilege, you know, give that education, figure out how to bring someone along who's going to be, who's not clearly represented today in this skills gap that we've been talking about. Any more thoughts on that? I don't know if someone can say that a little more clearly than I just kind of mumbled that out, but all the data's in the report, but I'm just giving you another way to think about some of that data.
That's great. Thank you for talking about it.
Oh, okay. Any questions from the audience? Otherwise, Bart is going to run up here with a horn and start taking photos. So, or start rapping or doing something. Any questions? We're also happy to take this conversation across the street. Is that where we're going? Amber Bar, maybe? Anchor Bar, sorry. Anyway, it's a really interesting report, and we are happy to talk more about it in the lobby, wherever you run into us. But, uh-oh, here it comes. Is it time? Okay.
We're not at the very, very end because I think you've all seen us with these super cool t-shirts that we have run DoK. And now you have a chance to win one. So we're going to change laptops and get our quiz up and running. So be prepared to answer some very challenging trivia questions. Before we do that, though, we have a lot of people to thank for making today possible. I said it in the beginning to the streaming team. I was like, I'm sure by the end of the day you're going to want to kill me. But because I'm very creative, I did that in the beginning of the day, and I think now we're actually pretty chill. So I want to give a huge shout out to all the folks that have been helping us on the technical side, sound, camera, and wonderful people that are hidden in a room back there like the Wizard of Oz. Can we give them a round of applause? That's a very underappreciated job. It's a it's a tough thing to do, and they've been very patient and flexible with us, and we really, really appreciate that. So that being said, you need to go to menti.com, all right, take out your phones or laptops or whatever you prefer, and we need you to enter the code 8499012. I'll repeat that again, it's kind of like bingo, 8499012. Got lots of folks joining, that's good. So we got 8 questions. Spoiler alert, one of the answers was just given. So yeah, anyway, so if you're paying attention, you have a safe advantage. These quizzes value, speed. So the faster you answer, the better you're going to be ranked. folks online, wherever you are, you can also be participating. The chance to win some really cool DoK swag. Good. Got all kinds of interesting things joining in there. All right. Got a ring, a donut, shamrock. Cool. A Swedish flag. Wow. This is nice. This is good. This is good. This is good. Okay. Let's still get a penguin. We got a boat. Strawberry. A bear. Wow. Okay. Good. A unicorn. Oh, unicorn left. Shy unicorn. All right. I think. Oh, we got the unicorn back. That's good. And a goat. This is cool. I think this is once again a suggestion for Halloween costumes, folks. All right, good. Okay, I think it looks like we've got our group. All right. So first question: what's the nickname for Detroit? City of Roses, Mile High City, Motor City, or Windy City? What's it gonna be? 3, 2, 1. Oh, time's up. Oh, Windy City, Chicago. Mile High City, Denver. City of Roses? Ah, sorry, been out of the US for a while. I just think of keep Portland weird. That's what I think about. All right. So, whoa. Wow. Jeff, good, well done. Question 2. What does Kubernetes mean? Oh, everybody should know this one. Here's some whispering. Folks sharing answers, that's good. Sharing is caring. Oh, all right, 46, yeah, folks got it right. Yep, Greek. No, you're a Greek. That's where we get all this stuff like Helm, manifest, stuff like that. Nautical terms. Oh, Grant was very fast. Dax was fast too. This is good. Some speed demons in the crowd. Question 3. Who is co-leading Kubernetes 6 storage? Okay, time's up. Oh, some folks were not paying attention. Yeah, Xing absolutely rocked it, all right? And is sponsored by Whole Foods. So we found out that today. All right, one not leading 6 storage. Cashing in for every mention of Whole Foods. Question 4. I'm not going to try to read that really quick. So after databases, what's it going to be? Highly contested. Ooh. Yep, go download that report, folks, and win some swag. Oh, we got some switches. Yeah. Which chapter? We had chapter 7 and chapter 11, which is not just bankruptcy. There's a lot of important information in chapter 11 about self-healing. So question 5. Very good. Lack of qualified. Oh, tough. That was mentioned. That was mentioned in the intro as well. Nobody paid attention to my intro. Nobody paid attention to my intro. It's all good. It's all love. All right. It's getting interesting. Well done. Good job, Robbie. Good job. You're getting dangerous now. Patrick. No. Oh. There were hints. We hinted. I mean, now we're balancing this out, though. Man, Robbie. Question number 7. Yeah, this is when we were polling the audience about, Pepsi or Coke, coffee or tea. And my family have an expression. Yep. Like Patrick Henry, give me decaf and give me death, I guess what we would say. Yep, but death before decaf. All righty, good. Grant was listening. Thank you, Grant. Very good. All right. Oh, this is getting intense. Question 8 of 8. This was mentioned in the last 10 minutes. And you can look for this on Google Maps next, so that's exactly where we're going to be. Aha! Good job. So 42 people. All right, we'll see 42 people. Good. Now, for the moment of truth. So what happens now? Oh, Robbie. Well done, Robbie. Well done. Well done. Very fast answers. Okay. And do we have a number 2? Number 2 would be Jeff then. No? All right, that's all we got. Robbie, where are you at? He's online. Robbie, show yourself. Show yourself in our Slack so we can send you the swag. That being said, good job, everybody. Very competitive quiz. I really like these quizzes. Once upon a time, I used to be a teacher, so it's nice to get back to these things, but not with young people that can be very difficult to deal with. That being said, we are at the end of our day. It's been a very full day, as all DoK days, but it went very, very quickly. We had a lot of talks. So nice to see so many people in person in so many ways. A, because it was the first time that we were doing it, but B, really nice to be connecting with people that maybe we've spoken to, things like that, as well as the speakers. First of all, let's actually give a big round of applause to our speakers who did a great job. All right. Really appreciate it. This stuff is tense. There's a lot of things to prepare. We've had speakers modifying talks, making changes, all that kind of stuff, different things like that, but I think we can all agree the quality was very, very good. I will say this, you can never remind people too many times not to do a vendor pitch, right? Get it tattooed. But that being said, very, very happy with the results we've achieved today. Seeing folks in person, doing it live in Detroit. We will be doing more live events. If you didn't know already, we're doing more and more local meetups. So if you're interested in setting one up in your city, please get in touch with us and let us know. We've done some in the Bay Area with Lisa and some other wonderful folks in our community. We've done several in London. We've done a couple in Istanbul. We'll be doing one in Spain when I get back in November. So like I said, lots and lots of things happening in that sense in the community. And as always, lots of action on Slack. We'll have more live streams coming up, recorded content, et cetera, et cetera. If you want to get involved, please just let us know. We're very open, committed to meeting new folks, sharing different kinds of talent. And I think with that, I think we are pretty much done. So you know where the bar is. You can find Anchor Bar. That's where we're going to be hanging out. After this, we will have a booth. So if you want to come and see what Sylvan and I will be wearing on Wednesday, please stop by. Good job, Sylvain, trying to attract more attention to himself because he knows he's going to look better than me. But anyway, we're here to have fun. Thank you so much for participating and being here with us. Thank you. Have a wonderful day.